Looking for a tech career that's fast-growing, high-paying, and super exciting? Then this Cloud and DevOps full course is just for you. The world is moving to the cloud, and businesses everywhere are adopting DevOps to build, launch, and scale software faster than ever before. That's why cloud and DevOps professionals are among the top most in-demand experts today, with salaries ranging from $80,000 to $150,000 plus, depending on skills and experience. In this course, we will start with the basics of cloud computing, what it is, why it matters, and how companies use platforms like AWS, Azure, and Google Cloud to run their operations. Then we will dive into DevOps fundamentals, understanding how development and operations come together to speed up software delivery. You'll also learn powerful tools like Docker, Kubernetes, Jenkins, and Terraform, and also explore cloud security, automation, CI/CD pipelines, and monitoring. And the best part is, you won't just learn theory. You'll get to work on hands-on projects, real-world use cases, and step-by-step guidance to build practical skills. And by the end of this course, you'll have the confidence to pursue cloud and DevOps roles, crack top certifications, and land high-paying jobs in this booming industry. So let's get started. Your future in cloud and DevOps begin right here. Before we move on, just a quick information. If you're looking to future-proof your tech career, this professional certificate program in cloud computing and DevOps by E&I City Academy, IT Guwahati is the perfect choice for you. Within 8 months, you'll gain hands-on expertise across AWS, Azure, and Google Cloud. You can master DevOps tools like Jenkins, Docker, Kubernetes, and work on 30+ real-world projects. What makes this program stand out is you'll get official Azure certifications, IIT JEEK-issued credentials, access to live masterclasses, and even a campus immersion opportunity. Plus, with AI-powered job assistance, resume building, and interview preparation, you are set up for real career growth. Whether you're upskilling or making a career switch, this program offers everything you need to thrive in the world of cloud and DevOps space. You can find the link below.
Before cloud computing existed, if we need any IT servers or application, let's say a basic web server, it does not come easy. Now here is an owner of a business, and I know you would have guessed it already that he's running a successful business by looking at the hot and fresh brewed coffee in his desk and lots of paperwork to review and approve. Now he had a smart, not only smart looking, but a really smart worker in his office called Mark. And on one fine day, he called Mark and said that he would like to do business online. In other words, he would like to take his business online, and for that he needed his own website as the first thing. And Mark puts all his knowledge together and comes up with this requirement that his boss would need lots of servers, database, and softwares to get his business online, which means a lot of investment. And Mark also adds that his boss will need to invest on acquiring technical expertise to manage the hardware and software that they will be purchasing, and also to monitor the infrastructure. And after hearing all this, his boss was close to dropping his plan to go online. But before he made a decision, he chose to check if there are any alternatives where he don't have to spend a lot of money and don't have to spend acquiring technical expertise. Now that's when Mark opened this discussion with his boss, and he explained his boss about cloud computing. And he explained his boss the same thing that I'm going to explain to you in some time now about what is cloud computing. What is cloud computing? Cloud computing is the use of a network of remote servers hosted on the internet to store, manage, and process data, rather than having all that locally and using local server for that. Cloud computing is also storing our data in the internet from anywhere and accessing our data from anywhere throughout the internet. And the companies that offer those services are called cloud providers. Cloud computing is also being able to deploy and manage our applications, services, and network throughout the globe and manage them through the web management or configuration portal. In other words, cloud computing service providers give us the ability to manage our applications and services through a global network or internet. Example of such providers are Amazon Web Service and Microsoft Azure. now that we have known what cloud computing is, let's talk about the benefits of cloud computing. Now I need to tell you, the cloud benefits is what is driving cloud adoption like anything in the recent days. If you want an IT resource or a service now with cloud, it's available for me almost instantaneously and it's ready for production almost the same time. Now this reduces the go live date and the product and the service hit the market almost instantaneously compared to the legacy environment, and because of this the companies have started to generate revenue almost the next day, if not the same day. Planning and buying the right size hardware has always been a challenge in legacy environment, and if you're not careful when doing this, we might need to live with a hardware that's undersized for the rest of our lives. With cloud, we do not buy any hardware, but we use the hardware and pay for the time we use it. If that hardware does not fit our requirement, release it and start using a better configuration and pay only for the time you use that new and better configuration. In legacy environments, forecasting demand is an full-time job, but with cloud, you can let the monitoring and automation tool to work for you and to rapidly scale up and down the resources based on the need of that hour. Not only that, the resources, services, data can be accessed from anywhere as long as we are connected to the internet. And even there are tools and techniques now available which will let you to work offline and will sync whenever the internet is available. Making sure the data is stored in durable storage and in a secure fashion is the talk of the business, and cloud answers that million-dollar question. With cloud, the data can be stored in a highly durable storage and replicated to multiple regions if you want, and the data that we store is encrypted and secured in a fashion that's beyond what we can imagine in local data centers. Now let's bleed into the discussion about the types of cloud computing. Very lately, there are multiple ways to categorize cloud computing because it's ever growing. Now we have more categories. Out of all these 6 sort of stand out, categorizing cloud based on deployments and categorizing cloud based on services. And again, under deployments, categorizing them based on how they have been implemented. Is it private, is it public, or is it hybrid? And again, categorizing them based on the service it provides. Is it infrastructure as a service, or is it platform as a service, or is it software as a service? Let's look at them one by one. Let's talk about the different types of cloud based on the deployment models first. In public cloud, everything is stored and accessed in and through the internet, and any internet users with proper permissions can be given access to some of the applications and resources. And in public cloud, we literally own nothing, be it the hardware or software. Everything is managed by the provider. AWS, Azure, and Google are some examples of public cloud. Private cloud, on the other hand, with private cloud, the infrastructure is exclusively for a single organization. The organizations can choose to run their own cloud locally or choose to outsource it to a public cloud provider as managed services. And when this is done, the service, the infrastructure will be maintained on a private network. Some examples are VMware Cloud, and some of the AWS products are very good example for private cloud. Hybrid cloud has taken things to the whole new level. With hybrid cloud, we get the benefit of both public and private cloud. Organizations will choose to keep some of their applications locally, and some of the application will be present in the cloud. One good example is NASA. It uses hybrid cloud. It uses private cloud to store sensitive data and uses public cloud to store and share data which are not sensitive or confidential. Let's now discuss about cloud based on service model. The first and the broader category is infrastructure as a service. Here we would rent the service, network, storage, and we'll pay for them in an hourly basis. But we will have access to the resources we provision, and for some we will have root level access as well. EC2 in AWS is a very good example. It's a VM for which we have root level access to the OS and admin access to the hardware. The next type of service model would be platform as a service. Now in this model, the providers will give me a pre-built platform where we can deploy our codes and our applications and they will be up and running. We only need to manage the codes and not the infrastructure. Here in software as a service, the cloud providers sell the end product, which is a software or an application, and we directly buy the software on an subscription basis. It's not the infra or the platform, but the end product or the software or a functioning application, and we pay for the hours we use the software. And in here, the client maintains full control of the software and does not maintain any equipment. Amazon and Azure also sell products that are software as service. This chart sort of explains the difference between the four models, starting from on-premises to infrastructure as a service to platform as a service to software as a service. This is self-explanatory that the resources managed by us are huge in on-premises, that towards your left as you watch, and it's little less in infrastructure as a service as we move further towards the right, and further reduced in platform as a service, and there's really nothing to manage when it comes to software as a service because we buy the software, not any infrastructure component attached to it. Now let's talk about the life cycle of the cloud computing solution. The very first thing in the life cycle of a solution or a cloud solution is to get a proper understanding of the requirement. I didn't say get the requirement, but said get a proper understanding of the requirement. It is very vital because only then we will be able to properly pick the right service offered by the provider. Getting a sound understanding, the next thing would be to define the hardware. Meaning choose the compute service that will provide the right support where you can resize the compute capacity in the cloud to run application programs. Getting a sound understanding of the requirement helps in picking the right hardware. One size does not fit all. There are different services and hardwares for different needs you might have, like EC2 if you're looking for IaaS, and Lambda if you're looking for serverless computing, and ECS that provides containerized service. So there are a lot of hardwares available. Pick the right hardware that suits your requirement. The third thing is to define the storage. Choose the appropriate storage service where you can back up your data, and a separate storage service where you can archive your data locally within the cloud or from the internet. And choose the appropriate storage. There is one separately for backup called S3, and there is one separately for archival, that's for Glacier. So knowing the difference between them really helps in picking the right service for the right kind of need. Define the network that securely delivers data, video and applications. Define and identify the network services properly. For example, VPC for network, Route 53 for DNS, and direct connection for private P2P line from your office to the AWS data center. Set up the right security services, IAM for authentication and authorization, and KMS for data encryption at rest. So there are a variety of security products available. We got to pick the right one that suits our need. And there are a variety of deployment and automation and monitoring tools that you can pick from. For example, CloudWatch is for monitoring, autoscaling is for being elastic, and CloudFormation is define the management process and tools. You can have complete control of your cloud environment if you define the management tools which monitors your AWS resources and or the custom applications running on AWS platform. There are a variety of deployment, automation and monitoring tools you can pick from, like CloudWatch for monitoring, autoscaling for automation, and CloudFormation for deployment. So knowing them will help you in defining the life cycle of the cloud computing solution properly. And similarly, there are a lot of tools for testing a process like CodeStar and CodeBuild and CodePipeline. These are tools with which you can build, test and deploy your code quickly. And finally, once everything is said and done, pick the analytics service for analyzing and visualizing the data using the analytics services, where we can start querying the data instantly and get a result. Now, if you want to visually view the happenings in your environment, you can pick Athena, and other tools for analytics are EMR, and which is Elastic MapReduce, and Cloud Search. Hello everyone, let me introduce myself as Sam, a multi-platform cloud architect and trainer, and I'm so glad and I'm equally excited to talk and walk you through this session about what AWS is, and talk to you about some services and offerings, and about how companies get benefited by migrating their applications and infra into AWS. So what's AWS? Let's talk about that. Now, before that, let's talk about how life was without any cloud provider, and in this case, how life was without AWS. So let's walk back and picture how things were back in 2000, which is not so long ago, but a lot of changes for better had happened since that time. Now, back in 2000, a request for a new server is not an happy thing at all, because a lot of money, a lot of validations, a lot of planning are involved in getting a server online or up and running. And even after we finally got the server, it's not all said and done. There's a lot of optimization that needs to be done on that server to make it worth it and get a good return on investment from that server. And even after we have optimized for a good return on investment, the work is still not done. There will often be a frequent increase and decrease in the capacity, and even news about our website getting popular and getting more hits, it's still an bittersweet experience, because now I need to add more servers to the environment, which means that it's going to cost me even more. But thanks to the present day cloud technology, if the same situation were to happen today, my new server, it's almost ready, and it's ready instantaneously. And with the swift tools and technologies that Amazon is providing in provisioning my server instantaneously and adding any type of workload on top of it and making my storage and server secure, creating a durable storage where data that I store in the cloud never gets lost, with all that features, Amazon has got our back. So let's talk about what is AWS. There are a lot of definitions for it, but I'm going to put together a simple and a precise definition as much as possible. Now, let me iron that out. Cloud still runs on an hardware, alright? And there are certain features in that infrastructure, in that cloud infrastructure, that makes cloud, or that makes AWS a cloud provider. Now, we get all the services, all the technologies, all the features, and all the benefits that we get in our local data center, like, security and compute capacity and databases. And in fact, we get even more cool features like content caching in various global locations around the planet. But again, out of all the features, the best part is that we get everything on a pay-as-we-go model. The less I use, the less I pay, and the more I use, the less I pay per unit. Very attractive, isn't it? Right? And that's not all. The applications that we provision in AWS are very reliable because they run on a reliable infrastructure, and it's very scalable because it runs on an on-demand infrastructure, and it's very flexible because of the designs and because of the design options available for me in the cloud. Let's talk about how all this happened. AWS was launched in 2002 after the Amazon, we know as the online retail store, wanted to sell their remaining or unused infrastructure as a service or as an offering for customers to buy and use it from them, sell infrastructure as a service. The idea sort of clicked, and AWS launched their first product in 2006. That's like 4 years after the idea launch. And in 2012, they held a big-sized customer event to gather inputs and concerns from customers, and they were very dedicated in making those requests happen. And that habit is still being followed. It's still being followed as reInvent by AWS. And at 2015, Amazon announced its revenue to be $4.6 billion. And in 2015 through 2016, AWS launched products and services that help migrate customer services into AWS. Well, there were products even before, but this is when a lot of focus was given on developing migrating services. And in the same year, that's in 2016, Amazon's revenue was $10 billion. And not the least, as we speak, Amazon has more than 100 products and services available for customers and get benefited from. Alright, let's talk about the services that are available in Amazon. Let's start with this product called S3. Now S3 is a great tool for internet backup, and it's the cheapest storage option in the object storage category. And not only that, the data that we put in S3 is retrievable from the internet. S3 is really cool. And we have other products like migration and data collection and data transfer products, and here we can not only collect data seamlessly but also in a real-time way monitor the data or analyze the data that's being received. That there are cool products like AWS data transfers available that helps achieve that. And then we have products like EC2, Elastic Compute Cloud. That's an resizable computer where we can anytime alter the size of the computer based on the need or based on the forecast. Then we have simple notification services, systems and tools available in Amazon to update us with notifications through email or through SMS. Now anything can be sent through email or through SMS if we use that service. It could be alarms or it could be service notifications if you want, stuff like that. And then we have some security tools like KMS, Key Management System, which uses AES 256-bit encryption to encrypt our data at rest. Then we have Lambda, a service for which we pay only for the time in seconds it takes to execute our code, and we're not paying for the infrastructure here. It's just the seconds the program is going to take to execute the code. If it's a short program, we'll be paying in milliseconds. If it's a bit bigger program, we'll be probably paying in 60 seconds or 120 seconds. But that's lot cheap, lot simple, and lots cost effective as against paying for service on an hourly basis, which a lot of other services are. Well, that's cheap, but using Lambda is a lot cheaper than that. And then we have services like Route 53, a DNS service in the cloud. And now I do not have to maintain an DNS account somewhere else and my cloud environment with AWS. I can get both in the same place. Alright, let me talk to you about how AWS makes life easier, or how companies got benefited by using AWS as their IT provider for their applications or for the infrastructure. Now, Unilever is a company, and they had a problem, right? And they had a problem and they picked AWS as a solution to their problem, right? Now, this company was sort of spread across 190 countries, and they were relying on a lot of digital marketing for promoting their products. And their existing environment, their legacy local environment, proved not to support their changing IT demands, and they could not standardize their old environment. Now, they chose to move part of their applications to AWS because they were not getting what they wanted in their local environment. And since then, rollouts were easy, provisioning new applications became easy, and even provisioning infrastructure became easy, and they were able to do all that in push button scaling. And needless to talk about backups that are safe and backups that can be securely accessed from the cloud as needed. Now, that company is growing along with AWS because of their swift speed in rolling out deployments and being able to access secure backups from various places and generate reports, and in fact useful reports out of it that helps their business. Now, on the same lines, let me also talk to you about Kellogg's and how they got benefited by using Amazon. Now, Kellogg's had a different problem. It's one of its kind. Now, their business model was very dependent on an infra that will help to analyze data really fast, right? Because they were running promotions based on the analyzed data that they get. So they being able to respond to the analyzed data as soon as possible was critical or vital in their environment. And luckily, SAP running on HANA environment is what they needed, and they picked that service in the cloud, and that sort of solved the problem. Now, the company does not have to deal with maintaining their legacy infra and maintaining their heavy compute capacity and maintaining their database locally. All that is now moved to the cloud, or they are using cloud as their IT service provider, and now they have a greater and powerful IT environment that very much complements their business.
Hi there, I'm Samuel, a multi-platform cloud architect
and I'm very excited and honored to walk you through this learning series about AWS. Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers. But prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital costs. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service. Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL, or American Online, uses AWS, and using AWS, they have been able to close data centers and decommission about 14,000 in-house and co-located servers and move mission-critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data. And they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data, and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy to use service for deploying and scaling web applications and services deployed, be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning to load balancing to auto scaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System or EFS provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files, so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic Load Balancing, it's also a network and content delivery service. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zones and also across availability zones. AWS Auto Scaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS Auto Scaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Auto scaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage. And S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we are also going to use CloudWatch for monitoring the environment. And CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well. And it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing. And now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? All right, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. All right, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL. So what did we learn? We started the session with what is AWS. We looked at features and tools, technologies, products that AWS provides. And we also looked at how AWS became very successful. Again, we looked into the benefits and features of AWS in depth. And we also looked at some of the services that AWS provides in random. And then we picked particular services and we talked about them like EC2, Elastic Beanstalk, Lightsail, Lambda, storage, stuff like that. Then we also looked at the future of AWS, what AWS holds in the store for us. We looked at that, and then finally we looked at a lab in which we created an application using Elastic Beanstalk, and all that we had to do was a couple of clicks and boom, an application was there available that was connected to the database, and that was connected to the simple notification system, that was connected to CloudWatch, that was connected to storage, stuff like that.
What is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now it's basically an online portal through which you can access and manage resources and services. Now resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched on February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure services. Now, Azure services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have ExpressRoute. Now with this, you can actually connect your on-premise network onto the Microsoft Cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have virtual network. Now with virtual network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now, this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development. It could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices, for example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines, where these services are able to provide you a large amount of storage where data can be stored.
Talk about Azure in great length and breadth. And if you're looking for a video that talks and walks you through all the services in Azure, then this could be one of the best video you could find in the internet. And without any further delay, let's get started. Everybody likes stories, so let's get started with a story. In a city not so far away, a CEO had plans to expand his company globally and called one of his IT personnel for an IT opinion. And this guy has been in the company for a long time and is very seasoned with the company's infra. And he nicely answered the questions with what he foresaw. And he said, I have a good news and a bad news for us to go global. And he starts with the good news. He said, Sir, we're well on our way to become one of the world's largest shipping company. And the bad news is, however, our data centers have almost run out of space, and setting up new ones around the world would be too expensive and very time consuming. Now the IT personnel, let's call him Mike, now he explains the situation from how he saw it. But the CEO had done some homework about how he was going to do it, and he answered Mike saying, don't worry about that, Mike. I've come up with a solution for a problem, and it's called Microsoft Azure. Well, Mike is an hard-working and honest IT professional working for that company, but he did not spend time on learning the latest technologies. And he asked this question very honestly, oh, how does it solve a problem? And the CEO begins to explain Azure to Mike, and he starts with what is cloud computing, and then he goes on and talks about Azure and the services offered by Azure and why Azure is better than the other cloud providers, and what are the great companies that uses Azure and how they got benefited out of it. And then he winds it all up with the use cases of Azure. So he begins his explanation saying Microsoft Azure is known as the cloud service provider, and it works on the basis of cloud computing. Now Microsoft Azure is formerly known as Windows Azure, and it's Microsoft's public cloud computing platform. It also provides a range of cloud services, including some of them are compute, analytics, storage, and networking. We can always pick and choose from these services to develop and scale our applications, or even plan on running existing applications in the public cloud. Microsoft Azure is both a platform as a service and infrastructure as a service. Let's now fade their conversation out and let's talk about what is cloud computing, Azure, services offered by Azure, how is Azure leading when compared to other cloud service providers, and what are the companies that are using Azure. Let's talk about that. In simple terms, cloud computing is being able to access compute services like servers, storage, database, networking, software analytics, intelligence, and a lot more over the internet, which is the cloud, with the flexibility of the resources that we use. Like anytime I want a resource, I can use one and it becomes available immediately. And anytime if I want to retire a resource, I can simply retire a resource and not pay for it. And we also typically pay only for the services that we use, and this helps greatly with our operating cost to run our infrastructure more efficiently and scale our environment up or down depending on the business needs and changes. And all the servers and storages and databases and networking, all that are accessed through the network of remote systems or remote computers hosted in the internet, typically in the provider's data center, which is Azure in this case. Now, we don't use any physical server or an on-premises server here. Well, we still use physical servers and VMs, hosted on a hardware or a physical server, but they're all in the provider's environment and none of them sit on premises or in our data center. We only access them remotely It looks and feels the same, except for the fact that they are in a remote location. We access them remotely, do all the work remotely, and when we're done, we can shut it down and not pay for them. So some of the use cases of cloud computing are creating applications and services. The other use cases are storing or using cloud for storage alone. If there is one thing that ever grows in an organization is the storage. Every new day there is a new storage requirement, and it's very dynamic. It's very hard to predict, and if we go out and buy a big storage capacity upfront, until we use the storage capacity fully, the empty storages, we're wasting money on them. So instead, I can go for a storage which scales dynamically, that's in the cloud. Put storage or put data in the cloud and pay only for what you're storing. And for the next month, if you have deleted or flushed out some files or data, pay less for it. So it's a very dynamic storage in the cloud, and a lot of companies are getting benefited from storing data in the cloud because of its dynamic in nature and the cost that comes along with it, the cheap cost that comes along with it. And also they give a lot of the providers like Azure, they give data replication for free. They promise an SLA along with the data we store in the cloud. So there's an SLA attached to it. And they also provide data recoveries as well. If in case something goes wrong with the physical disk where our data is stored, Azure automatically makes our data available from the redundant or other places where it had stored our data because of the SLA they wanted to keep. The other use case for Azure is hosting websites and running blogs using the compute service. Be it storing music and letting your users stream the music, Azure is a good place to store music and stream the music with the benefit of CDN, Content Delivery Network, which allows us to stream video or audio files with great speed. With Azure, our audio or video application works seamlessly because they are provided to the client with very low latency, and that improves the customer experience for our application. Azure Compute Service is a good place for delivering software on demand. There are a lot of softwares, embedded softwares that we can buy using Azure, and everything on a pay-as-you-go service model. So anytime we need a software, we can go out and immediately buy the software for the next 1 hour or 2 hour, let's say, and use them and then return it back. We're not bound to any yearly licensing cost by that. Azure Computing Services has analytics available for us with which we can analyze, get a good visualization of what's going on in a network, be it logs, be it the performance, be it the metrics. Instead of looking at logs and searching logs and trying to do manual things over the heaps and heaps of logs that we have saved, Azure Analytics Services helps us to get a good visual of what's going on in the network. Where have we dropped? Where have we increased? Or what's causing? What's the major driver? What is the top 10 errors that we get in the server, in the application? Stuff like that. Those can be easily gathered from the Azure Analytic Services. Now, cloud is really a very cool term for the internet. A good analogy would be looking back anytime we look at a diagram. When we do not know how things are transferred, we simply draw a cloud, right? For example, a mail gets sent from a person in one country to a person in the other country. There are a lot of things happening in between from the time you hit the send button and the time the other person hits the read button, right? And the simple and the easiest way of putting it in a picture is simply draw a cloud, and on the one end, one person will be sending the email, and on the other end, the other person will be reading the email. So a cloud is a really cool term for the internet. Now that's some basics about cloud computing. Now that we've understood about cloud computing in general, let's talk about Microsoft Azure as a cloud service. Now, Microsoft Azure is a set of cloud services to build, manage and deploy applications on a network with the help of Microsoft Azure's frameworks. Now, Microsoft Azure is a computing service created by Microsoft basically for building, testing, deploying, and managing applications and services through a global network of Microsoft managed data centers. Now, Microsoft Azure provides SaaS, which is software as a service, and PaaS, which is platform as a service, and IaaS, infrastructure as a service, and they support many different programming languages, tools, and framework. And those tools and framework include both Microsoft specific and third-party software. Now let me pick and talk about a specific service. For example, management. Azure Automation provides a way for us to automate the manual, long running and frequently repeated tasks that are commonly performed tasks both in cloud and enterprise environment. It saves us a lot of time and increases the reliability, and it kind of gives a good administrative control and even schedules the task automatically to be performed on a regular basis. To give you a quick history of Microsoft Azure, it was launched on 1st February 2010, and it was awarded, or it was called an industry leader for infrastructure and platform as a service by Gartner. Now, Gartner is the world's leading research and advisory company. This Microsoft Azure supports a number of programming languages like C#, Java, and Python. All these cool services we get to use and pay only for how much we use. For example, if we use for an hour, we only get to pay for an hour, even the costliest system available. If we use them for an hour, we only pay for that particular hour, and then we're done. No more billing on the resource that we have used. Microsoft Azure has spread itself more than 50 regions around the world. So it's quite easy for us to pick a region and start provisioning and running our applications probably from day one, because the infrastructure and the tools and technologies needed to run our application are already available. All that we have to do is commit the code in that particular region or build an application and launch it in that particular region, and they become live starting day one. Now, because we have 50 regions around the world, we can very carefully design our environment to provide low latency services to our customers. All right. Instead of in traditional data center, let's say, customers will have to, or their request will have to travel all the way around the globe to reach a data center which lives in the other side of the planet. And this adds more latency to it, and it is really not feasible to build a data center near each customer location because of the cost involved. But with Azure, it's possible. Azure already has data centers around the world, and all that we have to do is just pick a data center, build an environment there. They're available starting day one, number one, and also the cost is considerably saved because we are using a public cloud instead of an physical infrastructure to serve those customers from a very local location. And the services that Azure is offering is ever increasing. As of now, as we speak, we have like 200 plus services offered, and they span through different domain or different platform or different technologies available within the Azure console portal. Now, we're going to talk about that later in this section, so hold your breath till we talk about it. But for now, just know that we have like 200 plus services offered by Azure. Let's now talk about different services in Azure, starting with artificial intelligence plus machine learning, where we have a lot of tools and technologies. So the wide variety of services available in Azure includes artificial intelligence plus machine learning plus analytic services to get to give us a good visual of how the data or how the application is performing, or the type of the category of data stored, and to read from the logs. And variety of compute services, different VMs with different size and different operating systems, different containers available, different type of databases available, a lot of developer tools that are available for us, an identity service to manage our users in the Azure cloud. And those users can be integrated or federated with, let's say, Google, Facebook, LinkedIn. So there are some external federation services. They can be used to integrate with our identity system, IoT services, IoT tools and technologies available, and management tools to manage the users. Creating identity is one, and then managing them on top of it is a totally different thing. And we have tools, technologies to manage the users. Cool services for data migration. Data migration is now made simple. Tools and technologies available for mobile application development. And I can plan my own network in the cloud with the networking services. I can implement my own security, both Azure provided and third-party security services on Azure cloud. That's now possible. And a lot of storage options available in the cloud. So these are just a glimpse of the big list of services available in Azure cloud. So that was a glimpse of what's available in the cloud. Let's talk about the services in specific. Let's take compute for example. Whenever we're building a new application or deploying existing ones, the Azure Compute Service provides the infrastructure we need to run and maintain our application. We can easily tap in the capacity that Azure Cloud Service has, and we can scale our compute requirement on demand. We can also containerize our application. We have the option of choosing Windows or Linux VM machine and take the advantage of the flexible options Azure provides for us to migrate our VMs to Azure and a lot more. And these compute services also include a full-fledged identity solution, meaning integration with Active Directory in the cloud or on-premises, and a lot more. Let's look at some of the services that this compute domain provides. Some of the services the compute domain provides are virtual machines. And this Azure Virtual Machines gives us the ability to develop and manage a virtual computer environment or a virtualized environment inside Azure's cloud environment, that too in a virtual private network. Now we will talk about virtual private network at a later point, but as of now just know that there are a lot of services available in Azure Compute Service that we can get benefited from. We can always choose from a very wide range of compute options. For example, we have an option to choose the operating system. We have the option to choose whether the system should be in on-premises or in the cloud, or do we want to maintain the environment both in on-premises and in the cloud. We have the option of choosing the operating system, whether we want to use our own operating system with some software attached to it, or do we want to go and buy the operating system from the cloud, from Azure Marketplace. And these are just a few of the options available for us when we want to buy the compute environment. And these compute environments are easily scalable, meaning we can easily scale our VM instances from one instance to thousands of virtual machines in a matter of minutes, or simply put, in a couple of button clicks. And all these services are available on a pay for what we use model, meaning there is no upfront cost. We use the service and then pay for the services that we have used. There is no literal long-term commitment when it comes to using virtual machines in the cloud. And most of the services are built on a pay per minute billing basis. Alright, and at no point, because of the pay per minute billing model, at no point we will be overpaying for any of the services. That's attractive, isn't it? Now let's talk about batch service. Now batch service is always independent, regardless of whether you choose Windows or Linux, it's going to run fairly well. And with batch service, we can take advantage of the environment's unique features. And not only that, in short, the batch service helps us to manage the whole batch environment, and also it helps to schedule the jobs. Now this Azure batch service actually runs on a large scale parallel and high performance computing. Because of that, batch jobs are highly efficient in Azure. And when we run batch services, this Azure batch creates a pool of computer nodes and installs the needed applications that we want to run, and then it schedules jobs to those individual nodes in those pools. As a customer, there is no need for us to install a cluster, or there is no need for us to install a software that actually schedules the jobs, or even to manage or even to scale those infrastructure or the software, because everything is managed by Azure. And this batch service is a platform as a service. There is no additional charge for using this batch service except for, the only charges that we'll be paying is for the virtual machines that the service uses, and the storage that we will be using, of course, and the networking services that we will be using for this batch service. Let's summarize. This batch service, we have a choice of operating system that we can pick and use, and it scales by itself. Now, the alternative for the batch would be queues, but in queues, we'll have to pre-provision and pay for the infrastructure even if we're not using it. But with a batch, we only pay for what we use. And this batch service helps us to manage the application, manage the scheduling as a whole, as if they are just one thing. As next thing in the compute domain, let's talk about this Fabric service. Now, this Fabric service is actually a distributed system platform that helps us to package, deploy, and manage a scalable and a very reliable microservice and containers. And what does it help? This Azure Fabric service helps us, or it helps the developers and administrators so they can avoid the complex infrastructure problems, and they can focus only on implementing workloads or taking care of their development, taking care of their application instead of spending time on infrastructure. So what's Service Fabric? Service Fabric, it provides runtime capabilities and life cycle management to applications that are composed of microservices, no infrastructure management at all. And with Service Fabric, we can easily scale the application to tens or hundreds or even to thousands of machines. Here, machines represent containers. As next thing in compute domain, let's talk about virtual machine scale set. Now, this virtual machine scale set, it lets us to create a group of identical load balanced VMs. I just want to mention it again. It helps us to manage a group identical and load balanced VMs. The number of instances or the number of VM instances in a scale set can increase or decrease in response to the demand or in response to a schedule that we define. The resources needed on a Monday morning is not the same as that would be required on a Saturday or a Sunday morning. All right. And even within the day, the resources that would be needed in the beginning of the business hour is not the resources that would be needed at noon or, after 8 or 9 in the evening. So the demands could actually vary in the environment, and this scale set helps us to take care of the varying demand or take care of the different infrastructure requirement at a different schedule throughout the day, throughout the week, throughout the month, or could be throughout the year as well. The scale set also allows us to provide high availability to our applications, and it helps us to centrally manage, configure, and update a large number of VMs as if they are just one thing. Now you might ask, well, virtual machines are enough. Why would we need a virtual machine scale set? Just like I said, this virtual machine scale set helps us with a greater redundancy and improved performance for our applications. And those applications can be accessed through a load balancer that actually distributes the requests to the application instances. So in a nutshell, this virtual machine scale set, it helps us to create a large number of identical virtual machines, number one. And with scale set, we can increase or decrease the virtual machines. With virtual machine scale set, we can centrally manage and configure and update a big group of VMs. And it's a great use case when it comes to big data or container workloads. As next thing in compute domain, let's talk about cloud services. Now, this Azure Cloud Service is actually a platform as a service, and it's very friendly. In fact, it is designed for applications that support scalability, or an application that requires scalability or reliability, and on top of it, you want them to be very inexpensive to operate. So Azure Cloud Service provides all these. So where would this cloud service run? Well, it runs on a VM, but it's a platform as a service. VMs are infrastructure as a service, and when we run applications on VM through cloud service, it becomes platform as a service. So here is how you got to be thinking. With infrastructure as a service like VMs, we first create and configure the environment, and then we run applications on top of it. Let's look at the responsibility. The responsibility for us in VM is that we manage everything end to end, like deploying new patches, picking the versions of the operating system, and making sure they are intact and all that stuff. It's all managed by us. But on the contrary, with platform as a service, it's as if the environment is already ready. All that you have to do is deploy your application in it and manage the platform. Manage the platform not as an administrator, because all the administration is taken care by Azure, like deploying new versions of the operating system. It's all handled by the Azure. So we deploy the application and we manage the application. That's it. Infrastructure management is handled by Azure. So what does cloud service provide? This cloud service provides a platform where we can write the application code, and we don't have to worry about hardware. Simply hand over the code and cloud service takes care of it. So no worry on the hardware at all. So responsibilities like patching, what do we do if something crashes? How do I update the infrastructure? How do I manage the maintenance or the downtime in the underlying infrastructure? All that is handled by Azure. It also provides a good testing environment for us. We can simply run the code, test it before it's actually released to the production. I want to expand a bit on these testing applications. So this Azure Cloud Service, it actually gives us a staging environment for testing a new release without it affecting the existing release, which actually reduces the customer downtime. So we can run the application, test it, and anytime that's ready for production, all that's needed for us to do to move it to production is simply to swap the staging environment into the production environment, and the old production environment will now become the new staging environment, where we can add more to it and then swap it back at a later point. So it kind of gives us a swappable environment for testing our applications. And not only that, it gives us health monitoring alerts. It helps us to monitor the health and availability of our application. And there is a dashboard we can benefit from when we use Azure Cloud Services, and that shows the key statistics all in one place. And we can also set up real-time alerts to warn when a service availability or a certain metrics that we are concerned about degrades. As next thing in compute domain, let's talk about functions. Now, functions are serverless computing. Many times, if you've heard about Azure being serverless, a lot of time they are referencing, or the person who's talking to you is referencing to serverless computing or Azure Functions, which is a serverless computing service hosted on Microsoft Azure. The main motive of a function is to accelerate and simplify application development. Functions helps us to run code on demand without we need to pre-provision or manage any Azure infrastructure. So Azure Functions are script or a piece of code that gets run in response to an event that you want to handle. So in short, we can just write a code that you need for a problem at hand without actually worrying about the whole application or the infrastructure that will be running that code. And the best of all the best is when we use functions, we only pay for the time that our code runs. So what does functions provide, or what does Azure Functions provide? Azure Functions allow users to build applications using serverless simple functions with a programming language of our choice. So the current programming languages that are supported is C#, F#, Node.js, Java, and PHP. So here we really don't have to worry about provisioning or maintaining servers. If a code requires more resource, yes, Azure Functions handles or it provides the additional resources needed by the code. And the best part is we only pay for the amount of time the functions are running, not the resources, but the amount of time the function is running. As next thing, and moving to the new domain, let's talk about the container domain in Azure. Now the container domain or the container service, it allows us to quickly deploy a production ready Kubernetes or a Docker Swarm cluster. Now what's a container? A container is a standard unit of software that packages of code and all its dependencies so the applications run quickly and reliably from one computing environment to another. It could be testing to staging to development environment to staging to production, or from one production to another production, or on premises to cloud, or one cloud to another cloud, vice versa. Now imagine we had an option not to worry about the VM and just focus on the application. Well, that's exactly what containers helps us achieve. So these container instances enable us to focus on applications and not worrying about managing VMs or not worrying about learning the new tools required to manage the VMs or even the deployment. And our applications that we create, they run in a container. And running in a container is what helps us to achieve all these, not being able to manage or not needing to manage the virtual machines. So these containers, they can be deployed into the cloud using a single command if you're using a command line interface, and a couple of button clicks if we are using the Azure portal. And these containers are kept lightweight, but they are equally secure as virtual machines. Let's talk about container service as next thing. The container service, or sometimes called as Azure Kubernetes Service, it helps us to manage the containers. Container is one thing, and a service that's used to manage the container is another thing. Now this Kubernetes service, or ACS, it helps us to manage the containers. So let's expand on this a bit. So this Azure Container Service, or ACS, it actually provides a way to simplify the creation, configuration, and management of a cluster of virtual machines that are pre-configured to run containerized applications on top of them. Deploying these containers might take like 15 to 20 minutes, or deploying the virtual machines that run containers in it might take 15 to 20 minutes. And once they are provisioned, we can actually manage them by using simple SSH tunnel into them. And this ACS, when it runs applications from Docker images. What does that mean? Docker images makes sure that the applications the container runs are fully portable. Images are portable. And ACS also helps us to orchestrate the container environment. Not only that, it also helps us to ensure that these applications that we run in containers can be scaled to thousands or even tens of thousands of containers. So in a nutshell, managing an existing application into a container and running it using AKS or ACS is really easy, or that's what it is all about, to make the application management or migration easy. Now, managing the container-based architecture, and we discussed that containers could be tens or even tens of thousands of containers. So managing them is made simple using this container services. And even training of model using a large data set in a complex and resource intensive environment, this AKS helps us to simplify that environment. Alright, as next thing in container domain, let's talk about container registry. We spoke about registry a little bit when we spoke about Docker images. So container registry is a single place where we can store our images, which are Docker images. When we use containers, it's Docker images that we use for our image purposes. So these container images are a central registry that can be used to ease container development by easing the storage and management of container images. So there we can store all kind of images like Docker Swarm, or the images used in Docker Swarm are in Kubernetes. Everything can be stored in container registry in Azure. Now, anytime we store a container image, it provides us an option for geo-replication. What that means is that we can efficiently manage a single registry replicated across multiple regions. Now, this geo-replication, it actually enables us to manage global deployments, assuming we are having an environment that requires a global deployment. So it helps us to manage global deployments as one entity because we are geo-replicating. We would be updating, we would be editing one image, and that image gets replicated throughout the global replication centers we would have set up. And so just one editing would have actually edited the global images, and those global images would have provisioned the global application. So one edit, replication, and then provisioning of the applications global wide. And this replication also helps us network latency, because anytime an application needs to deploy, it does not have to rely on a single source which can be reached only through high latency network. Because we have global replications around the world, anytime the application wants to check back, it would check back the application which is in a very nearby location for the application itself. Global replication means that we are managing it as a single entity that's being replicated across the multiple regions in the globe. As next thing in our learning, let's talk about Azure databases. Now, these Azure databases are relational. In fact, they have many flavors in them. We're going to look at different flavors, SQL, NoSQL, cache type of database that Azure offers. So we're going to learn one at a time, or we're going to learn one by one. So this Azure SQL database is a relational database. In fact, it's a relational database as a service. It's managed by Azure. We don't get to do a lot of management in it. So it's a relational database as a service based on Microsoft SQL Server database engine. And this database is a high performance database. It is very reliable, and it's very secure as well. And this high reliability, high performance, and for this high security, we really don't have to do anything. It comes along with it, and it's managed by Azure. And there are two things that I definitely need to mention about Azure SQL database. That is, it's an intelligent service. Number one, it's fully managed by Azure, and it also has this one good thing, which is it has built-in intelligence that learns app patterns and adapts to maximize performance and reliability and data protection of the application. That's something that's not found in many of the other cloud providers that I'm aware of. So I thought I'll mention it. So it uses built-in intelligence to learn about the user's database patterns and helps improve performance and protection. And migration or importing data is very easy when it comes to Azure SQL database. So it can be readily or immediately used for analytic reporting and intelligent applications in Azure. As next thing, let's talk about Azure Cosmos DB. Now, Azure Cosmos DB is a database service that is for NoSQL type, and it's created to provide low latency and an application that scales dynamically or that scales rapidly. Now, this Azure Cosmos DB is a globally distributed service, and it's a multi-model database. This can be provisioned in a click of a button. That's all we got to do if we need to provision an Azure Cosmos DB in the Azure. It helps with scaling the database. We can elastically and independently scale throughput and storage across this database and in any of the Azure geographic regions. It provides a good throughput, it provides good latency, it provides good availability, and it provides, or Azure promises, a comprehensive SLA that no other database can offer. That's the best part about Cosmos DB. So this Cosmos DB was built with global distribution in mind, and it's built with the horizontal scale in mind. And all this we can use by only paying for what we have used. And remember, the difference between Azure Cosmos DB and the SQL database is that Azure Cosmos DB supports NoSQL, whereas SQL doesn't. Alright, few other things about Azure Cosmos DB is it allows users to use key value graph, a column, family, and document data. It also gives users a number of API options like SQL, JavaScript, MongoDB, and few others that you might want to check in the document at the time of reading. And the best part here is that all that we mentioned, we get to use only by paying for the amount of storage and throughput that are required. And the storage and the throughput can be elastically scaled based on the requirement of that R. Alright, let's talk about Redis cache. Discussion about Azure database won't be complete without we talking about Redis cache. Now, Redis cache is a secure data cache. It's also sometimes called as messaging broker that provides high throughput and low latency access to data for the applications. Now, Redis Cache is based on a popular open source caching product, which is Redis, sometimes called as Redis Cache. Now, what's the use case? It's typically used to cache to improve the performance and scalability of a system that rely heavily on backend data stores. Now, performance when we use Redis Cache is improved by temporarily copying the frequently accessed data to a fast storage located very close to the application. Now, with Redis Cache, this fast storage is located in memory with Redis Cache instead of being loaded from the actual disk in the database itself. Now, this Redis Cache can also be used as an in-memory data structure store. Not only that, it can be used as a distributed non-relational database and a message broker. So there are a variety of use cases for this Redis Cache. And by using Redis Cache, the application performance is improved by taking advantage of the low latency and the high throughput performance that this Redis Cache engine provides. So to summarize, this Redis Cache, when we use Redis Cache, data is stored in the memory instead of the disk to ensure that there is high throughput and low latency when the application needs to read the data. It provides various levels of scaling without any downtime or interference. Now, this Redis Cache is actually backed by Redis server, and it supports string, hashes, linked list, and various other data structures. Now let's talk about security and identity services. Now, identity management in specific is a process of authenticating first and then authorizing using security principles. And not only that, identity management involves controlling information about those principal identities. You might ask, now what's a principal identity? Now, identity or principal identity are services, applications, users, groups, and a lot more. The speciality about this identity management is that it not only helps authenticate and authorize principals in cloud, it also helps authenticate and authorize principals or resources on premises, especially when you run an hybrid cloud environment. So all these services and features that this identity management helps us to get additional level of validation, like identity management can provide multi-factor authentication. It can provide access policies based on condition, permit or deny based on condition. It can also monitor suspicious activity, and not only that, it can also report it. It can also help generate alerts for potential security issues, and in a way to mitigate it, can send us an alert so we can get involved and prevent a security accident from happening. So let's talk more about identity management. So some of the services under security and identity management are Azure Security Center. Now, this Azure Security Center provides security management and threat protection across the workloads in both cloud and in the hybrid environment. It helps control user access and application control to stop any malicious activity if present. It helps us to find and fix vulnerabilities before they can be even exploited. It integrates very well with analytic methods that helps us to identify, or it gives us the intelligence to identify or detect attacks and prevent them before it can actually happen. And it also works seamlessly with hybrid environments. So you don't have to have one policy for on-premises and one policy for the cloud. It's now a unified service, both for on-premises and the cloud. The next service in security and identity would be Key Vault. Now, a Key Vault is a service or a feature that helps safeguard the cryptographic keys and any other secrets used by the cloud applications and the services. In other words, this Azure Key Vault is a tool for securely storing and accessing the secrets of the environment, the secret keys. Now, a secret is anything that you really want to have a very tight control access, like the certificates, like the passwords, stuff like that. Now, if I tell you what Key Vault actually solves, that would actually explain what Key Vault is. Now, Key Vault is used in secrets management. It's helped in securely storing the tokens, the passwords, the certificates. It helps in key management. It really helps in creating and controlling the encryption keys that we would use to encrypt data. It helps in certificate management. Talking about certification management, it helps us to easily provision, manage, and deploy public and private SSL, TLS certificates in Azure, and a lot more. So in a nutshell, this key vault, it provides users the ability to provision new vaults and keys in just a matter of minutes, all that in a single command, or all that in a couple of button clicks. It also helps users to centrally manage their keys, secrets, and policies. Next in the list, let's talk about Azure Active Directory. Now, Azure Active Directory, it helps us to create intelligent-driven access policies to limit resource usage and manage user identities. What does that mean? Now, this Azure Active Directory is a cloud-based Active Directory and identity management service. Now, Azure Active Directory combines, it's actually a combination of the core directory services plus application access management plus identity protection. And one good thing about this Azure, in fact, there are a lot of good things, but especially when you're running hybrid environments, you might wonder, well, how this Azure Active Directory is going to behave. Now, this Azure Active Directory is built to work on on-premises and cloud environment as well. Not only that, it also works seamlessly with mobile applications as well. So in a nutshell, this Azure Active Directory, it acts as an central point of identity and access management for our cloud environment. It also provides good security solutions that protect against unauthorized access of our app and the data. Now that we've discussed about security and identity, let's talk about the management tools that Azure has to offer. Azure provides built-in management and account governance tools that helps administrators and developers, that helps them to keep their resources secure and very compliant. And again, it helps both in on-premises and in the cloud environment. And these management tools help us to monitor the infrastructure, monitor the applications. It also helps in provisioning and configuring resources. It also helps in updating apps. It helps in analyzing threats, taking backup of the resources, build disaster recoveries. It also helps in applying policies and conditions to automate our environment. We use Azure management tools, and it's also used in cost control methods. So this Azure management plays a wide role across the Azure services. And in the management tools, first comes the Azure Advisor. Now this Azure Advisor, it acts as a guide to educate us about Azure best practices. It throws recommendations that we can select on the basis of the category of service, and it also provides the impact it can have, or the impact that would happen in our environment if we follow the recommendations given. And recommendations are, first one is the recommendations are kind of templatized, and it throws the templatized recommendations. Not only that, it also provides customized recommendations on the basis of the configuration, on the basis of our usage patterns. And these recommendations are not hard. It's not like something that it recommends and then just leaves us hanging there. These recommendations provided are very easy to follow, very easy to implement and see results. You can think of Azure Advisor as a very personalized cloud consultant that helps you to follow best practices to optimize our deployments. It kind of analyzes our resources, our configurations, our usage, and then it recommends a solution for us that really helps in improving the cost effectiveness, improving the performance, improving high availability, and improving security in our Azure environment. So with this Azure Advisor, we can get a proactive, actionable, and personalized best practice recommendations. Now, you don't have to be an expert. Just follow the Azure Advisor and your environment is going to be good. It also helps in improve the performance, security, high availability of our environment. And also it helps in bringing down the overall Azure spend. And the best part is It's a free service that analyzes our Azure usage and provides recommendations, how we can optimize our Azure resource to reduce cost. And reduce cost at the same time boost the performance, helps in strengthening the security and improve the overall reliability of our environment. Next in the list would be Network Watcher. Now this Network Watcher helps users identify and gain insights in the overall network performance and the health of the overall environment. Now these Azure Watchers provides enough tools to monitor, to diagnose, to view the metrics, and to enable or disable logs, which means generate and collect the logs for resources in the Azure Virtual Network. So with Network Watcher, you can monitor and diagnose issues in networking without even logging into the virtual machines. With just the logs, which are real time, we can actually come to a conclusion what could be wrong in a certain resource, in a VM or in a database, by just looking at the logs. And not only that, it's used for analytic or to gain some intelligence of what's happening in our network. We can gain a lot of insight to the current network traffic pattern using the security group flow logs that this Network Watcher offers. It also helps in investigating VPN connectivity issues using detailed logs. Now, you might or might not know that VPN troubleshooting requires both parties, or it involves two parties. The person, the network administrator on this side and the network administrator on the other side. And they will have to check logs in their end, and we'll have to check logs in our end, stuff like that. But with the Network Watcher, it kind of takes it to the next level. The logs itself, we could easily identify which side is having the issue and suggest an appropriate fix. And the next in the list would be Microsoft Azure Portal. Now, this Microsoft Azure Portal, it provides a single unified console to perform various number of activities like building, not only building, managing and monitoring the web applications that we build. Now, this portal can be used to organize our environment or the appearance of the environment or the visual of the environment based on our work style. And using Azure Portal, users can control who gets to manage or access the resources, all from the Azure Portal. And this Azure Portal gives a very good visibility on the spends that happen on each resource, right? And if we can customize it, we can also identify spends based on team, spends based on days, spends based on department, stuff like that. So it kind of gives us a good visual of where the money is spending or where is the bill consumed within the Azure environment. Next in the list would be Azure Resource Manager. Now, Azure Resource Manager enables us to manage the usage of the application resources. Now, we use Resource Manager to deploy, monitor, and manage solution resources as a group, as if it's one single entity. Now, the infrastructure of our application is typically made of various components, which includes virtual machine, storage, virtual network, web app, database servers, some other third-party services that we might use in our environment. And they are by nature separate services. But with Azure Resource Manager, we don't see them as different components or different entities. Instead, we see them as related services in a group that supports an application. Now we kind of get the relation between them instead of letting them spread. Azure Resource Manager identifies the relation between them and helps us to visually see them all as one or single entity. Not only that, Azure Resource Manager helps or it ensures that the resources that we provision are deployed at a constant rate along with the other application. It also helps users to visually see their resources and how they are connected, and that helps in managing the resources a lot better. Resource group also is used to control who can access the resources within the user's organization. Kind of gives you the fine-grained control over who gets to access and who does not get access. And the last one in the management tools would be automation. And this automation gives us the ability to automate, configure, and install upgrades across hybrid environments. It provides a cloud-based automation and configuration service. Not only that, this can be applied for non-Azure environments as well, which is on-premises. So some of the automation we could do is process automation, update management automation, configuration features automation, stuff like that. And this Azure automation provides complete control during the deployment, operation, and also during the decommissioning of the workloads and resources. With automation, we can actually automate time-consuming or mundane or any task that's error-prone because of human errors. Those things can be automated. So irrespective of how many times you run it, it's going to run the same way. And that really helps in reducing the overall time and also the overhead cost, because a lot of the things are automated, which means it's human error-free, which means the application is not going to break and keep running for a longer time. With automation, we can actually build a good inventory of operating system resources and configuration items all in one place with ease. And this really helps in tracking the changes and investigating the issue. Let's say something happened. Because we have automation, because it's logging the configuration changes, it's easy to track, easy to identify what has changed lately that has broken the environment, go back and fix it or kind of roll it back. That solves the problem. And that actually summarizes the Azure management tools or management services. Now let's talk about the networking tools or the networking services available in Azure. There are a variety of services, especially networking services, that Azure offers, and I'm sure it's going to be an interesting one. Let's begin our discussion with Content Delivery Network. Now, the Content Delivery Network, in short, CDN, it allows us to perform secure and a very reliable content delivery. Not only that, it also helps in accelerating the delivery time, or in other words, reducing the delivery time, also called as load times. It also helps in saving bandwidth and increases in responsiveness to the application. Let's expand on this. The Content Delivery Network is actually a distributed network of servers that can efficiently deliver web content to users. Now, CDNs, we're going to use the word CDN here. CDNs store cached content on global edge servers, also called as POPs, point of presence locations, that are very close to the end users, so the latency is minimized. It's like taking a copy of the data or taking a multiple copy of the data and storing it in different parts of the world, and whoever is requesting it, the data gets delivered to them from a server which is very locally to them. So this CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching the content in a strategically placed location which is very near to them. So these content delivery networks, it really helps in handling. That's one advantage you get for content delivery network, that's we can handle spikes and heavy loads very efficiently. And we can also run analytic against the logs that gets generated in content delivery network, which helps in gaining good insight on the workflow and what would be the future business need for that application. And this, just like a lot of other services, this is on a pay as you go type. So you use the resource first and then you only pay for what you have used. The next one in networking would be ExpressRoute. Now ExpressRoute is actually a circuit or a link that provides a direct private connection to Azure. And because it's direct, it gives low latency link to Azure. It gives good speed and reliability for the Azure data transfer. It could be on-premises to Azure. So it gives very good speed. It gives increased reliability and low latency for that connection. Let's expand on this a bit. Now this ExpressRoute is a service that actually provides a private connection between Microsoft data center and infrastructure in our premises or in a different co-location facility that we might have. Now these ExpressRoutes do not go over the public internet. And because they don't go over the public internet, they offer a high security, reliability and speed and low latency compared to the connections which are in the internet. because it's fast, because it's reliable, because it has low latency, it can be used as an extension of our existing data center. Users are not going to feel the difference whether they are accessing services from an on-premises or in the cloud environment, because latency is minimized as much as possible. Users are really not going to see the difference. And because it's a private line and not an public internet line, it can be used to build hybrid applications without compromising privacy or the performance. Now, these virtual private cloud, these express routes can be used for taking backups. If assume a backup going through the internet, that would be a nightmare. If we use express route for backups, that's going to be fast. And imagine recovering a data through the internet, from the cloud, through the internet, to the on-premises in a time of disaster. That would be the worst nightmare. So these express routes can be used not only to backup, but also to recover the data. Because it provides good speed, low latency, recovering the data is going to be a lot sooner. The next product or service we're going to discuss in networking is Azure DNS. Now, Azure DNS allows us to host domain name in Azure, and these domain names come with an exceptional performance and availability. Now, Azure DNS is used to set up and manage DNS zones and records for our domain name in the cloud. Now, this Azure DNS is a service for DNS, just like the name says, and it provides name resolution by using Azure's infrastructure. And by using this domain, we can actually manage the DNS ourselves through the Azure portal with the same credential. Imagine having a DNS provider which does not even belong in our IT. Imagine that environment. We would have a separate portal to manage the DNS environment. Now, those are gone. And now we can actually manage the DNS in the very same Azure portal where we use the rest of the other services. And this Azure DNS very much integrates with other DNS service providers. It uses a global network of name servers to provide fast response to DNS queries. And these domains are having additional availability compared to the other domain service providers' availability promises. These are going to have more availability than the rest because most of the servers are maintained by Microsoft, and it helps resolve sooner. It helps resyncing. Let's say a server fails, it kind of helps resyncing with the rest of the servers. So all the Microsoft's environment, all the Microsoft's global network of name servers kind of ensures that our domain names are resolved properly, not only properly, but also are available most of the time. All right, next in the list in networking services is virtual network. I'm sure this is going to be very interesting, and I'm sure you're going to like it. So this networking or virtual networking in Azure, it actually allows us to set up our own private cloud in the public cloud. It gives us an isolated and highly secure environment for our application. Let's expand on this. So this Azure Virtual Network helps us to provision Azure virtual machines, and it helps us to securely communicate with other on-premises and internet networks. It also helps in controlling the traffic that flows through or flows in and out of this virtual network to other virtual networks and to the internet. Now, this Azure virtual network, sometimes called as VNet, is actually a representation of our own network in the cloud. It's actually a logical isolation of the Azure cloud dedicated to our subscription. All our environments are provisioned in a VNet that is separate from another customer's VNets. That way we have that logical separation there. So this virtual network can also be used to provision VPNs in the cloud, so we can connect the cloud and the on-premises infrastructure and a lot more, especially in an environment where we have hybrid environment. Surely we will be using virtual network because that's going to require a VPN for secure data transfer in and out of the cloud and in and out of the on-premises environment. Alright, so it kind of gives us a boundary for all the resources. So all the traffic between the Azure resources, they kind of logically stay in between or logically stay within the Azure Virtual Network. And here we can design the network. It's given over to us. You can pick the IP, you can pick the routing, you can pick the subnet. A lot of freedom is given, or I would say a lot of control on how the network is designed. It's not like something that's already cooked and we only get to use it. No, we can actually build the network from the scratch. We can pick the IP address that we like. We can pick, which subnet needs to communicate with the other subnet, stuff like that. And like I said, if you are using hybrid environment, you definitely would be requiring a virtual network because it helps connect the on-premises and the cloud in a secure fashion using VPN. The last product we're going to discuss in networking is a load balancer. This load balancer actually provides application a good availability and a good network performance. So how does it work? It actually works by load balancing the traffic to and from the virtual machine and the cloud resources. Not only that, it also load balances between cloud and cross-premises virtual networks. With Azure Load Balancer, we can actually scale our application and create high availability for our services, which means our application will be available most of the time. If any of the server goes dead, the server does not get traffic. What happens if the server gets traffic? User is going to experience downtime. What happens if the server does not get traffic? User won't experience any downtime. The connection is shifted to an healthy service, so the user experiences uptime all the time. So this load balancer supports inbound and outbound scenarios, and it provides low latency. It gives high throughput of the data transfer, and we can actually scale up the flow of the TCP and UDP connections from hundreds to thousands to even millions because we have a load balancer now in between the user and the application. So how does it operate? This load balancer actually receives the traffic and it load balances the traffic to the backend pool of instances connected to it according to the rule and the health probe that we set. That's how it maintains high availability. So what does load balancer help? It helps in creation of high available scalable application in the cloud in minutes. It can be used to automatically scale the environment with the increasing application traffic. And one feature of load balancer is to check the health of the user's application instance, and it removes or it stops sending the request to the unhealthy instance and kind of shifts that connection to the healthy instance. That way a user or a connection does not get stuck with an instance that's not healthy. That's all that you need to know about the networking services. Now let's talk about the storage services or the storage domain in Azure. Now Azure Storage in general is a Microsoft managed service providing cloud storage, which basically is highly available, secure, durable, scalable, and redundant because it's all managed by Azure. We don't get to manage a lot of it. And these Azure storages are a group of storage services. They cater different needs. And the storage products include Azure Blobs, which is actually an object storage. It includes Azure Data Lake. It includes Azure Files. As you see, it includes Azure Queues. It includes Azure Tables and a lot more. But let's start our discussion with Azure Store Simple. Azure Store Simple is an hybrid cloud storage solution that actually lowers the cost of storage to nearly 60% of how much you would be actually spending without using it. So Azure Simple Storage or Store Simple is an integrated storage solution that manages the storage task between on-premises and the cloud storage. What I really like about Azure is that it's built around a hybrid environment in mind. There are a lot of other cloud providers that are there where running an hybrid environment is a big challenge. It has some compatibility. You won't be able to find an hybrid or a on-premises and cloud solution for your need, stuff like that. But with Azure, especially when it comes to storage, a lot of the things that we're going to see, it clearly is designed with hybrid environment in mind. All right, so let's come back and talk about Store Simple. So Store Simple is an very efficient, cost-effective, and a very easily manageable SAN, storage area networking solution in the cloud. I thought I'll throw in this information. The reason why it got Store Simple is really because it uses Store Simple 8000 series devices devices which are used in Azure data center. And this Store Simple or Simple Storage, it comes along with storage tiering to manage the stored data across the various storage media. So the very current data is actually stored in on-premises on solid-state drives, and data that is used less frequently is stored in HDDs or hard disk drives. And the data that requires archived or that needs to be archived, very old data, let's say less frequently used data, candidate for archive, they are actually pushed to the cloud. So you see how this storage tiering automatically happens in Store Simple. And another cool feature of Store Simple is that it enables us to create an on-demand and scheduled backups of data and then store the data locally or in the cloud. And these backups are actually taken in the form of incremental snapshot, which means that they can be created and restored quickly. It's not a complete backup, it's an incremental backup. And these cloud snapshots, they can be critically important when there is a disaster and when there is a disaster recovery scenario, because these snapshots can be called in and they can be put on storage systems and then they become the actual data. So recovering is faster if you have proper scheduled backups or if you have frequent backups. And this Storage Simple, it really helps in easing our backup mechanism, which means it kind of eases our disaster recovery steps or procedures as well. So this Store Simple, it can be used to automate data management, data migration, data movement, data tiering across the enterprise, both in cloud and on premises. It actually improves the compliance and accelerates the disaster recovery for our environment. And if there is one thing that's increasing every new day in our environment, that would be storage. And this Store Simple addresses that need, and we really don't have to pre-plan or think in deep for having a proper storage, because now we have a simple storage available in the cloud, and moreover it's on a pay-as-you-go type. So not much pre-planning on storage is needed. Yes, there will be a need, but not as much as I would without the cloud or without the simple storage. And the next service under storage that we would like to discuss is the Data Lake Store. This Data Lake Store or storage, it's a cost-effective solution for big data analytics in specific. So let's expand this. So this Data Lake Storage is an enterprise-wide repository for big data analytic workload. Now that's the major service that's dependent on this Data Lake Store. And this Data Lake enables us to capture data of any size, of any type, and of any ingestion speed, and it kind of collects them in one single space or in one single place for operational efficiency. And for analytic purpose. Hadoop in Azure is very dependent on this Data Lake Storage. And this Data Lake Store is designed with performance for analytics in mind. So anytime you think of, or anytime you're using analytic in the cloud, or anytime you're using Hadoop in the cloud in Azure, we are definitely using, or we will be, to the most part, or the normal procedure or the right storage to pick would be Data Lake Store in Azure. It's designed with security in mind. So anytime we use Azure storage, we can be rest assured that we are using storage from within a data center which was built with security in mind. So this data store also uses Azure Blob Storage behind the scenes for global scale, durability, and for performance. Let's talk about blob storage. Now, blob storage provides large amount of storage and scalability. Now, this blob storage is the object storage solution for Azure Cloud. Let's expand a bit on blob storage. Azure Blob Storage is Microsoft offering for object storage. Now, this blob storage is optimized for storing massive amount of unstructured data, which could be text or binary data. It's designed and it's optimized for rapid reads. If I explain to you on what scenarios we would be using blob storage, that might help you get a good understanding of what blob storage is. So it's designed, as of now it's being used in many IT environments to serve images or documents directly to the browser. It helps in storing files for distributed access. A lot of fetchers can fetch data from Azure Blob Storage. and it's currently helping users stream video and audio. It's currently being used for writing log files. It's currently being used to store data as backup and restore at a later point in times of disaster recovery. It also is used as an archiving storage in a lot of cloud IT environments. It's widely used in storing analytic data, not only storing but also running analytic query against the data stored in it. So that's a wide use case for blob storage. Not only that, in addition to all that we mentioned, it also supports versioning. So anytime somebody updates an data, a new version gets created, which means at any point I can roll back as and when needed. And it provides a lot of flexibility on optimizing the user's storage need. It also supports tiering of the data. So based on need, when I actually explore, I would find a lot of options I can pick from that suits to my unique storage environment or unique storage need. And like I said, it stores unstructured data, and this unstructured data is available for customers through REST-based object storage environment. The next product and storage service would be queue storage. Now, queue storage provides durable queues for large volume cloud services. It's a very simple and a cost-effective, durable messaging queue for large workloads. Let's expand this queue storage for a moment. Now, this queue storage is a service for storing large amount of messages that can be accessed from anywhere in the world through HTTP and HTTPS calls. A single queue or a single queue message can be up to like 24 KB in size, and a single queue can contain millions of such 24 KB in size messages. And how much can it hold? It can hold up to the total capacity of the storage account itself. So that's kind of easy to translate. How much would it hold? And this Azure Queue Storage, it provides an messaging solution between applications and components in the cloud. What does it help? It helps in designing an application for scale. It helps in decoupling the application, so it's not very dependent, or sometimes it's not at all dependent on the other application, because now we have a queue in between which kind of translates or which kind of connects or which kind of decouples both the environment. Now we have a queue in between, both the environment can scale up or scale down independently. The next in the storage service would be file storage. Let's talk about file storage. Now, these Azure files provide secure, simple, and managed cloud file shares. Now, with file share in the cloud, it actually extends the user server's on-premises performance and capacity. And a lot of familiar tools for the cloud file share management can be used along with the file storage that we're talking about. So let's expand a bit on file storage. Now, this Azure Files or Azure File Storage offers a fully managed file shares in the cloud that can be accessed via the SMB protocol, Server Message Block Protocol. Now, this Azure File Shares can be mounted concurrently by cloud or in on-premises deployments. A lot of operating systems are compatible with it. Windows are compatible, Linux is compatible, Mac OS is compatible. In addition to all this being able to run on-premises and on the cloud, or being able to access from on-premises and on the cloud, it can also offer cache for caching the data and keeping it locally, so it's immediately available when needed. So that's some additional feature, I would say that's some advanced feature that it offers compared to the other file shares available in the market. Let's talk about table storage. Now, table storage is a NoSQL key value pair storage for quick deployments with large semi-structured data sets. The difference between one important thing to note with table storage is that it has a flexible data schema, and also it's highly available. Let's expand a bit on table storage. So anytime you want to pick a schema-less, a NoSQL type table storage is the one we'll end up picking. It provides an key pair attribute storage with a schema-less design. This table storage is very fast and very cost effective for many of the applications, and for the same amount of data, it's a lot cheaper when you compare it with the traditional SQL data or data storage. So some of the things that we can store in the table storage are, of course, they're going to be flexible data sheets, such as user data for web application, address books, device information, and other types of metadata for our service requirements. And it can have any number of tables up to the capacity limit of the storage account. Now, this is not possible with SQL. This is only possible with NoSQL, especially with table storage in Azure. Explanation of storage really concluded the length and breadth of the explanation this CEO was giving his IT personnel. But this IT personnel is not done with it yet. He still has a question even after this lengthy discussion. And his question was, well, there are a lot of other cloud providers available. What made you specifically choose Azure? I mean, from the kind of question that he asked, we can say that he is very curious, and he definitely had asked a very thoughtful question. So his CEO went on and started to explain about the other capabilities of Azure, or how it kind of outruns the rest of the cloud providers. So he started, or he again started his discussion, but from a different angle now. So he started to explain what are the capabilities or how Azure is better than the competitors. So he started with explaining the platform as a service capabilities. And I'm going to tell you what the CEO told his IT person. So this platform as a service, or in platform as a service, the infrastructure management is completely taken care by Microsoft, allowing users to focus completely on the innovation. No more infrastructure management responsibilities. Go and focus on innovation. That's a fancy way of saying it. When we buy platform as a service, that's what we get. We can contribute our time on innovation and not just maintaining the infrastructure. And Azure especially is .NET friendly. Azure supports the .NET programming language, and it has, or it is built or designed, or it is optimized to work with old and new applications deployed using .NET programming framework. So if your application is .NET, most of the time you would end up picking Azure. I mean, if you try to compare, most of the time you would end up picking Azure as your cloud service provider. And the security offerings that Azure offers is it's designed based on the security development lifecycle, which is an industry-leading assurance process. When we buy services from Azure, it assures that the environment is designed based on security development lifecycle. And like I mentioned many times in the past, and I would like to mention it again, Azure has well thought about the hybrid environments, which a lot of other cloud providers have failed. So it's very easy to set up an hybrid environment, to migrate the data or not to migrate the data and still run a hybrid environment. They work seamlessly with Azure, because Azure provides seamless connection across on-premises data centers and the public cloud. It also has a very gentle learning curve. If you look at the documentation, it's picture rich, and the documentations are neat and clear. It would encourage you to learn more. It would encourage you to think and imagine and try easily get a grasp of how services work. So it has a very gentle learning curve. Azure allows the utilization of technologies that several businesses have used for years. So there is a big history behind it. It has a very gentle learning curve. The certifications, the documentations, the stage-by-stage certification levels, it's all very gentle learning curve, which is generally missing in other cloud service providers. Now, this would really impress the CTOs or people working in finance and budgeting. If an organization is already using Microsoft software, they can definitely go and avail or be bold and ask for a discount that can reduce the overall Azure spending. In other words, overall pricing of the Azure. So that's what helped, or they are the information that helped the CEO pick Azure as his cloud service provider. And then the CEO goes on and talks about the different companies that are currently using Azure, and they are definitely using Azure for a reason, like Pixar, Boeing, Samsung, EasyJet, Xerox, BMW, 3M. They are major multinational, multi-billion companies. They rely, run, operate their IT in Azure. and this CEO has a thought that his IT person is still not very convinced unless and until he shows him a visual of how easy things are in Azure. So he goes on and explains about a practical application of Azure, which is what exactly I'm going to show you as well. All right, a quick project on building an Azure app using or building a .NET application in Azure Web App and making it connect to an SQL database will solidify all the knowledge that we have gained so far. So this is what we're going to do. I have an Azure account open, as you see, logged in, and everything is fresh here. Let me go to resource group. There's nothing in there. It's kind of fresh. All right, I'm logged in, and this is what we're going to do. So we're going to create an application like this, which is nothing but an to-do application, a to-do list application, which is going to run from the web app, get information from us, and save it in the database that's connected to it. So you can already see it's a two-tier application, web and DB. All right. So let me go back to my Azure account. The first thing is to create an resource group. Let's give it a meaningful name. Let's call it Azure Simplilearn. All right. And it's going to be a free trial. And the location, pick one that's nearest to you or wherever you want to launch your application. Now for this use case, I'm going to pick Central US and create. It's going to take a while to get created. There you go. It's created. It's called Azure Simplilearn. Now what do we need? We need an web app and a separate SQL database. Let's first get our web app running. So go to App Services and then click on Add. It's not the web app plus SQL that we want. We want web app alone for this example. So let's create an web app. Give it a quick name. Let's call it Azure Simplilearn. The subscription is free trial. And I'm going to use my existing resource group, a resource group that we created some time back. It's going to run out of Windows, and we're going to publish the code. All set, we can create it. All right, while this is running, let me create my database. All right, SQL database, create a database. Give it a name. Let's call it Azure Simplilearn DB. Put it in our existing resource group that we created. It's going to be a blank database, all right? And it's going to require some settings like the name of the server and the admin login, the password that goes along, and in which location this is going to be created. The server name is going to be Azure Simplilearn DB. That's the server name. And the admin login can be, what can be the admin login name? Let's see. So let's call it Simplilearn. That's my admin login name. And let me pick a password. Click on create. So what have we done so far? We have created an web app and we have created a database in the resource group that we have created. So if I go to resource group, it's going to take some time before things show up. So if I go to my resource group, I only have one resource group as of now, Azure Simplilearn, and there I have a bunch of resources being created. It's still being created. Right. In the meantime, I have my application right here that's running out of or that's in Visual Studio as of now. Right. So once the infrastructure is set and ready in the Azure console, we're going to go back to Visual Studio, feed these inputs in the Visual Studio so the code knows what the database is, the credentials to log into the database, stuff like that. So we're going to feed those information in Visual Studio. By that, we're actually feeding it into the application, and then we're going to run it from there. Deploying these applications takes quite a while. We really got to be patient. Right, now we have all the resources that we need for the application to run. Here's my database, and here's my app service. There's one more thing we need to do, that is create an firewall exception rule. So one more thing needed is to create an firewall exception rule, right? So the application is going to run from my local desktop, and it's going to connect to the database, right? So let's add an exception rule by simply adding the client IP. It's going to pick my IP, the IP of the laptop I'm using as of now, and it's going to create an exception to access the database. So that's done. Now we can go back to our Visual Studio. I already have a couple of apps running, or a couple of configurations pushed from Visual Studio. I'm going to clean that up. If you're doing it for the first time, you may not need to do this. Alright, so let's start from the scratch. This is very similar to how you would be doing in your environment. Alright, so we're going to select an existing Azure app service. Now before that, I have logged in. As you can see, I have logged in with my credentials. So it's going to pull few things automatically from my Azure account. So in this case, I'm going to use an existing Azure app. So select existing and then click on publish. Alright, if you recall, these are the very same resources that we created a while back. Right, we have clicked on save and it's running, kind of validating the code, and it's going to come up with an URL. Now initially the URL is not going to work because we haven't mapped the application to the database. So that would be the next thing. Alright, so the app has been published and it's running from my web app as of now. It's going to throw an error. Like you see, it's throwing an error. That's because we haven't mapped the app and the DB together. So let's do that. Alright, let's do that. So let's go to Server Explorer. This is where we're going to see our databases that we have created. Now let's quickly verify that. Go back to the resource group, right? Appropriate resource group, which is right here. And here I have my database, Azure Simplilearn database. Right, it has some issues connecting to my database. Give me a quick moment. Let's fix it. Alright, so we'll have to map the database into this application. Alright, so let's go to the Solution Explorer, click on Publish, and a page like this gets shown, and from here we can go to Configure. Here is our web app, alright, with all its credentials. Let's validate the connection, number 1. Alright, and then click on Next. This is my DB connection string, right, which the app is going to use to connect to my DB. Now, if you recall, our DB was Azure Simplilearn DB, and that's not being shown here. So let's fix that. right? So let's fix that. Click on configure, and here let's put our DB servers URL. Now before that, let's change this to SQL Server. All right, and then in here put the DB's URL. So go back to Azure. Here is my DB or server's name. Put that here, right? The username to connect to the server, that's right here. Put that in, and the password to connect to the server, let's put that in. All right, it's trying to connect to our Azure portal or the Azure infrastructure, and here is my database. If you recall, it's Azure SLDB. That's the name of the database. Let's test the connection. Connection is good. Click on OK. So now it's showing up correctly. Azure Simplilearn DB, that's the name of the database that we created. Now it's configured. All right, let's modify the data connections. Right, let's map it to the appropriate database again. All right, so our name of the database is Azure Simplilearn DB, and then it's going to be SQL Server. That's the data source. The username is Simplilearn, and the password is what we have given in the beginning. All right, let's validate the connection. It's good. Click OK. Now we're all set and ready to publish our application again. Now the application knows how to connect to the database. We have educated it with the correct connection strings, the DNS name, the username, and the password for the application to connect to the database. So Visual Studio is building this project, and once it is up and running, we'll be prompted with an URL to connect, and anytime we put or we give inputs to the URL, that's going to receive the input and save it in the database. Alright, so here is my to-do list app, and I can start creating to-do list for myself. Alright, so I have the items already listed. I can create an entry, and these entries get stored in the database. I can create another entry, take the dog for a walk. That's gonna get stored. I can create another entry, book tickets for scientific exhibition, and that's going to receive and put that in the database. And that concludes our session. So through this session we saw how I can use Azure services to create a web app and connect that to the DB instance, and how those two services which are decoupled by default, which are separate by default, how I can use the connection strings to make connection between the app server and the database and be able to create an working app.
Hello everyone, welcome back to the channel. Today I want to take you on a journey that could transform your career, much like how cloud computing has transformed some of the world's most innovative companies. Imagine Netflix, once a DVD rental service, transforming into a streaming giant capable of delivering high-definition content to millions of users simultaneously. Or consider Airbnb, which has used cloud computing to manage listings and bookings for millions of properties around the globe, providing a seamless experience for hosts and travelers alike. Both Netflix and Airbnb utilized cloud technologies to efficiently scale their businesses, manage large volumes of data, and ensure high availability and performance. So, by transitioning from traditional, costly, and inflexible on premises infrastructure to scalable cloud environments, they significantly reduced cost, accelerated innovation, and improved user experience in real time. Now, you might think that working on such impactful projects requires years of experience and advanced degrees. But there's the good news, guys. With the right approach, you can start a career in cloud engineering in just 3 months, even if you are starting from scratch. In this video, I will outline a clear, actionable plan that uses entirely free online resources to get you there. We will cover the essential skills you need to learn, the certifications that can help validate your knowledge, and practical projects that will make your resumes stand out. So if you're ready to dive into the world of cloud computing and perhaps one day contribute to the next big thing in tech, so stay tuned, guys. So let's get started. And the number one point you should start with is starting your cloud journey. So transitioning into cloud engineering may seem daunting, especially if you are new to this field. The first step is understanding why this is a valuable career move. The cloud industry is booming with a projected market value of $800 billion by 2025 and the potential to grow even further. This growth means a constant demand for skilled professionals, making it an excellent time to enter the field. Now that we understand the industry's potential, the next question is, where should you start? So you should choose a cloud provider. So choosing a cloud provider is a critical decision as it shapes your learning path and future jobs opportunities. So the three major players are AWS, Azure, and Google Cloud Platform, GCP. So starting with AWS, so AWS, that is Amazon Web Services, is often recommended for beginners because it has the largest market share and a wide range of services, which translates into more job opportunities. Now coming to Azure, that is another strong option, especially if you're targeting jobs in enterprises that use Microsoft technologies. Now coming to GCP, that is Google Cloud Platform, and it is gaining popularity and offers excellent features, especially in data analytics and machine learning. For beginners, AWS is popular choice due to its widespread use and extensive documentation. However, it's important to research the demand in your local job market and consider your own interest when making a decision. And with the cloud provider chosen, the next step is to build a strong foundation in the fundamental technologies that underpin cloud computing. So now, before diving into cloud-specific services, it's essential to understand the foundational technologies that cloud computing relies on. These include, number one comes networking. So understanding how data moves across networks is crucial for setting up and managing cloud infrastructure. Then comes operating systems. Familiarity with operating systems, particularly Linux, is essential as most cloud environments run on Linux servers. Then comes virtualization. So this is the process of creating virtual instances of physical hardware. That's a core concept in cloud computing. And then comes databases. So knowledge of databases, both relational and non-relational, is critical for managing data in the cloud. So with these foundational skills in place, you are now ready to explore cloud-specific learning paths. So let's start with certifications. So certifications can validate your knowledge and make you stand out in the job market. For AWS, starting with the AWS Cloud Practitioner certification is advisable. This certification provides a broad overview of cloud concepts and AWS services. It covers key areas such as compute services, storage options, security measures, networking capabilities, and billing and pricing structures. Now coming back, while certifications are valuable, they need to be complemented with practical, hands-on experience to truly demonstrate your skills. Here comes building projects or hands-on practice. So building projects is the most effective way to apply what you have learned and to demonstrate your abilities to potential employers. So here are a few beginner-friendly projects to consider. Number one is setting up virtual machines. So start by launching an EC2 instance on AWS. Learn about the different instance types, configurations, and the basics of server management. Then comes the next project, that is cloud storage systems. So experiment with services like S3 for object storage and RDS for relational databases. Document the use cases and differences between these services. Then deploy a web application. Host a static website using S3 and CloudFront, which will teach you about web hosting, content delivery, and the basics of DNS management with Route 53. Initially, you can use the AWS console for these tasks, but as you progress, try implementing these projects using infrastructure as code tools like Terraform. This approach not only deepens your understanding but also aligns with industry best practices. In addition to practical projects, having some coding knowledge can greatly enhance your capabilities as a cloud engineer. So now we'll see how you can learn to code. While not always mandatory, coding skills can significantly enhance your effectiveness as a cloud engineer. Languages like Python and Bash are particularly useful for scripting and automation. Even a basic understanding can help with tasks such as writing scripts for server automation, managing cloud services or resources programmatically, then implementing infrastructure as code. For those new to coding, check out Simplilearn videos on YouTube, which offers excellent starting points. Coding skills not only make you more versatile but also open up opportunities to specialize in areas like DevOps or cloud native development. And once you have built your skills and some projects, it's time to start with the job hunting process. That is, building your profile. Creating a strong online presence is crucial when job hunting. Your LinkedIn profile should clearly reflect your new skills, certifications, and projects. So here are some tips. Number one is optimize your LinkedIn profile. That is, include a professional photo, an engaging summary, and detailed description of your projects. Then comes network actively. Connect with professionals in the field, join cloud computing groups, and participate in discussions. And then comes apply strategically. Tailor your resume for each job application, highlighting the skills and projects that align with the job description. Applying for jobs can be a number game, so be persistent. It's also helpful to reach out to recruiters or hiring managers directly to express your interest in the role. As you start to gain experience in your first cloud role, consider specializing in a niche area to advance your career. And then comes specializing and continuous learning. So specializing in a particular area of cloud computing can make you more valuable and increase your earning potential. Possible specializations include DevOps, that is, it focuses on automation, continuous integration, and continuous deployment practices. Then comes serverless computing, work with functions as a service, that is FAS, and other serverless architectures. And then comes security. Specialize in cloud security to protect data and infrastructure. The cloud industry is dynamic with new tools and technologies emerging regularly. So continuous learning is key, so stay updated through online courses, webinars, and industry news. Finally, remember that the journey into cloud engineering is continuous and ever evolving. So if we talk about resources, so embarking on a career in cloud engineering is challenging but highly rewarding. You realize free resources like YouTube tutorials, community forums, and documentation to guide your learning.
Hello, this is Matthew from Simplilearn, and today we're going to go through a complete end-to-end journey on what it takes to set up a DevOps team. We're going to go through what we need to be able to do to go to DevOps, what the arguments are and why you need to do DevOps, and then we'll actually go through all the individual tools you need to be able to successfully implement DevOps within your organization. In addition to that, we're also going to take time and go through each of those tools so you get a good understanding of a step-by-step instructions on how to do basic setup of each of those tools. So let's get started. So what was DevOps before? So what was the process that we took for doing delivery before DevOps? Well, it was a model called waterfall, and waterfall was a very traditional approach to actually building out solutions. And the reason why it's called waterfall is that you break out all the individual requirements and individual sections of a project and they cascade off each other. So if we look at the breakdown, we have requirements design, we have implementation, we have verification, we have maintenance, you'll have user acceptance testing. This is all based on the software development lifecycle model, or SDLC, and it's been around for quite some time and is still used by a lot of companies today. The challenge you had with the waterfall model is that it really is a very long, drawn out model for actually building and delivering solutions. So it took a very long time to actually write code and then deploy the code. It was very difficult to actually identify problems within the code and provide feedback to the development team on what to fix. And this really was a very time consuming. We're talking about months, sometimes years, for projects to actually go through a waterfall model process. So along came a new method of being able to do delivery, and it's called Agile. And the Agile approach is a way of being able to take the actual work that's done in a waterfall model and compress it down into small iterations. And what we would do is a fundamental change is that you would actually take teams that were disparate and as part of the individual cascades within a waterfall project, and you actually bring them together. So you have your requirements team person, design, developer, and release management team all together in one group working on an iteration. The great thing about Agile is that you took a process that was weeks or months or even years in length, as it was with Waterfall, and you reduce it down to 2 or 4 week sprints, depending on the cadence for your team. Typically, you have a 2-week sprint, and then the goal is that at the end of each sprint, or sometimes every other sprint, you would do a software release, and so that customers were getting the software much faster. The problem that we still ran into though with Agile is fundamentally similar to what we were having with Waterfall. You have your DevOps person working on code on their system and it'd be working great on their computer, and then you have the operations person who's migrating the code from the developer's environment, the test environment, to the production environment, and you would run into issues where the code simply wasn't working. And there's a lot of reasons why that would happen. The actual developer environment would often be very different or would have different dependencies in it. So the hardware, the software, there may be additional applications that were installed on the operating system that simply hadn't been transferred over to the operations environment. And so what you would have is a disconnect between the developer environment and the operations environment, making it difficult to actually roll out code. So you'd run into a program where when you rolled out code, you'd have to have a rollback plan in case the code wouldn't work in production. And so each release became an event where everybody got very stressed about the actual event of releasing code because you didn't know whether it was going to work. So DevOps really looks to address and solve a lot of these problems. So the key word that you'll often hear with DevOps is continuous integration. And what that means is essentially that as a developer is working on their code is constantly being tested against not just the actual code itself with unit testing, but the environment with which it's going to be released in. And the goal from a DevOps model is that the breakdown of communication that happens with Waterfall and Agile, where developers and operations teams aren't working in the same environment, is being removed, and you're able to provide a continuous and contiguous environment between the developer and the actual operating model. So the reality is when the developer is working on their code, they're actually working in an environment that is identical to the production environment. And so when the actual operations person comes to actually do releases for the code, and you can see some teams are doing as many as 20 to even up to 50 releases to production environments every single day, you're able to guarantee that the actual code itself will work, and releases go from being a stressful event to a byproduct of good testing and good setup and structure for how you actually build out your solutions. So what we're seeing here, so the goal is that as a developer and as an operations person, that the code is working continuously in both environments. You have continuous integration and continuous delivery. So simply put, what we're able to do is we're able to eliminate the problem of the operation environment not being in sync with the development environment. And this is an improvement on Agile. And this is not to say that Waterfall or Agile are wrong as delivery models. What it is just a maturity of the ability to deliver solutions. And DevOps is just another rung in that maturity curve, using tools that are available to us now that 5-10 years ago simply weren't available. So the goal is for you as a team to move to a DevOps model where you can implement continuous releases on your software as long as you're using the tools that are available. And the good news is those tools are open source tools. So let's go through some of the benefits of why you'd want to go and use DevOps. So, essentially, what's in it for you? So over the next few slides, we're going to go through what is DevOps. We're going to go through the benefits of DevOps. So in the last few slides, you've actually seen, what is DevOps and the benefits of DevOps along with the life cycle. But we're also going to start digging into the tools that you have that are useful for DevOps. And we're going to focus in on 7 tools that can provide an end-to-end infrastructure for delivering DevOps solutions. There are significantly more tools available on the market, but these are 7 of the most popular for each of their categories. So DevOps really is an essential collaboration between the development team and the operations team. These are teams that have in past been somewhat at conflict with each other, and what you have now is an opportunity where those teams can now work continuously with each other. The expectation with DevOps is that it will continue to mature. Indeed, you're actually even seeing some groups which are now called DevSecOps, where they're integrating security as part of the delivery between the development team and the operations team. The bottom line is a DevOps engineer is highly in demand. The demand for a DevOps engineer is literally going through the roof, with salaries going up exponentially around that. So let's dig into some of the benefits of DevOps. It's not just a new catchphrase, it's actually got significant value and how you can speed up delivery of your software. So the benefits of DevOps can really be broken up into a number of key areas. First of all, we have continuous delivery of software, which allows you to continuously release new features with the security and understanding that the software going out is of high quality. It allows the teams that are working on the software delivery within your organization to more effectively collaborate with each other so that you're all talking from the same page and understanding of what needs to be delivered. The deployment process itself moves from being an event where there's a lot of stress and there's a lot of contingency plans to being a much easier deployment. The efficiency within the actual code that you're writing and the ability to scale up using the different tools that are available allows you to be able to bring in and scale up and reduce the teams you have running the software as needed. Errors can be fixed much earlier and more quickly and can be caught before anything gets pushed out to the production environment. And fundamentally, what we're looking for is improving the security of the actual releases. So the actual concept of security is center to all the work you're doing. And then finally, what really allows you to reduce the number of errors is that there is much less manual intervention. There is a greater reliance on scripted environments that you can actually test and validate for their security, reliability, and uptime efficiency. So let's talk a little bit about the life cycle of a DevOps. So the very first step that you'll take is to actually build out a build and test environment. And this is a continuous build and test environment. And this is managed with the first step of your source code. Once you move through that, then you're looking at continuous integration, which means that every time somebody checks in their code, they're validating that the code actually can run in the production environment. Once you've actually then passed the continuous integration and the testing that you have with your code, you're looking at continuous deployment. If the code works and is available to be released into the production environment, let's go ahead and release it. And once you actually have release code, then you want to be able to validate that your environment is working efficiently. You may release code that is a new feature within your application, and customers may then gravitate immediately to that new feature. If they do, you want to be able to ensure that the code is working and, more importantly, that the infrastructure is there to support. And then finally, you're looking at software released as a continuous event. And then you go back to the beginning. You start working on more code. You run it through your build environment and continuous integration, deployment, continuous monitoring, and keep that cycle moving. So let's dig into the tools that you as a DevOps engineer would need to learn. If we break down the environment that we have, all the way from source code management to software release, there are a number of key tools that you want to be able to use. So for instance, source code management, Git is an open source tool that you would want to use for managing your code. The continuous build and test environment will be managed with Maven and Selenium. Integration with the environments that you're working on is managed through Jenkins. The actual deployment to your production environments would be managed with products such as Ansible and Docker. And then the monitoring of your network would be used with tools like Nagios. The thing that you have to remember with all these tools is that they're open source tools. There is no licensing that you have to purchase. Some of the tools will have pro level licensing that you can choose to select. But to get started, all of these are open source tools you can actually start using for free right now. So let's dig into Git. So let's look at the challenge that Git is able to address. So before Git, and if you had a team of developers that were working on different pieces of code, one of the key problems you have is that there was no collaboration between the team. And the challenge you have is that with version control, it was difficult and often required having to check into large environments, or you had very quasi version control environments. It was time consuming. Often there were problems that what would happen if the version control server would crash and there wasn't a backup, then you'd have to kind of essentially go back to square zero to see whether or not you actually had to do the work again. So let's look at what Git does to actually solve this. So first of all, one of the things that Git does is it makes team collaboration much easier. The software itself is more effectively documented and more effectively maintained. The actual code that actually gets worked on by each developer in a Git environment is the complete code. So it makes it much easier for backups and for sharing content amongst each developer. So the way in which Git is able to accomplish this is that it is essentially a distributed version control solution. And what that means is that when you have multiple developers, yes, you do have a Git remote hub that you connect and are able to upload and download different branches of the code that you're working on. But essentially, as a developer, when you actually have the code, you actually have all of the code, and you're able to manage it directly from your local PC or your local development machine without having to worry too much about the network or the server actually going down. So some of the key things in which Git is really good at, it is a software management tool. It's designed from the ground up to manage code development. It does track the changes on that code easily and effectively. It makes it easy for you as a developer to track your code. The ability for multiple developers to work together is much easier in comparison to other solutions. And this is really the key success point with Git, is that it allows for non-linear code development. So you can actually have people working on different areas of the code that may be released at different times because of what they're working on. So if we actually break down the architecture of Git, it really falls into 4 key areas of a working directory, a local staging area, a local repository, and a remote repository. So the process you would go through is you would add files to the staging area from your working directory, and this would be usually the git add command. And then from your staging area, when you're ready to actually then commit those files to a local repository, you would use the git commit command. And then from there, you would actually then push your local repository out to the remote repository for a final commit to the remote repository. And this allows then the rest of the team to pull down your latest final changes. So you can be working on your code locally, and you can be using your local staging area, local repository, and when you're ready to commit your work, you can commit it. And then as soon as it's committed, the rest of the team can then pull down the latest changes that you have worked on. And this allows for a complete and holistic checkout and check-in process. And then sometimes you want to be able to go through and then take the checked out code that you're pulling out and merge it with your local code. And the merge process always ensures that you are working on the latest and best version of the code, and everybody on the team is being consistent with the communication of the actual code that's being delivered. Okay, so what we're going to do is we're going to validate that we have Git running on our computer. We're going to then create a directory, add a file to that directory, make some changes to that file, and then use the commit commands to be able to check in the files and validate changes that have been made. So first thing we do is we're going to see if we have git installed, and to do that you just use the command git version and what you'll git -- version, and they'll actually then give you the version number. And now we're going to create a new folder, so mkdir green, and that'll create a new folder, and we'll move our cursor into the green folder by changing the directory. And we can go back into Windows and we can validate that that directory is actually there. So here we go. Let's have a look. We should see it. There's the green folder. If I double click into that, you'll see there's nothing in the folder right now. So what we have to do is we actually have to add the folder as part of a Git project. And so we're going to use our git initiate init, and they'll actually initialize the folder and make it a Git repository. And so let's go ahead and create a file that'll actually go inside of that new initialized folder. And you'll see that there's a .git folder that's been added. So the new text file we're going to create is going to be called class, and it'll actually be class.txt. The extension is hidden by default. In the text file, we're just going to type in the text, welcome to Simplilearn, and save that. Now let's go ahead and check the status of that file in Git. So let's do git status, and you'll see that it says yes, there's a file there, but it hasn't been committed to the repository. That's why it's in red. So what we have to do now is commit the file to the repository, and it won't be able to track any changes that we do to that file. So let's go ahead and commit the file. So we do commit add class.txt, and they'll add that to the repository, and there we are, it's added. And the final step is we want to do is commit it, and let's do git. So let's do git commit -m, put in, this will be our first commit, and this is the description, and so it actually shows us committing the file. It's the only item in the folder. So now we can go over to the file that we just created, and we can make some changes to it. So let's open up the file. So it says welcome to Simplilearn. Let's put in some text afterwards that says this is my demo, and we'll save that, close that. And now if we go back to Git, we can do a compare and contrast between the original file that we committed and the new updates that we've just done. And we can check the difference by using git diff, and what you'll see is the red text was the original text, and the green text is now the new text that's been added. And so that shows you how you can actually go and create a new Git repository, go through adding files, committing the files into the repository, and being able to see the different version controls. Let's move on to Maven. So why use Maven? So why use Maven? Well, let's look at some of the things that you would have done in the past if you actually building out the tasks. So let's break down what you would have done before using Maven if you were to create a game of football using Java. You would actually have to go out, and for your actual game, you'd have to collect all of the different components needed within the Java environment to make sure that everything would work correctly. And if you made the slightest mistake, you wouldn't get the right output that you needed. The actual process of building and deploying a project really would take quite a lot of time. After Maven allows you to be able to take templates that are stored locally and be able to use those to be able to improve the efficiency of being able to build out your environment by removing dependencies within the application. It makes it a lot easier for you to be able to focus on just writing the code for your game or your solution rather than having to manage the environment within which that solution would be deployed. Now, the focus within Maven is that it is an automation tool, and it's used for projects that have a short period of time. So as you're starting on your environment for building out solutions, Maven is great to get started with. And then if you need to have longer term projects, then you can look at other alternative tools on the market. So 4 key areas that you want to focus on and why Maven can help you is that it does allow for efficient parallel builds to be run concurrently. It's really easy to use. You can get up and started with Maven very quickly. You do have fast access to new features and new configurations quickly within your environment, and the build process that will allow you to be able to visualize your code happens very quickly. The actual architecture of Maven is that the execution and commands are managed through what's known as a POM file. The POM file itself is a project object model, and it's an XML file that actually has the details for the project and the configuration for the build environment. POM file itself will then fetch dependencies from the local repository and will apply any plugins that you may have also included within your Maven environment. The goal is that your software is built much more controlled manner. So what we're going to do now is we're going to show you how to go through and run your very first project using Maven. The first steps you're going to have to do is make sure that you have the latest JDK installed on your computer. So we're going to go ahead and open up our web browser and get this installed on your computer. So we're going to type in JDK download into our Chrome web browser and go to the Oracle website, which allows us to download the JDK. And because we're running this on Windows, we're going to download the Windows version of the JDK. And once you have that installed, so the next step is to actually then go ahead and download the Maven files. So it's going to take us to the mavenapache.org website, where you can actually go ahead and download the version of Maven that you need for your operating system. We're going to go ahead and download the zip file instead of just an executable file. Now this will give you more control over how you install it onto your Windows PC. After the file has been downloaded, we want to go ahead and extract the entire file, so you have the unzipped folder running on your computer. So one of the things that we're going to have to do is go through and set a number of system variables for the JDK and for the path to your Maven files. And to do that, you want to go into your control panel and select the system security and then system settings, and then go into advanced system settings. This will give you access to the edit system variables setting that you're looking for. So we're going to go down to the path variable, and you'll see already that we have pasted in the link to the JDK right there underneath the variable value. If you've installed the JDK, it's likely that it's already installed this path for you correctly. The good news is it's actually fairly easy to install the path to Maven and to the JDK, because all you have to do is copy the path for where the folder is located on your system and just paste it into a variable value under the edit systems variable file system. And that should now get us all of the files, and we can see that we have our extracted folder already on our desktop there. And the system path is now set to where the Maven folder is located. So we also have to go into system protection and set the system path to your Maven folder. Now we have to go ahead and do a user variable that also links to the path of the Maven files. So what we're doing right now is we're just validating that all the files have been extracted correctly. They have, which is good. We can now go ahead and link to this Maven folder. All right, so now what we're going to do is we're going to move over to command prompt. And this is where we're going to do most of our work from here on out. First command we're going to do is mv. So we're going to go ahead and create a new user variable, and we're going to type in, we're going to call this one m2 dash, and then we'll put in the path to the Apache Maven folder. You should be able to use m2-home for your project, but if it's not, you can always use the variable name maven-home. And that will do exactly the same as M2. We're going to do both here just so we have a backup. So we're going to open up command prompt and we're going to see if Maven is installed. We do that by writing mvn-version. And here we are, yes. So now we're going to go ahead and create our first Maven project. And the first part of creating the Maven project is actually the directory in which we will store the files that will be used to create for our project. So we're just going to go ahead into the folder and we're going to create a new directory, and we're going to call this one, and we're going to call it Simplilearn. And we can just copy the path for that. So I'm going to write the correct path for us. So we're going to change directory, cd, and copy the file location over. Alright, we are now moved ourselves over to the Simplilearn folder, and we'll be able to install the POM file, which is what all the instructions for Maven are stored in, into this area. So to do that, we're actually going to use a template that's already been created by Maven, and this is going to be the MVN archetype template. And so you just do MVN archetype :generate, and this will go ahead and create all the files for us. So there can be quite a few files, and they're all being downloaded from the Maven website. So it can take some time, but as you see, we've gone ahead and all the files have downloaded, and we have everything up and running correctly inside of our environment on command line and command prompt. So we'll have some values that we do have to set. The first one is group ID, and we're going to call this one com.mav, and then the next one is going to be artifact ID, and this is going to be mav-project, hit return, and then version is going to be 1.0-snapshot. We'll just put in the same value for this version, which will be 1.0-snapshot. And the package, we're going to call this one com.mav.demo. And then we'll select yes or Y to create the environment, and it will build the environment for us. And what we have now is we have this screen which shows everything is up and running for us. And we have a successful build. So let's go into the Maven folder and just see that we have our Simplilearn folder. Let's open it up and see what's in there. So we double click into that directory. Yep, and there we are, starting to see some of our files. So it's the same project names there as mav-project. And then we have our POM file that's in there, which is fantastic. Under the source folder, we'll actually see the demo, and we have our app under the demo app. We have our test file as well. So in the main folder, we have a file that's called the POM file, and that really is the most important file that you need for your project. You'll now go in, you'll be able to set all your settings inside of that POM file. But that's it. That's what we have done here. Is we've gone through all the setup that allows you to make sure you have the right files running on your computer, the right files to download from the Maven website, how to install all of the files, the settings you need to make on your Windows computer, and then all the settings that need to be done in the command line to be able to run the application. And then from here, you can actually start running Maven. Now let's look at Selenium as we start looking at testing. So before Selenium, if you wanted to run testing, and particularly if you wanted to do sequential testing, it would take up a lot of time. You'd have to run one test, then a second test, and then all of the other tests, and the actual time elapsed would be quite significant. With Selenium, you're actually able to do parallel testing. So instead of looking at the amount of time it would take to actually run a test and run the test sequentially, the length of time to actually run your test is based on the length of the longest running test, of which in this example, the longest running test is 2 minutes. Now, one of the things that you'll notice with Selenium is that its focus is on web applications, and it is an open source tool, and it's really good at regression and functional testing of web applications. If you're doing a mobile application or if you're doing an IoT application, there are other tools you can use on the market as well. But if you are new to DevOps and you're setting up your first DevOps environment, Selenium is a great place to start, and web applications are mature and allow you to be able to test out and validate the concept of continuous testing in your environment. So 4 key takeaways for Selenium. It really is fast. I mean, fast execution, it's highly accurate, so you can always validate that what you're doing will work correctly, and feedback can be sent straight back to the developer if their code doesn't pass the test. It allows you to script in multiple languages. Again, this is a great way for you to test. The focus is on web applications, but you can test in multiple languages used for web applications, and most importantly, allows for parallel test execution, which speeds up the whole test process significantly. If we're actually to break down the architecture of Selenium, what you'll find is the actual libraries that you can use for Selenium run in C#, Java, Python, JavaScript, PHP. These are the common languages used to build out web applications. The actual WebDriver itself is an API driver, which is fantastic because it makes it easier for you to integrate Selenium with applications through API. And you can run the solution through different web browsers, the most popular being Firefox, Chrome, and Edge. So to focus, the Selenium WebDriver codes are being used to build out the client libraries that make it to allow you to be able to build solutions across multiple web application environments. The WebDriver application interface is used to integrate with the application to make it easy for testing. The WebDriver service provides an immutable stateless environment that makes it very easy for you to be able to use protocols such as JSON to wire up your test environment. The driver manages the communication between the browsers and the wire protocol that's used for JSON within the web browser itself. And then the actual commands are then run through the web browser for you to be able to get your results. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here. I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download, and here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version, and we've gone ahead and done that already. So we have everything running, and now the next step is for us to install all of this great content. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here. I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download. And here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version, and we've gone ahead and done that already. So we have everything running, and now the next step is for us to install all of this great content. So we're just going to go ahead and open up the Eclipse environment, and it always takes a moment to launch Eclipse. And we're going to go ahead and create a new project, and we're going to call our project XYZ. I think that should be fine. And this is just a test after all. And we're going to go ahead and create a new class file by right-clicking and select New Class. And we're going to go in here and we're going to give the class file a name of Simplilearn. And I don't see the Finish button being selected, so maybe we need to select some other options here. Oh, you know, I think it could be the package name. Yeah, let me go ahead and change the package name, and I'm going to change that to QWE. Yep, and the Finish button has now been highlighted. I can select that. I can go select that and select Finish. And we now have a test page that's up and running, but what we have to do is to validate that Selenium is actually part of the project. So to do that, we're going to go to the source, to the actual source XYZ file, and right click on it, and we want to validate that all the files are there correctly. And so we're going to see that we have the libraries are there. Yep, there's Selenium. If it's not there, you can select add external files and find the Selenium jar file, select open, and that would load that in there, and then you hit apply and close, and that would then apply it to your project. And now we can actually start writing the code part. So we're going to put this code in the public static void section. And the first command is going to be a system.setProperty, and we want to make sure that we're configuring the WebDriver for Chromium correctly. So we're going to do WebDriver .chrome driver, and then the argument is actually going to be the full path, full network path to the Chromium driver that you have on your PC. So let's see, we have Chromium here. We want to copy that path. And so that paste that in. And then after we've pasted in the path, we have to make sure that we also put a link to the actual file that we want to execute, which in this case is chromedriver.exe. And then we want to make sure that the WebDriver is pointing to the new Chrome driver. And you'll notice that there's a couple of red colors on here, which means that we don't have all of the public classes imported correctly. So you can right click on that and select import the WebDriver and just select that real quick, and that adds the import correctly at the top of the page. And the same for Chrome driver. And that's just a very quick way when you're working in Eclipse to import additional files. So before we actually start our test, we want to make sure that we've actually cleared out any potential browser cookies that would be within the Chromium driver. So for that, we're actually going to go ahead and we're going to write a script that allows us to remove the cookies. So we want to do driver.manage and then delete all cookies. And the next line we're going to do is to actually have the web page that we're going to connect to open up in full screen mode. And for that to happen, we're going to go and actually use the window property, which is what I was writing before by mistake. And so this will allow us to go full screen. And now we need to pull in a web page. So we're going to get the get command. And what we're going to do is we're actually just going to pull in a web page from Amazon, which I just happen to have here. So I'm just going to go to the Amazon web page. And so I'm just going to copy the URL. Just need to copy HTTPS www.amazon.in or .com, wherever you're located. And so you can see that I've pulled in the Amazon web page, and then line 18 actually allows me to go and connect. So here we are, we have the Amazon web page that I'm pulling in. And then what I also want to do is I want to look for a specific ID in one of the elements. And so I have the driver, which is called find an element. And that allows me to look for any element that would be on the actual page. So here we have the HTML in the console screen, and I can actually then paste out an ID from the element that I want to use. So the find element is just the ID for each element, and most of them have them because they need it for JavaScript and CSS. So let's see, there's quite a few IDs, and we can select any of those. So what we have here is we have two-tab search text box, and then what that actually does is that finds the ID for the text box used for searching, and then we're going to use the send key command, which allows us to actually pre-fill in the search box, and we're going to use the test of Puma shoes. This is a fixed string, but you could actually put a variable in here if you want to pull strings from a database or an XML file. And then the next line on line 19 shows how long we're actually going to run the actual script for the search, which is only 10 seconds. And then once the 10 seconds has elapsed, we'll actually quit the script, which actually closes the web browser and takes us back into our screen here. And let's test that, make sure it's working. And everything's looking good. The web browser opens, which is what we expect. It goes to Amazon, fantastic. It now actually goes to the search screen and should fill in the Puma shoes. There we go, Puma shoes. And waits 10 seconds and it closes. And that's exactly what we were expecting. Now you can actually change the unit of time that you would have for the actual test. So if you wanted to see what was happening, so longer than 10 seconds, you can actually change the actual time or the actual metric. So in this instance, we got it as seconds and it's the unit of time, but you could do minutes or hours or microseconds. And you can change the keyword as well, so it could be jigsaws or anything that you wanted to check. But if you're actually building your own application, you want to be able to test your own data against your own application, that's where you put in that specific data. So let's look at the center, the heart of your DevOps environment, and that center is with Jenkins. So before Jenkins, developers would work on their code, and the code would then be checked into a source repository. You would then check for any issues, and then you would then send that code over to the operations team, and there would be a delay for actually delivering software. So the actual challenges developers had is that if they wanted to run any tests, they had to wait until their software was built, and there was a lot of problems in providing feedback, particularly if you had large teams working on software who actually had the error. The actual delivery of software was often delayed because of these key problems. So after Jenkins, what we actually have is the ability to be able to streamline this whole process. The build, test, and deploy happens continuously and are able to then notify developers and the actual specific developer of any errors that are detected, being able to speed up the delivery process much more efficiently. The focus of Jenkins is that it automates a continuous development, testing, and deployment environment. And it's open source. Jenkins is easy to install and configure. It's been around for many years now, and it is very mature. There are many plugins that you can use within Jenkins to be able to have the Jenkins product work with your environment. If there isn't a plugin, you can actually you can actually write your own plugins if a plugin doesn't exist. So you can actually continue and extend and invest in the Jenkins ecosystem, and it can be easily distributed across multiple machines. So let's break out the architecture of Jenkins. So Jenkins starts as a remote source code repository, and it then pulls out the code every time there is a commit from into the server master. The server master will then have a slave that will run on either Windows, Linux, or Mac OS to be able to distribute its load across those environments. And after it's actually gone through and run its test, it'll then send out a report. The goal of the report is to communicate back to the team what has passed and what has failed, the actual check-in process. Okay, so we're going to go ahead and show you how to install Jenkins on your local PC. So the first thing you want to do is check that you have Java installed. So we're just going to go into our system and see whether or not we have the Java JDK installed. You can do that by going into System Properties, Setting Advanced, and then Environment Settings. And there we are. We have Java JDK installed. And you want to just double check on the system variables to make sure that you have the Java_home installed correctly as well. And we have that installed. And under path, also make sure you have a link to the Java JDK as well. So we have everything installed. And what we're going to do is we're going to open up a command window and just do a double check right there. So open up command window, and we're just going to check that we have Java installed. So we do Java-version, and we have a version number that comes back. If we didn't have Java installed, we wouldn't get a Java version number come back. We'd actually have an error. So everything looks good. So the next thing we want to do is to go to the Jenkins website and download the files. So we're going to go to jenkins.io, and that's the official Jenkins website. And if you want to download, you just go to jenkins.io/download, or you can just type type into your search bar download Jenkins, and that will give you a link straight to the download page. And one of the things that you'll see is that there's lots of different versions for Jenkins, because Jenkins runs on pretty much most operating systems, including Windows, Linux, and Mac OS. But we want to select the Windows version. So we've already gone ahead and downloaded a zip file which contains all of the files that we need for Jenkins. And so that's the zip file, and we've expanded it. And what we want to do now is double click the installer file, and we'll go ahead and install that. So we've already installed this. So one of the things that we'll get is a message asking if we want to repair. You would actually get a install message because it'd be a fresh install for you. But once you've done that, it has all the files and all the settings correctly installed onto your Windows computer. And we do all of our commands for Jenkins through a web page that's run locally on your PC. And so you're going to type in localhost :8080, and when you do that, they'll actually take you to Jenkins running locally on your PC. And here we have our Jenkins dashboard. And we've already gone in and created some sample jobs, and you can see those listed on the on the right hand side of the screen. So let's go through some of the things you would want to set up here. So first of all, let's go into the Manage Jenkins screen, and that will actually, so we'll go to the Manage Jenkins tab on the left hand side to do some standard configuration settings. So we'll go into the configuration systems, and if you want to, if you're like remotely connecting to a remote Jenkins environment, you can actually install a JDK remotely on that machine if you want to. We already have the JDK environment already set up, so yeah, that's good here, so we don't need to do that. But you'll also see as you go through the list of applications that you have: Gradle, Ant, Maven, Docker, Git, and other tools that you would use in a DevOps environment. There are many other tools you can install through plugins as well. Let's have a look at one more setting here with the security. The default security is Jenkins' own user database. That probably is not allowed within your company due to security restrictions. So you can choose LDAP, which allows you to connect with your Active Directory configuration. Again, because there are so many plugins for Jenkins, there are plugins for SAML authentication as well as OAuth. So let's go ahead and start a new build job. And so we'll select a new item, and we're going to select demo 1 from that to create a new item. And we're going to use just a freestyle project because I just want to demo how you can actually create a build. Select OK. Description, gosh, what can we write here? We can put in Snippy demo. And we're not going to use source code for this one. We're going to do that in the next demo. But what we want to go down to is the job type. And we're going to, build, we can just do add for execute Windows batch command. And so let's just put in a very simple command. And so we're going to type in echo, open quotes, hello world. And then we'll put in the timestamp. So we'll put in date first and then time as part of our output. Close quotes. And we're going to save that. Also hit save. And that's our simple project. So what we want to do now is we want to actually go and select the build now command to actually run this project. Hit build now, and it'll take a couple of minutes for it to run. And here we are. This is our project, and we can actually now see the different builds that have happened. And if you look on the build history, you'll see the latest history shows when the build was executed. And if you click on that, you can actually start getting information such as the console output will actually provide information that we were asking for. So for instance, we have, first of all, we can see that the build was successful, and we see the output includes the hello all and date and time. So we're going to go ahead and create one more project where we can actually connect to a GitHub and use the Git command tool to be able to build a real project. So we're going to go ahead and create a new item, and we're going to call this one Jenkins. It's a freestyle project, and our description is demo using Git. So we're actually going to connect to GitHub. So to do that, we're going to go into Source Code Management tab, and we're going to select Git. And so we select that, we can actually now connect to GitHub. So to do that, you go to your GitHub account, and you want to go in and select the clone or download, and you get the URL link from there. So copy that, go back to Jenkins and add that in the repository URL. So you paste that in. And then for credentials, we want to add in our Jenkins credentials. And so just make sure you have those selected correctly. And we've select add, and then we just pull those from the drop down. And let's not change any of the other settings. And then for the build, we're actually going to be building a Java application. So it's a slightly different set of build commands. So we want to type in Java C for compile, and then space, and the file name is simply.java. And then you want to put Java and space simply on a new line. Save that. Again, this is a really simple application, but it gives you the understanding of what you need to do here. And so we saved it, and let's now go ahead and see if everything's working. We'll do the build now and see what happens. And here's our first build. We select that. We can go to the console output for details, and what we can actually see if we scroll down is that the finished output at the very end says success, which means everything was built correctly. And so that's how you're able to connect Jenkins with a Git repository. And the thing that's great with working with Jenkins is that it connects to so many different systems and really does become the central point of your DevOps toolset. So let's start looking at the operations side of the DevOps environment, and let's focus in on Docker. So before Docker, the problem you had as a developer, if you're working on a virtual machine, the actual virtual machine was your VM, was a very complex piece of software. So first of all, VMs have not been around for very long, and we're talking about less than 10 years. And the typical way of having a VM is that it's very heavy on usage on your computer. You essentially are running everything of the VM plus the tools to run the VM on your computer. With Docker, what you're able to control is the actual development environment you're working in. You don't have to be encumbered by all of the additional extraneous processing that a VM environment has. You're really stripped down to just the bare minimum that you need to have to run the environment using a containerized solution known as Docker. So Docker is essentially an OS level virtualization software. It is a maturity of the solutions that were started with virtual environments, and there are other solutions out there. Docker has become the de facto container solution that you can use for building out and guaranteeing that what the developer is building is going to be the same as what the operations team will use. So Docker itself is highly scalable and efficient. You can have many Docker environments running on a single piece of hardware. The boot up time is incredibly short. You can reuse the data volumes very, very easily. It's not complicated. And the actual applications are completely isolated. This is like a perfect sandbox environment. So let's dig through the architecture of Docker. So there are really two parts to Docker. There's the Docker engine and there's the Docker client. The Docker engine is comprised of the Docker CLI, which connects with the server daemon. The Docker client will then issue the commands to the Docker daemon. And then the Docker daemon will then interact with your system to be able to provide the tasks and tools needed for you to be able to build out your solution. The actual images that Docker uses are instructions for creating Docker containers. And the actual Docker container itself is a lightweight package that contains all the dependencies needed to run an application. Now, once you have created a container that is of value to your team, you want to be able to store that container so that other team members can use it. And this is where you would use a Docker registry to be able to host and distribute multiple Docker images. So in this video, we're going to go ahead and see how we can get Docker installed and running. So we're going to go ahead and open up our terminal window, and we want to validate whether or not Docker is installed. If you haven't installed Docker, you can actually go ahead and use the following command, and that is to enter in sudo apt install docker, and that will go ahead and run the command to install Docker. I already have Docker installed on my system, so I'm not going to do that right now, so I'm just going to delete that out. But what I am going to do is check to see what Docker images I have installed on my system. And to do that, I'm going to type in sudo docker images. And when I run this will actually show how many images I have. And right now I don't have any images at all. So when we go ahead and install an image, there are two ways you can create an image for your Docker environment. One is to get one from Docker Hub, and the other is to create your own image. Let's go ahead and get one from Docker Hub. And so the command line that we'd want to write is sudo docker pull redis colon, and after the colon we're going to actually write the name of the actual file that we're going to be connecting to from Docker. So I'm going to go ahead and go to Docker Hub, and I've already logged in with my user ID and account. So I'm going to go to Docker Hub, and it's hub.docker.com is the website address, and I'm already logged in with my Simplilearn account. And what you can actually see is different repositories that I have already created below. But I'm going to click the Explore button, and I can see the Redis image, and these are all the different commands that I can actually use, all the different variations that I can create. So I can do 5.0, I can do a 32-bit version, I can do a 4.0 version or a 3.8 version, or if I select latest, that will allow me to just pull the latest version even if it's updated. So I'm going to go back to my command line and do latest, and what's going to happen now is that we're actually going to pull the files live over the internet and create the Docker image. So this is going to take just a few minutes. Of course, if your internet speed is faster, then this will happen a lot faster. And here we are. We have everything downloaded, which is great. And so let's just go and check and see if the image has been added to Docker. So we do sudo docker images, and now you can actually see that we have the latest Redis image, and it's given the default image ID, and there's the size of the Docker image, and the tag is latest, so it's the latest version of Redis. And I'm just checking to see if there's any other images running, and no, there isn't. So let's go ahead and now create a container. And so the command for that is sudo docker run -d -p 0.0.0, I think it's .80:80 space redis latest, and let's run that. Got an error message. Okay, now you know that it's a real demo. This is really live. So I'm just going to clear the screen, and let's write that in again. So sudo docker run -d -p, and it's 0.0.0.0:8080 redis.latest, and there we are. Everything's up and running. Awesome. So let's just go ahead and check that we actually have the image running in Docker. So sudo docker ps, and there you can see that we actually have the latest Redis version, and it was created 16 seconds ago. We have a new container ID for it, and there's our port that we've created. And let's see if we can view all the running containers. And sudo docker ps-a, and there we are. And we created that container 42 seconds ago. But one of the things you'll notice is the name for the Docker is created automatically by Docker. And here we have Stupefied Engelbarts is the name. Let's change that name to something that's more meaningful for the work that we're doing. So that's actually fairly easy to do, and it's going to be our final task here. So we're going to type sudo docker, and the command is rename, and we want to copy over the old name, and then we put in the old name, and then you do a space, and then you put in what you want the new name to be, in which case we're going to make it Simplilearn. We run that command. That's good. Now let's validate that everything has been changed. So we're going to do sudo docker ps-a, just ps. And there we are. Everything has been renamed. And that gets you started working with Docker. Now let's move on to Ansible. So before Ansible, the ability to be able to deploy software across a network was pretty hard. You couldn't guarantee that your web servers were all consistent and that the database environments were consistent. This was okay if you had a small environment, but once you actually start getting into more complex environments, it became very difficult to manage. Ansible is code that allows you to be able to consistently and reliably create and stand up the environments that you need to be able to store your code for production. So whether or not you require one server environment or you need 1,000 server environments, using tools like Ansible will allow you to be able to consistently deploy out environments that all look the same. So essentially, Ansible is a configuration management tool, and it allows you to be able to deploy automatically to a large variety of environments. The actual tool itself is a push-based configuration tool. It is an agentless tool, so there is no communication coming back about the health of the environment. We actually have tools that we'll cover later on in the video that cover that. Ansible does have a consistency of its product performance, so you know that if you're using Ansible that it's going to work. It's just a very consistent product, and it uses SSH for very secure connections. So it doesn't matter whether or not you have 1 or 1,000 pieces of hardware you're looking to configure, you can actually be rest assured that there will be no security infringement because of the use of SSH. And we look into the architecture of Ansible. It's a very simple architecture. There is the Ansible management node that has playbooks which contain the instructions that you would have for your environment, and that playbook is then pushed out to all the different nodes that contain the hardware that you wish to configure. The actual module collection is the configuration code itself. The playbooks are the instructions of that configuration, and then the inventory is the document of the different groups and the hardware within those groups that you would be pushing out to. So we're going to go ahead and install Ansible onto the system here, and we're actually running our environment in a Linux environment right now. So we have a master environment and a standard node, but we're actually going to go into our terminal window and we're going to do everything on the master node. So the first steps we want to do is actually go ahead and install Ansible, and we're going to do that by installing sudo yum install ansible -y. And this goes ahead and downloads all the files that we need and starts to run the installation. And let's go ahead and see if it's installed correctly. So we're going to type in vi etc/ansible/hosts, and there we see we actually have a default Ansible hosts already up and running, which is fantastic. And we want to grab this IP address, which is Ansible servers, and then the IP address with the password and root access. And the IP will be specific to your local client. So this is my client system, so if I type in my config, I'll actually see that the IP address matches up, and then you want to make sure that the IP address is correct for your environment. And so this is essentially a node in the Ansible environment, and this is the IP address and the password for that node so we can access correctly. So we're going to hit colon at the bottom of the screen and take ourselves actually into Ansible. And what we're going to do now is create a playbook to be able to run a sample script. So we're going to call it vi sample.yml. And here we have a sample playbook. We have the name, we have the host, we have the root user, and we have the task. And in the task, you actually see that we're looking to create a virtual web page with the content of welcome, so that we can actually see that the web page is loading. And all of this is written with a very basic XML format called YML, which stands for yet another markup language. But it's very flexible and it's very easy to learn. So let's see if we can go ahead and actually run this playbook so you can actually see it in action. And so we're going to type in Ansible-playbook sample.yml, and this will run the sample YML script -- syntax -check. Then we type in Ansible-playbook sample.yml. So I had some issues there, so I'm going to try that again. And let's go in and write the command again. So Ansible-playbook sample.yml -syntax-check, and then run the actual playbook itself. And let's see if it works. Yes, everything's working. And it'll take a moment for everything to initialize. And now what we want to be able to do is go back to our web browser and see whether or not we were able to create that default web page with the word welcome in it. Because that was the command that we created in our playbook. And there we are, there's the word welcome, exactly as we planned. And we can go back and we can review the playbook that we created just to validate that. So let's go back into the screen here, and let's go in and look at the YAML page, and there we are. We see that the word welcome is there, exactly as we expected. Now let's step into our final area, which is network monitoring using a tool called Nagios. So before you had Nagios, sometimes you didn't know whether or not your network was working. In fact, the worst case scenario scenario was when your customers called up and said, hey, your website's not working. The challenges you had is that you didn't know how the usage of the server was being managed. You didn't know whether you were up to 80% usage, utilization on that server, or if you were at 50%. It was difficult to get that information easily. With Nagios, you're able to set up email notifications and other notifications that allow you to stay ahead of issues that you would have within your environment. So with this example, if you're looking for memory utilization, you can receive a notification telling you that your memory is almost full on a particular server and that you should be setting up a new server. In this instance, use Ansible to set up another server. So again, as with the other tools that we've been covering, Nagios is an open source tool, and it's specifically for monitoring systems, servers, and networks within your infrastructure. Very easy to use. It has comprehensive monitoring tools that you can set and control. It is highly available, and it is designed specifically at problem remediation. You want to set it up so that it is the eyes and ears of your network without you having to constantly monitor your network. So the way that Nagios works is that it's just constantly checking out your environment. So the Nagios server is constantly checking the status of your systems. It then is able to create visualization tools of that data, so you can actually then make quick responses. Or you can even send out alerts, such as an email alert or a push notification alert. In this video, we're going to take you through the steps that you need to follow if you want to set up Nagios and the dashboard Nagios provides to help monitor your network. So the first thing you want to do is go to nagios.com, and you can either download the application, or you can actually do what we're going to do here is actually just log into the actual application running on the Nagios website. So for that, you want to go to nagios.na.demos.nagios.com, and you can use the administration or normal user access IDs that Nagios provides. And we've gone ahead and we've actually pre-filled in our ID with Nagios admin and Nagios admin for the user ID and password. Of course, you wouldn't do that in normal real life. So that brings us into the Nagios dashboard. And what you're going to notice is that there are three distinct areas that you should want to focus on. You have the fixed sources, which is all your actual physical hardware that you're monitoring. You have alert summary and abnormal behavior. So let's go check out the fixed sources. And so we have two default fixed sources here, and one in Chicago, one in Tulsa. And you can go ahead and set up additional sources, but what you'll see is that this provides a quick dashboard of the activity in the last 30 minutes, the amount of usage on the disk. You can go ahead and under the behavior tab, and you can modify how you're monitoring and updating the actual source itself. And then the data from these reports will be from these sources will actually be then used in reports, queries, and alerts that you'll use. So we're going to go back to the board, and here you are. Here's the two fixed sources. So let's look at alert summary. We're going to expand that out. And the alert summary provides just an overview of the alerts that are being managed. The alerts that you see here are the default alerts that have been created as part of the test environment. It's very easy to create alerts. And in this instance, you can see that the Chicago source is being used to manage the alert. What you can do is when you're actually setting up your own sources, you'll see that the alert will then point specifically to the source that it's pulling the data from. So in the PowerPoint, in the presentation that we just went through, you actually see how Nagios actually is the center of collecting all the information, but it's actually pulling the information from the different networks and environments that you have, and then it stores that data locally to be able to create the visualizations and the alerts. And we have here just a quick overview of an alert here inside of the summary, which actually shows green, which shows that the alert is actually good. Now, there are three different types of colors. There's green, yellow, and red, but as you can see, we have no critical alerts right now. And you'll see the same thing happening at abnormal behavior as well, where it actually goes ahead and shows you the different colors that are available. The thing that's great is that as soon as a warning status is created, then it allows you to trigger an email notification that gets sent out to you and has information in the email which you can then action. So the alerts are very important, and the alerts again are pulling the information from the fixed sources. So the abnormal behavior is just going to zero in and show any specific abnormal behavior that would be happening with your fixed sources. And so in this instance, it's around bandwidth, and everything is green, so everything's looking good. So we're going to the source tab and we're going to look at the bandwidth graph, and this is a more detailed visualization of the bandwidth that's happening through the Chicago fixed source. Again, you can create your own fixed sources and you'll be able to see the actual usage, such as the bandwidth graph for that fixed source on this screen. And at the bottom of the screen we have just kind of the most popular information that most network engineers are looking to assess on how a network is being used. So we can go ahead and we can select reports, and we can actually come in and we can either create our own custom report, or you can use one of the many saved reports that are already there. If you're new to Nagios, use the saved reports, because you'll be able to get in and get the great visualization tools that Nagios provides very quickly, and be able to then action the information visually from what you're looking at. These reports are absolutely fantastic, and they're also really good to send to other team members that would have an interest in understanding the network usage and the different areas that you're managing. Now, if you want to get really specific on the type of data that you want in the report, you can actually go in and create a query, and the query can be customized to really however you want it to work. The points of view are very specific insights into different data points that interact, and they're very easy to create. A lot of them have been created, as you can see on the screen already, and as you can see on the left hand side, there's an edit button that allows you to edit and modify those points of view very quickly. Now we're going to go ahead and create one right now, and we're just going to put one in. We're going to put the limiter for an IP address. We're going to change the data lifetime. We can either do hours, days, or weeks. We do 24 hours, that's fine. So we'll just go ahead and we'll see what we have on the screen, and as you can see, there are just a lot already created. Select one, we'll edit the FTP, and we'll see what the data lifetime for that is, and it all looks good. So a query will show all of the saved queries you've created, but you can actually go in and modify a query very easy. You can go in and create a query and really essentially ask it to pull any kind of information that you would be looking at analyzing that has been captured by Nagios. And there's a dictionary you can use that Nagios has on their website that allows you to get better access and understanding the querying constructs you can put together. The alerts, in my opinion, are the most important part, because these are the actual actions that interact with the data sources and will trigger alerts that get sent to you. So if we go back to the presentation again, you can see that we're analyzing a lot of data, but it's the data that gets sent to you as an alert that allows you to immediately understand why you need to be able to go in and check out your network. And this is why you're really using Nagios, because you need to have those alerts. And so what we're going to do here is we're going through the steps you use to create an alert, and we're just going to do an alert here that is going to be on analyzing bytes of traffic. And the final step is to actually go ahead and save the alert and really put in what the alert notification model method is going to be. The default is to use an email, which is great, but you can use a Nagios alert or SMP, a simple network protocol alert, or just use a command. Email is definitely the easiest one to use, and so getting started, I would recommend you use email. So we're going to go ahead and we're going to create one. We're going to do one on workflow, and we're going to set up the way in which we're going to manage this. So the threshold is going to be 34 bytes with a critical threshold of 50 bytes, which is very small. I expect an alert to be triggered because of this, and we're just going to use the default emails to send out. And you'll see by default that the new alert is now impending, and the reason why we have it impending is that it's just there to be reviewed by the system to make sure it meets all the standards. I don't think that'd be a problem, and I'm just looking at some of the other different commands we have here. So if we go back, and we can get alerts from other Nagios networks. We connect to different networks right from this configuration screen. Same thing with the SMP receiver. We can use simple network management protocol to connect to other receivers. And the command tab allows us to create scripts that can be triggered from alerts that get created. So you may want to have something that triggers a rebuild of a network environment, which would allow you to authenticate through other systems. Now, of course, there are other things that you can set up in the Nagios dashboard. So, things like information on your profile, defaults here, such as language and your username. You have the same thing for a system administrator, where you can actually go in and set defaults for the sysadmin. There's LDAP AD integration for SAML authentication. Go back to the main dashboard. If we scroll down, you'll actually see that we have an alert has been approved. That's the alert that we created before, and it's now saying critical because more than 50 bytes of information have been sent over our test network in the fixed source of Chicago. Surprise, surprise, 50 bytes is very easy to do. So it's good to see that the system is working correctly. And this is how our Nagios environment works. And from here, the next step is for you to be able to set up and configure Nagios to run with your infrastructure.
Imagine a large hospital where doctors and nurses need to access patient records every day. They look up medical histories, test results, and treatment plans to make sure they give the best care. One day, the hospital's old database system crashes, and suddenly nobody can get the information they need. Doctors can't see patient records during emergencies, and everything comes to a standstill. What can the hospital do to make sure this never happens again? This is where AWS databases come to the rescue. By using AWS powerful and reliable database services, the hospital can make sure the patient data is always available, safely stored, and easy to access. AWS offers a range of database solutions that keep the data secure and backed up, so doctors and nurses can always get the information they need, even in emergencies. So in today's video, we'll explore about the storage services of AWS and the different types of databases available in AWS. We'll explain how each service works, their key features, and the best ways to use them. Whether you are a developer, a database administrator, or just curious about cloud technology, this video has something for you. So what is AWS? Amazon Web Services, or AWS, is a comprehensive cloud computing platform provided by Amazon, offering a wide array of on-demand services such as compute power, storage, and databases, along with advanced functionalities like machine learning, analytics, and IoT. It helps businesses to scale their applications efficiently. It reduces the IT cost as it has pay-as-you-go model. Its global network of data centers ensures high availability and security. Now, what is a database and why is it important? So databases are systems that store, organize, and manage lots of data efficiently. They have tables to hold the data, queries to find specific information, and indexes to speed up searches. Databases also ensure that all operations are completed correctly and keep data secure. Now there are different types of databases. Relational databases use structured tables and SQL for queries, while NoSQL databases handle unstructured data and are easier to scale. Now, using databases in cloud has many benefits. Cloud databases can easily grow or shrink based on your needs. So you can handle busy times without paying for extra resources you don't need. They are also reliable because cloud providers manage backups and replicate data in different locations, which minimizes downtime and data loss. Additionally, cloud databases reduce costs because you don't have to buy and maintain your own hardware and software. They allow global access, so teams and applications around the world can quickly get the data they need. Now let's discuss the various storage services provided by AWS and identify which AWS databases use each type of storage. So AWS offers a variety of storage services tailored for different use cases. First, we have Amazon S3, or Simple Storage Service, which is an object storage service that is highly scalable, durable, and secure, ideal for backups, big data analytics, and content storage. It's used by databases like Amazon RDS, Amazon DynamoDB, and Amazon Redshift for backups and data storage. Next, we have Amazon EBS, or Elastic Block Store, which provides block storage for EC2 instances, offering different volume types for balancing cost and performance. Now, Amazon EBS is used by Amazon RDS and Amazon Aurora for database storage. Now, next we have Amazon EFS, which is Elastic File System. Now, it offers scalable file storage that can be concurrently accessed by multiple EC2 instances, suitable for applications needing shared access, like web serving and content management. Next on the list is Amazon FSx. which provides fully managed file systems optimized for specific workloads, such as FSX for Windows File Server and FSX for Lustre, the latter being ideal for high-performance tasks like machine learning and big data processing. Now, for archival storage, Amazon S3 Glacier offers low-cost storage for infrequently accessed data, perfect for compliance and archival needs. Now, finally, we have the AWS Snow family, including Snowcone, Snowball, and Snowmobile, which facilitates secure and efficient data transfer into and out of AWS, supporting the initial data loading for various databases. So having known the services offered by AWS, now let's move on to the different databases in AWS and discuss each of them with their use cases. So first we have Amazon DynamoDB. Now, Amazon DynamoDB is a fully managed NoSQL database service offered by AWS. It is designed to handle large amounts of data with high speed and low latency, making it perfect for applications that need to store and retrieve data quickly. Some of its features are scalability. DynamoDB can automatically scale up or down based on the application's demand, ensuring consistent performance. It provides single-digit millisecond response times, which is ideal for real-time applications. AWS handles all the maintenance tasks like backups, patches, and hardware provisioning, so you don't have to worry about them. So let's see a use case. Imagine you are running a mobile game with thousands of players online simultaneously. Each player's game progress, scores, and in-game purchases need to be stored and retrieved quickly to ensure a smooth gaming experience. Now, DynamoDB can efficiently handle this type of workload by providing quick access to player data even when there are sudden spikes in game activity. This ensures players have a seamless and enjoyable experience without delays or lag. Now, next we have Amazon Aurora. Amazon Aurora is a high-performance, fully managed relational database service offered by AWS. It's designed to be compatible with MySQL and PostgreSQL, which are popular database systems, but it's much faster and more reliable. Aurora automatically takes care of tasks like backups, software patching, and scaling, so you don't have to worry about them. Let's see its use case. Imagine you have an online store that handles thousands of transactions every day. You need a database that can quickly process orders, manage inventory, and store customer information without any slowdowns. Amazon Aurora is perfect for this because it can handle lots of read and write operations very efficiently, ensuring a smooth shopping experience for your customers. Plus, Aurora can automatically scale up to meet high demand during sales or holidays and scale down when traffic is lower, helping you save costs. Its high availability and automatic backup features mean your data is always safe and accessible, even in case of hardware failures. This makes Aurora an excellent choice for running a reliable and responsive e-commerce website. Next on the list, we have Amazon RDS. Now, Amazon RDS or Amazon Relational Database Service is a cloud-based service that makes it easy to set up, operate, and scale a relational database. This means you can store and manage your data in a structured way using popular database engines like MySQL, PostgreSQL, Oracle, SQL Server, and MariaDB without worrying about the underlying infrastructure. Now, imagine you run an online store. You need a database to keep track of your products, customers, orders, and inventory. Using Amazon RDS, you can quickly create a database that handles all these tasks. RDS automatically takes care of backups, software updates, and scaling, so you don't have to worry about your database crashing during a big sale or needing more space as your business grows. Now next, we have Amazon TimeStream. Now, Amazon TimeStream is a cloud-based time series database service offered by AWS, designed to efficiently store and analyze timestamp data. Now, timestamp data is information collected at regular intervals, like temperature readings every minute or stock prices every second. So the key features include performance. It handles trillions of events per day with fast query capabilities. Now, it automatically scales up or down based on the volume of data. Now, you only pay for storage and queries you use, with automated data lifecycle management to reduce costs. Now, imagine you have a network of thousands of IoT sensors deployed across a city to monitor air quality. Each sensor collects data like temperature, humidity, and pollution levels every few seconds. Now, Amazon TimeStream can efficiently store this vast amount of timestamp data and provide quick access for real-time monitoring and historical analysis. This helps in analyzing trends, predict pollution levels, and make data-driven decisions to improve air quality. Next on the list, we have Amazon Neptune. Now, Amazon Neptune is a fully managed graph database service provided by AWS. It's designed to work with highly connected data, making it ideal for applications where relationships between data points are as important as the data itself. Its key features include graph models. It supports popular graph models like Property Graph and RDF, which is Resource Description Framework, optimized for querying large amounts of interconnected data quickly. It handles database management tasks like backups, patching, and scaling automatically. Now, one common use case for Amazon Neptune is building social networking applications. So in a social network, users are connected to each other in various ways: friends, followers, likes, comments, and groups. Now, Neptune can efficiently manage these connections and quickly answer complex queries like who are the mutual friends of two users or what groups are my friends part of. So by using Neptune, social media platforms can provide a fast, responsive user experience even as the number of users and connections grow. So next we have Amazon QLDB. Now it stands for Amazon Quantum Ledger Database, which is a fully managed ledger database provided by AWS. It is designed to maintain a complete and unchangeable history of all changes made to your data over time. Think of it like a highly secure and transparent digital logbook where every entry is recorded and can't be altered. So the key features are immutable ledger. Once data is entered, it cannot be changed or deleted. It ensures the integrity of your data by allowing you to verify that it hasn't been tampered with. Now, AWS handles all the maintenance, including scalability, backups, and availability. So one common use case for QLDB is in tracking financial transactions. So imagine a bank needs to maintain an accurate and tamper-proof record of all the transactions to ensure transparency and compliance with regulations. So QLDB can provide a trustworthy and unchangeable log of every transaction, making it easy to audit and verify the history of financial activities. Now, the last on the list is Amazon RDS on VMware. So it is a service that allows you to run Amazon's Managed Relational Database Service or RTS in your own data centers using VMware. Now, VMware is a virtualization and cloud computing software provider. So this means you can enjoy the benefits of RDS like automated backups, patching, and scaling without moving your data to the AWS cloud. So it's perfect for businesses that want to keep their data on premises due to regulatory requirements, low latency needs, or existing investments in VMware infrastructure. For example, imagine a hospital that needs to store and manage large amounts of sensitive patient data. So due to strict privacy regulations, this data must remain on-site itself. With Amazon RDS or VMware, the hospital can set up and manage databases easily within their own data centers. They get the reliability and automation of AWS RDS while keeping patient information secure and compliant with local laws. So this setup ensures the hospital's data is always backed up, secure, and accessible without the complexity of managing database servers manually.
Do you know, friends, that Kubernetes is also called K8 or Kube? It is an incredibly powerful platform that helps you manage and scale applications automatically. But it can feel complex and overwhelming at the same time. Many people find Kubernetes a bit tricky when they read through the documentation, especially when they are trying to understand how all the pieces fit together to manage containers. In this video, we are going to break it down for you in easy terms. We will explore two types of nodes in Kubernetes: the master node and the worker node. We will talk about how these nodes work together inside the cluster to manage and orchestrate your applications. So guys, without further ado, let's get started. So guys, let's start with understanding first what is pod. A pod is the smallest unit in Kubernetes. It is like a wrapper around your application. Inside a pod, there's usually one or more containers. Now you'll be wondering, what is a container? A container is where your actual application runs. It includes everything that the app needs to function, like code, system, libraries, and dependencies. Containers are lightweight and can be easily moved across different environments, making them very popular in modern software development. You can think container like a box that has your app and everything it needs to run. Whether you run it on your laptop or on a cloud server or inside a Kubernetes pod, the container will always behave the same way. Let me give you one example. Suppose you run an online e-commerce store. You have a front-end web app that the customers see and the back-end, the database that stores the product information and orders. In Kubernetes, you might choose to package the front-end and back-end as two separate containers. So you could run both the web app and the database inside the same pod. In this case, both containers, front-end and back-end, share the same resources, such as memory and network. This might be useful if they need to be closely coupled and always run together. Now, pods are basically responsible for managing resources for containers inside them, like the memory, CPU, and storage. And each pod runs on a node, and Kubernetes decides which node will run on each pod. Now let's understand the Kubernetes architecture. So guys, as we all know that Kubernetes is an open source platform designed to automate, deploy, scale, and manage centralized applications. It provides a powerful way to ensure that your applications are running efficiently and can easily scale across multiple machines, and can also recover if something goes wrong. At the heart of Kubernetes architecture, there are worker nodes and master nodes. These two components work together to ensure your apps are always running smoothly. In this video, we will take a closer look at each of these components and how they interact with each other. So let's understand first the worker nodes. Worker nodes are the machine which can be either physical computers or virtual machines where your applications actually run. Think of them as the workers for your Kubernetes cluster. They execute your app workloads, handle the tasks required them to run. Each worker node in Kubernetes runs these three main processes. That is container runtime, kubelet, and kubeproxy. Let's understand each one of them one by one. The first process is container runtime. The container runtime is like the engine of your worker node. It is responsible for running your applications, which are packaged into containers. Containers are basically lightweight standalone units that contain everything your app needs to run. This includes code, system libraries, and dependencies. The container runtime is a software that ensures these containers are properly managed and executed on each worker node. One of the most popular container runtime is Docker, as you can see all over here. So there are two instances of first, there is a my app, which can be a front end. Then you can consider this as the backend. So guys, you can consider something like this. These two as your two containers. This can be a front end, this can be a backend or database. Now there's a container runtime all over here, which can be Docker in this case. So the container runtime in this case is Docker, and it is ensuring that the container for your web app is running on the worker node. So if you have multiple applications, they will be packaged into separate containers, and container runtime will manage them, making sure they are running as expected. The next process that we are going to discuss about is called kubelet. Kubelet is like a manager that oversees everything happening on a worker node. It talks to the master nodes, which are responsible for managing the entire cluster. The kubelet gets instruction from the master node detailing which application or pods needs to be run on the node. It ensures that these applications are running by managing containers inside the pods. Unlike container runtime, which is specific to managing containers, the kubelet handles the interaction between Kubernetes and the worker node. It is responsible for making sure that the right number of containers are running, that the resources like CPU, memory, and storage are allocated properly to those containers. So you can say, for example, we have the master node that sends a request to the kubelet saying run two containers for the web app. So one container is there for web app and one is for the database. The kubelet will check the available resources on the worker node and ensures that the containers are up and running. It also continuously monitors the health of these containers to make sure they don't crash or run into problems. If container fails, the kubelet can restart it based on the policies defined in the Kubernetes, ensuring that the application remains highly available. I hope so you would have got an idea regarding kubelet. Now let's move ahead and understand about kubeproxy. Think of kubeproxy as a traffic director for your Kubernetes cluster. In a distributed systems like Kubernetes, your applications which are running on different nodes, kubeproxy is responsible for managing network traffic and ensuring that data is routed correctly between different services and pods. When your application needs to talk with each other, in this case, kubeproxy sets up the necessary network rules and ensures that the traffic flows smoothly between different pods, services, and nodes. It manages the internal networking of the cluster and ensures that each pod has a unique IP address. Now, let's move ahead and understand about the working of master nodes. While worker nodes handle the execution of the application, master nodes are the brain of the Kubernetes system. The master node manages the overall state of the cluster and makes decisions about which application should run and where they should run. The master node constantly monitors the clusters to ensure everything is working as expected. There are 4 key components that make up the master node. The first one is API server. The API server is like the front desk of the Kubernetes control plane. It acts as an entry point for all the requests you send to the Kubernetes. Whether you are creating a new application, checking the status of your pods, or scaling your app, you communicate with the Kubernetes through the API server. The API server handles all these requests and ensures that they are passed on to the correct components within Kubernetes. For example, let's say you want to deploy a new web application in your Kubernetes cluster. You would send a request to the API server, which would receive the request, it will validate it, and pass it to the appropriate components, like it can be a scheduler or a control manager. Now, let's move ahead and understand about the second component, that is the scheduler. If I talk about the scheduler, guys, the scheduler is like a smart planner for the cluster. It is responsible for deciding which worker node should run a new application. When you create a new app in Kubernetes, the scheduler looks at all the available worker nodes and determines the best node for the app to run on. Based on available resources like CPU, memory, and network, the scheduler ensures that your apps are distributed efficiently across a cluster so that no single worker node is overloaded. Now let's move ahead and understand about control manager. The control manager is like the quality control department of Kubernetes. It constantly monitors the state of cluster and ensures that everything is running as it should. If something goes wrong, like a pod crashes or a node goes offline, the control manager steps in to fix it. The control manager is responsible for ensuring that the desired state of the cluster matches the actual state. If you define that you want 3 replicas of an app running and one of them crashes, the control manager will automatically create a new replica to maintain the desired state. Now the final component is etcd, which is also called as the cluster brain. etcd is a database that stores all the data about the Kubernetes cluster. It is often referred to as brain of the cluster because it keeps track of everything, including the apps which are running, where they are running, and the overall state of the cluster. etcd is a distributed key value store, meaning it can store data across multiple machines and ensure that it is highly available and fault tolerant. This is crucial for Kubernetes because the entire system relies on etcd to know how the current state of the cluster is. For example, if you want to deploy a new app, Kubernetes stores information about the app, like its configuration, location, and state in etcd. If something happens to the cluster, Kubernetes can recover the current state from etcd. Now let us look at the example of setting up a cluster. Now that we understand how worker nodes and master nodes work, let us go through a simple example of a Kubernetes cluster setup. In this, you have a basic cluster with 2 master nodes and 4 worker nodes running on it. Let us say these pods contain a web app and a database. You start by creating pods, and each pod contains 1 or more microservices for your web app. Then the scheduler steps in. Once you submit the request to Kubernetes through the API server, the scheduler looks at the available worker nodes and assigns both the pods to your worker nodes. Then comes the kubelet, which manages the pod. The kubelet on the worker nodes receives the instruction from the master node to run on the 2 pods. It starts a container inside each pod using Docker or another container runtime, and it ensures they are running smoothly. Then we have kubeproxy, which handles the communication. The web app pod needs to communicate with the database pod. kubeproxy sets up the network routes and ensures that the 2 applications can exchange data securely and efficiently. Then we have control manager, which ensures the stability. If one of the pod crashes or fails to start, the controller manager detects the issue and creates new instance of the pod, ensuring that both your web app and the database stay online. Then finally, we have the etcd, which keeps up the track. All the information about the state of the cluster, including running pods, their location, their status, is stored in etcd. This ensures that the cluster can recover from any issues and always knows what is happening. So this was a simple example illustrating the cluster setup. Kubernetes is a powerful platform for managing containerized application across cluster of machines. By understanding the roles of worker nodes and master nodes, you can see how Kubernetes automates the deployment, scaling, and management of your apps.
Hello, and in this video, we're going to cover a common conversation, which is Kubernetes versus Docker. But before we jump into that, I want you to hit the subscribe button so you get notified about new content as it gets made available. And if you hit the notification button, that notification will then pop up on your desktop as a video is published from Simplilearn. In addition, if you have any questions on the topic, please post them in the comments below. We read them and we do reply to them as often as we can. So with that said, let's jump into Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker. And we can actually go through and understand what the problems specific companies have actually had and how they're able to use the two different tools to solve them. So our first one is with Bose. And Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing two primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the number one container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising, because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design, because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it, and you should be able to look and see whether or not you can add your own company to this list.
Jenkins is the powerhouse behind modern software development, streamlining the entire build and deployment process. In this comprehensive course, we will unlock the potential of Jenkins, teaching you how to automate tasks, integrate diverse tools, and orchestrate the software delivery pipeline like a pro. From setting up Jenkins pipelines to managing configurations and scaling for large projects, we will cover it all. Whether you are a seasoned developer looking to boost productivity or a beginner eager to dive into DevOps, then this course will empower you to harness the full potential of Jenkins for efficient and error-free software development. If these are the type of videos you'd like to watch, then hit that subscribe.
Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. I have listed popular 3 mechanisms in which Jenkins is usually installed on any system. The topmost one is as a Windows or a Linux based services. So if at all you have Windows like the way I have, and I'm going to use this mechanism for this demo. So I would download a MSI installer that is specific to Jenkins and install this service. So whenever I install it as a service, it goes ahead and nicely installs all that is required for my Jenkins. And I have a service that can be started or stopped based upon my need. Any flavor of Linux as well. One other way of running Jenkins is downloading this generic WAR file, and as long as you have JDK installed, you can launch this WAR file by the command, opening up a command prompt or shell prompt if at all you're on Linux box, specifying java-jar and the name of this WAR file. It typically brings up your web application, and you can continue with your installation. The only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt. You either do a Control-C and then bring down this prompt, and your Jenkins server would be down. Other older versions of Jenkins were run popularly using this way, in which you already have a Java-based web server up and running. So you kind of drop in this WAR file into the root folder or the HTTPD root folder of your web server. So Jenkins would explode and kind of bring up your application. All user credentials or user administration is all taken care of by the Apache or the Tomcat server or the web server on which Jenkins is running. This was a very older way of running, but still some people use it because if they don't want to maintain 2 servers, if they already have a Java web server which it's being nicely maintained and backed up, Jenkins can run attached to it. All right, so either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very, very same or similar one with the subtle changes in terms of user administration if at all you're launching it through any other web server which will take care of the user administration. Otherwise, all the commands or all the configuration or the way in which I'm going to run this demo, it is going to be same across any of these installations. All right, so the prerequisites for running Jenkins, as I mentioned earlier, Jenkins is nothing but a simple web application that's written in Java. So all that it needs is Java, preferably JDK 1.7 or 1.8. 2 GB RAM is the recommended RAM for running Jenkins. And also, like any other open source toolsets, when you install JDK, ensure that you set in the environment variable Java home to point to the right directory. This is something very specific to JDK, but for any other open source tools that you install, there is always a preferred environment variable that you got to set in, which is specific to that particular tool that you're going to use. This is a generic thing that is there for, for any other open source projects, because the way open source projects discover themselves is using this environment variables. So as a general practice or a good practice, always set these environment variables accordingly. So I already have JDK 1.8 installed on my system. But in case you do not, what I would recommend is just navigate on your browser to the Oracle homepage and just type in or search for install JDK 1.8 and navigate to the Oracle homepage. You'll have to accept the license agreement, and there are a bunch of installers that you can pick up based upon the operating system on which you're running. So I have this Windows 64 installer that is already installed and running on my system. So I will not get into the details of downloading this or installing it. Let me show you once I install this, what I've done with regard to my path. So if you get into this environment variables, all right, so I've just set in a Java home variable. If you see this, C: program files Java JDK 1.8. This is where my Java is located. C program files Java. Okay, so this is the home directory of my JDK. So that is what I've set it up here in my environment variable. So if you see here, this is my Java home. All right, one other thing to do is ensure that in case you want to run Java or JavaC from a command prompt, ensure that you also add that path into this path variable. So if you see this, somewhere I will see, yes, there you go. C: program files Java JDK 1.8 bin. So with these two, I'll ensure that my Java installation is nice and good enough. So to check that, to double check that, or to verify that, let me just open up a simple command prompt. And if I type in Java -version, all right, and Java C -version. So the compiler is on the path, Java is on the path, and if at all I do this, even the environment variable specific to my Java is installed correctly. So I'm good to go ahead with my Jenkins installation. Now that I have my prerequisites all set for installing Jenkins, let me just go ahead and download Jenkins. So let me open up a browser and say download Jenkins. All right. LTS is nothing but the long-term support. These are all stable versions. Weeklies, I would not recommend that you try these unless until you have a real need for that. Long-term support is good enough. And as I mentioned, there are so many flavors of Jenkins that is available for download. All right. So what I want is, yes, this is the WAR file, which is a generic WAR file that I was talking to you earlier. And this is the Windows MSI installer. So go ahead and download this MSI installer. I already have that downloaded. So let me just open that up. All right, so this is my downloaded Jenkins instance, or rather installer. This is a maybe a few months old, but this is good enough for me. Before you start Jenkins installation, just be aware of one fact that there is a variable called Jenkins home. This is where Jenkins would store all this configuration data, jobs, project workspace, and all that specific to Jenkins. So by default, if at all you don't set this to any particular directory, if at all you install an MSI installer, all your installation gets into C: program files 86 and Jenkins folder. If at all you run a war file, depending upon the user ID with which you're running your war file, the Jenkins folder, there's a .jenkins folder that gets created inside the user home directory. So in case you have any need wherein you want to back up your Jenkins or you want Jenkins installations to get into some specific directories, go ahead and set this Jenkins home variable accordingly before you even begin your installation. For now, I don't need to do any of these things, so I've already downloaded the installer. Let me just go ahead with the default installation. All right, so this is my Jenkins MSI installer. I don't want to make any changes into the Jenkins configuration. C: program files is good for me. Yeah, this is where all my destination folder and all the configuration specific to it goes. I'm happy with this. I don't want to change this. I would just say go ahead and click installation. Okay, so what typically happens once the Jenkins installation gets through is it'll start installing itself, and there are some small checks that needs to be done. So, and by default, Jenkins launches on the port 8080. So let me just open up localhost 8080. There's a small checking that will be done as a part of the installation process, wherein I need to type in a hash key. All right, so there's a very simple hash key that gets stored out here. So I'll have to just copy this path. If at all you're running as a war file, you would see that in your logs. All right, so this is a simple hash key that gets created every time when you do a Jenkins installation. So as a part of the installation, it just asks you to do this. So if that is not correct, it'll crib about it, but this looks good. So it's going ahead. All right, one important part during the installation. So you would need to install some recommended plugins. What happens is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugin and it's got a dependency which is not installed and you get into all those issues. In order to get rid of that, what Jenkins recommends, there's a bunch of plugins that is already recommended. So just go ahead and blindly click that install recommended plugin. So if you see, there is a whole lot of plugins which are bare essential plugins that is required for Jenkins in order to run properly. So Jenkins as a part of the installation would get all these plugins and then install it for you. This is a good combination to kind of begin with. And mind you, at this moment, Jenkins needs lots of bandwidth in terms of network. So in case your network is not so good, few of these plugins would kind of fail. And these plugins are all available on openly or mirrored sites, and sometimes some of them may be down. So do not worry in case some of these plugins kind of fail to install. You'd get an option to kind of retry installing them, but just ensure that at least most or 90-95% of all these plugins are installed without any problems. Let me pause the video here for a minute and then get back once all these plugins are installed. My plugin installation is all good. There was no failures in any of my plugins. So after that, I get to create this first admin user. Again, this is one important point that you got to remember. Give in any username and password, but ensure that you kind of remember that, because it's very hard to get back your username and password in case you forget it. All right, so I'm going to create a very simple username and password, something that I can remember. That's my name, and an email ID is kind of optional, but it doesn't allow me to go ahead in case I don't. So I just give in an admin and I got a password. I remember my password. This is my full name. All right, I say save and finish. All right, that kind of completed my Jenkins installation. It was not that tough, was it? Now that I have my Jenkins installed correctly, let me quickly walk you through some bare minimal configurations that is required. These are kind of a first time configuration that is required. So, and also let me warn you, the UI is little hard for many people to wrap their head around it, specifically the Windows guys. But if at all you're a Java guy, you know how painful it is to write UI in Java, you will kind of appreciate, all the effort that has gone into the UI. Bottom line, UI is little hard to, wrap your head around it, but once you start using it, possibly you'll start liking it. All right, so let me get into something called as Manage Jenkins. This can be viewed like a main menu for all Jenkins configuration. So I'll get into some of those important ones. something called as configure system. Configure system, this is where you kind of put in the configuration for your complete Jenkins instance. Few things to kind of look out for. This is a home directory. This is a Java home where all the configurations, all the workspace, anything and everything regarding Jenkins is stored out here. System message, you want to put in some message on the system, you just type in whatever you want and it's possibly show up somewhere up here on the menu. Number of executors, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. You can kind of visualize it like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, number of executors 2 should be good enough. In case at any point in time, if there are multiple jobs that kind of get triggered at the same time, in case the number of executors are less compared to the number of jobs that have woken up, no need to panic because they will all get queued up and eventually Jenkins will get to running those jobs. Just bear in mind that whenever a new job kind of gets triggered, the CPU usage and the memory usage in terms of the disk write is very high on the Jenkins instance. So that's something that you got to kind of keep in mind. All right, but number of executors, 2 for my system is kind of good. Label for my Jenkins, I don't want any of these things. Usage, how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this node as much as possible. Quiet period. Each of these options have got some bare minimal help kind of a thing that is out here. By clicking on these question marks, you will get to know as to what are these particular configurations. All right, so this all look good. What I want to show you here is there's something regarding the Docker, timestamps, Git plugin, SVN, email notifications. I don't want that. What I want I want this SMTP server configuration. Remember, I mentioned earlier that I would want Jenkins to be sending out some emails. And what I've done here is I've just configured the SMTP details of my personal email ID. In case you're in an organization, you would have some sort of an email IDs that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of send out emails. But in case you want to try it out like me, I have configured my personal email ID, which is on my Gmail, for sending out notifications. So the SMTP server would be smtp.gmail.com. I'm using the SMTP authentication. I've provided my email ID and my password. I'm using the SMTP port, which is 465, and reply to address is the same as mine. I can just send out an email and see if at all this configuration works. Again, Gmail would not allow anybody to send out notifications on your behalf. So you'll have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notifications on your behalf. So I've done already that. I'm just trying to see if I can send a test email with the configurations that I've set in. Yes. All right. So the email configuration looks good. So this is how you configure your your Gmail account in case you want to do that. If not, put in your organization SMTP server details, which are with a valid username and password, and it should all be set. All right, so no other configurations that I'm going to change here. All of these look good. All right, so I come back to manage Jenkins. Okay, one other thing that I want to kind of go over is the global tool configuration. Imagine this scenario, or look at it this way. Jenkins is a continuous integration server. It doesn't know what kind of a code base it's going to pull in, what kind of a tool set that is required, or what is the code that it's going to pull in and how is it going to build. So you would have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from your source code repositories. So just to give an example, in case your source code is a Java source code, and assuming that because in this demo, this is my laptop and I've put in all the configurations, JDK, everything on my laptop because I'm a developer, I'm working on the laptop. But my continuous integration server would be a separate server without anything being installed on it. So in case I want Jenkins to run a Java code, I would need to install JDK on it. I need to specify the JDK location of this out here this way. Okay, since I already have the JDK installed and I've already put in the Java home directory, or rather the environment variable correctly, I don't need to do it. Git, if at all I want the Jenkins server to use Git, Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you would need Git to be installed on that particular system and set the path accordingly. Gradle and Maven, if at all you have some Mavens as well, you want to do this. Any other tool that you're going to install on your system, which is your continuous integration server, you will have to come in here and configure something. In case you don't configure it, when Jenkins runs, it will not be able to find these tools for building your task and it'll crib about it. That's good. I don't want to save anything. Manage Jenkins. Let me see what else is required. Yes, configure global security. All right, the security is enabled. And if you see by default, it's the security access control is set to Jenkins' own user database. So what does this mean? Jenkins by default, it uses file system where it stores all the usernames, which hashes up these usernames and kind of stores them. So as of now, Jenkins is configured to use its own database. Assuming that you are running in an organization, you would probably want to have some sort of an AD or an LDAP server using which you would want to control access to your Jenkins repository, rather Jenkins tool. So you would specify your LDAP server details, the root DN, password or the manager DN and the manager password and all these details in case you want to connect your Jenkins instance with your LDAP or AD or any of the authentication servers that you have in your organization. But for now, since I don't have any of these things, I'm going to use this own database. That's good enough. All right. So I will set up some authorization methods and stuff like that once I put in few jobs. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own servers, which is happening as of now. So I'm going to save all this stuff. That's good for me. So enough of all these configurations. Let me put in a very, very simple job. All right. So job, new item, little difficult to kind of figure out, but then that's the new item. So I'll just say, first job, this is good for me. I just give a name for my job. I would say it's a freestyle project. That's good enough for me. I don't want to choose any of that. So unless until you choose any of this particular button would not become active. So choose the freestyle project and say, okay. At a very high level, you would see general, source code management, build triggers, build environment, build and post build. In case you install more and more plugins, you will see a lot more options. But for now, this is what you would see. So what am I doing? At the moment, I'm just putting up a very, very simple job. And the job could be anything and everything. So I don't want to put in a very complicated job for now. For the demo purpose, let me just put in a very, very simple job. I'll give a description. This is an optional thing. This is my first Jenkins job. All right. I don't want to choose any of these. Again, there are some helps available here. I don't want to choose any of this. I don't want to connect it into any source code for now. I don't want any triggers for now. I'll come back to this in a while. Build environment. I don't want any build environment. As a part of this build step, I just want to, run few things so that I kind of complete this particular job. So since I'm on a Windows box, I would say execute Windows batch command. All right. So what do you want to do? Let me just echo something. Echo. Hello. This is my first Jenkins job, and possibly I would want the date and the timestamp pertaining to the job. I mean, the date and time in which this job was run. All right. Very, very simple command that says, this is my first job. It just puts out something along with the date and the time. All right. I don't want to do anything else. I want to keep this job as simple as this. So let me save this job. All right. So once I save this job, the job names comes up here, and then I need to build this job. And you would see some build history out here. Nothing is there as of now because I've just put in a job. I have not run it yet. All right. So let me try to build it now. You see a build number, you would see a date and a timestamp. So if I click on this, you would see a console output. If I go here, okay, as simple as that. And where is all the job details that is getting into? If you see this, if I navigate to this particular directory, all right, so this is the directory what I was mentioning earlier regarding Jenkins home. So all the job related stuff that is specific to this particular Jenkins installation is all here. all the plugins that is installed. The details of each of those plugins can be found here. All right. So the workspace is where all the jobs that I've created, whichever I'm running, there will be individual folders specific to the jobs that has been put up here. All right. So one job, one quick run. That's what it looks like. Pretty simple. Okay, let me do one thing. Let me put up a second job. I would say second job. I would say freestyle project. All right, this is my second job. I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put up on Jenkins, which will be triggered automatically. Remember what I said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right, so what I'm going to do, I will just keep everything else the same. I'm going to put in a build script pretty much similar to second job that gets triggered automatically every minute. All right, let me do that. Percentage date, and I'll put in the time. All right, so I just put in another job called second job, and it pretty much does the same thing as what I was doing earlier in terms of printing the date and the time. But this time I'm just going to demonstrate the powerfulness of the automation server that is there. If you see here, there's a build trigger. So a build can be triggered using various triggers that is there. So we'll get into this GitHub triggering or hook or a webhook kind of a triggering later on. But for now, what I want to do, I want to ensure that this job that I'm going to put in would be automatically triggered on its own. Let's say every minute, I want this job to be run on its own. So build periodically is my setting. If you see here, there's a bunch of help that is available for me. So for those of you who have written cron jobs on Linux boxes, you'll find it very, very simple. But for others, don't panic. Let me just put up a very, very simple regular expression for scheduling this job every minute. All right, so that's 1, 2, 3, 4, 5. All right, come up, come up, come up. All right, so 5 stars is all that I'm going to put in. And Jenkins got a little worried and he's asking me, do you really mean every minute? Oh yeah, I want to do this every minute. Let me save this. And how do I check whether it gets triggered every minute or not? I just don't do anything. I'll just wait for a minute. And if at all everything goes well, Jenkins would automatically trigger my second job in a minute's time from now. This time around, I'm not going to trigger anything. Look, there you see. It's automatically got triggered. If I go in here, yep, second job that gets triggered automatically. It was triggered at 1642, which is 4:42 my time. That looks good. And if everything goes well, every 1 minute onwards, this job would be automatically triggered. Now that I have my Jenkins up and running, a few jobs that has been put up here on my Jenkins instance, I would need a way of controlling access to my Jenkins server. This is wherein I would use a plugin called role-based access plugin and create few rules. The rules are something like a global role and a project role, project specific role. I can have different roles and I can have users who have signed up or the users whom I create kind of assigned to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwarranted. All right, so first things first, let me go ahead and install a plugin for doing that. So I get into manage Jenkins and manage plugin. A little bit of a confusing screen in my opinion. There is updates available, installed and advanced. As of now, we don't have the role-based plugin. So let me go to available. It'll take some time for it to get refreshed. All right, now these are the available plugins. These are the installed plugins. All right, so let me come back to available and I would want to search for my role-based access plugin. So I would just search for role and hit enter. Okay, role-based authorization strategy enables user authorization using a role-based strategy. Roles can be defined globally or for particular jobs or nodes and stuff like that. So exactly, this is the plugin that I want. I would want to install it without a restart. All right, looks good so far. Yes. Go back to the top of the page. Yes. Remember, Jenkins is running on a Java using a Java instance. So typically many things would work the same way unless and until you want to restart Jenkins once in a while. But as a good practice, whenever you do some sort of a big installations or big patches on your Jenkins instance, just ensure that you kind of restart it. Otherwise, there would be a difference in terms of what is installed on the system and what is there on the file system. You would need to flush out few of those settings later on. But for now, these are all very small plugins, so these would run without any problems. But otherwise, if at all there are some plugins which would need a restart, kindly go ahead and restart your Jenkins instance. But for now, I don't need that. It looks good. I've installed the plugin. So where do I see my plugin? I installed the plugin that is specific to the user control or the access control. So let me go into, yes, global security. And I would see this role-based strategy showing up now. All right, so this comes in because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up. And for the authorization part, in the sense that who can do what, I'm going to install. I mean, I've already installed a role-based strategy plugin, and I'm going to enable that strategy. All right, I would say save. Okay, now I've installed the role-based access plugin. I would need to just set it up and check that, I would go ahead and create some roles and ensure that I assign users as per these roles. All right, so let me go to manage Jenkins, configure. All right, let me see, where is this? Configure global security. Is that where I create my roles? Nope, not here. Yes, manage and assign roles. Okay, again, you would see these options only after you install these plugins. So for now, I've just enabled the plugin. I've enabled role-based access control, and I would go ahead and create some rules for this particular Jenkins instance. So I would say first, manage roles. So I would need to create some roles here, and the roles are at a very high level. These are global roles, and there are some project roles, and there are some slave roles. I'll not get into details of all of these. At a very, very high level, which is a global role, let me just create a role. A role can be kind of visualized like a group. So I would create a role called developer. Typically, the Jenkins instance or the CA instance are kind of owned up or controlled by QA guys. So QA guys would need to provide some sort of limited access to developers. So that's why I'm creating a role called developer, and I'm adding this role at a global role level. So I would say add this here, and you would see this developer role that is there. And each of these options, if you hover over it, you would see some sort of a help on what are these permissions specific to. So what I want is it sounds a little different, but I would want to give very, very little permissions for the developer. So from an administration perspective, I would just want him to have a read kind of a role. Credentials, again, I would just want a view kind of a role. I don't want him to create any agents and all that stuff. That looks good for me. For a job, I would want him to just possibly read. I don't want him to build. I don't want him to cancel any jobs. I don't want him to configure any job. I don't even want him to create any job. I would just want him to read few things. I would not give him possibly a role to the workspace as well. I mean, I don't want him to have access to the workspace. I would just want him to read a job or check, have read-only access to the job. Run. No, I don't want him to give him any particular access which will allow him to run any jobs. View, configure, yeah, possibly create, yeah, delete. I don't want read, yes, definitely. And this is the specific role. So what I'm doing, I'm just creating a global role called developer, and I'm giving him very, very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs, or build jobs, or cancel jobs, or configure jobs. At the max, I would just want him to read a job that is already put up there. Okay, so I would save. Now I've created a role. I still don't have any users that is there on the system. So let me go ahead and create some user on the system. That's not here. I would say configure, Manage Jenkins, manage users. Okay, let me create a new user. I would call this user as, yeah, developer1 sounds good. Some password that I can remember. Okay, his name is developer1 d@d.com or something like that. Okay, so this is the admin with which I kind of configured or brought up the system, and developer1 is a user that I have configured. So still have not set any roles for this particular user yet. So I would go to manage Jenkins. I would say manage and assign roles. I would say assign roles. Okay, so if you see, what I'm going to do now is assign a role that is specific to that particular developer. I will find the particular user and assign him the developer role that I've already configured. The role shows up here. I would need to find my user, whoever I created, and then assign him to that particular role. So if you remember, the user that I created was developer1. I would add this particular user, and now this particular user, what kind of a role I want him to have, because this is the global role that I had created. So developer, I would assign this developer1 to this particular global role, and I would go ahead and save my changes. Now let me check the permissions of this particular user by logging out of my admin account and logging back as developer1. If you remember, this role was created with very less privileges. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new job. I can't do anything. I see these jobs. However, I don't think so I'll be able to start this job. I don't have the permission set for that. The maximum I can do is look at the job, see what was there as a part of the console output and stuff like that. So this is a limited role that was created, and I added this developer to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs, because the Jenkins instance is owned by a QA person. He doesn't want to give developer any administrative rights. So the rights that he set out by creating a developer role, and anybody who is tagged, any user who is tagged as a part of this developer role would get the same kind of permissions. And these permissions can be, fine grained. It can be a project specific permissions as well. But for now, I just demonstrated the high level permission that I had set in. Let me quickly log out of this user and get back as the admin user, because I need to continue with my demo. With the developer role that was created, I have very, very less privileges. One of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins that is provided by users or community users who don't charge any money for these plugins, but it's got plugins for connecting anything and everything. So if you can navigate to, or if you can find Jenkins plugins, you would see index of over so many plugins that is there. All of these are wonderful plugins. Whatever connectors that you would need, if you want to connect Jenkins to an AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you would have a plugin. You can go and search up. If I want to connect Jenkins to Bitbucket, Bitbucket is one of the Git servers. There's so many plugins that is available. Okay, so bottom line, Jenkins without plugins is nothing. So plugins is the heart of Jenkins. For you to connect, or in order to connect Jenkins with any of the containers or any of the other tool sets, you would need the plugins. If you want to connect, or you want to build a repository which has got Java and Maven, you would need to install Maven and JDK on your Jenkins instance. If at all you're looking for a .NET build or a Microsoft build, you would need to have MS Build installed on your Jenkins instance, and the plugins that will trigger MS Build. If at all you want to listen to some server-side webhooks from GitHub, you would need GitHub specific plugins. If you want to connect Jenkins to AWS, you need those plugins. If you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. SonarQube is one of the popular static code analyzers. So you can connect a Jenkins build, you can build a job on Jenkins and push it to SonarQube, and get SonarQube to run analysis on that and get back the results in Jenkins. All of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to GitHub. I already have a very, very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. All right. So this is my very, very simple, repository that is there called Hello Java. And this is what is there in the repository. There is a hello.java application that is here, or a simple class file that is there. It's got just one line of system.out. So this is already present on github.com at this place, and this would be the URL for this repository. If I pick up the HTTPS URL, this is my HTTPS URL. So what I would do is I would connect my Jenkins instance to go to GitHub, provide my credentials, and pull out this repository which is on the cloud hosted github.com and get it to my Jenkins instance, and then build this particular Java file. I'm keeping the source code very, very simple. It's just a Java file. How do I build my Java file? How do I compile my Java file? I just say Java C and the name of my class file, which is hello.java. And how do I run my Java file? I would say Java and hello. Okay, so remember, I don't need to install any plugins now, because what it needs is a Git plugin. So if you remember, when we were doing the installation, there was a bunch of recommended plugins. So Git is already installed on my system, so I don't need to install it again. So let me put up a new job here. It says Git job. Let it be a freestyle project. That's good for me. I would say okay. All right, so the source code management. Remember, in the earlier examples, we did not use any source code because we were just putting up some echo kind of jobs. We did not need any integration with any of the source code systems. So now let me connect this. So I'm going to put up a source code, and Git would show up because the plugin is already there. SVN, Perforce, any of those additional source code management tools, if at all you would need, just install those plugins, and Jenkins connects wonderfully well to all these particular source control tools. Okay, so I would copy the HTTPS URL from here. I would say this is the URL that I'm supposed to go and grab my source code from. But all right, that sounds good, but what is the username and password? So I'll have to specify a username and password. All right, so I would say the username, this is my username, and this is my HTTPS credential for my job. Okay, so this is my username and this is my password. I just save this. I say add, and then I would say, use these credentials to go to GitHub, and then on my behalf, pull out a repository. All right. If at all, at this stage, if there's any error in terms of Jenkins not able to find Git or the git.exe, or if my credentials are wrong, somewhere down here, you would see a red message saying that, something is not right. You can just go ahead and kind of fix that. For now, this looks good for me. I'm going to grab this URL. What am I going to do? This step would pull the source code from the GitHub. And then what would be there as a part of my build step? Because this repository just has a Java file, correct? Hello.java. So in order for me to build this, I would just say execute Windows batch command, and I would say Java C hello.java. That is the way I would build my Java code. And if I have to run it, I would just say Java hello. Pretty simple, 2 steps, and this would run after the repository contents are fetched from GitHub. So Java C, Java, that sounds good. I would say save this, and let me try to run this. Okay, if you see, there's a lot of, it executes Git on your behalf. It goes out here, it provides my credentials and says, it pulls all my repository, and by default, it will pull up the master branch that is there on my repository, and it kind of builds this whole thing, Java C hello.java, and it runs this project Java hello, and there you see, this is the output that is there. And if at all you want to look at the contents of the repository, if you can go here, this is my workspace of my system. Hang on, this is not right. Okay, Git job. If you see here, this is my hello.java. This is the same program that was there on my GitHub repository. Okay, so this is a program that was there on my GitHub repository. All right, so this was the same program that was here, and Jenkins on our behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to my local system on my Jenkins instance. It compiled it and it ran this particular application. Okay, now that I've integrated Jenkins successfully with GitHub for a simple Java application, let me build a little bit on top of it. What I will do is I have a Maven based web application that is up there as a repository in my GitHub. So this is the repository that I'm talking about. It's called MVN Web App. It's a Maven based repository. As you would know, Maven is a very simple Java based build tool that will allow you to run various targets, and it'll compile. It will, based upon the goals that you specify, it can compile, it can run some tests, and it can build a WAR file and even deploy it into some other server. For now, what we're going to use Maven is just for building and creating a package out of this particular web application. It contains a bunch of things, and what is important is just the index.jsp. It just contains an HTML file that is there as a part of this web application. So from a perspective of requirements, now since I'm going to connect Jenkins with this particular repository, Git, we already have that set. We only need two other things. One is Maven, because Jenkins will use Maven. So in order to use Maven, Jenkins would have to have a Maven installation that is there on the Jenkins box. And in this case, the Jenkins box is this laptop. And after I have my Maven installed, I also need a Tomcat server. Tomcat is a very simple web server that you can freely download. I'll let you know how to quickly download and install the Tomcat. All right, so download Maven first. There are various ways in which you can kind of download this Maven. There is zip files, binary zip files, and archive files. So what I've done is I've just already downloaded Maven, and if you see, I've unzipped it here. So this is the folder with which I've unzipped my Maven. So as you know, Maven again is a one open source build tool. So you'll have to set in a few configurations and set up the path. So mvn -- version, if I specify this, after I set in my path, Maven should work. And if at all I echo m2 home, which is nothing but the environment variable specific to Maven home, it is already set here. So once you unzip Maven, just set this m2 home variable to the directory where you unzipped your Maven. Also, just set the path to this particular directory /bin, because that is where your Maven executables are all found. All right, so that's with Maven. And since I've set the path and the environment variable Maven is running perfectly fine on my system, I've just verified it. Okay, next one is a Tomcat server. Download Apache Tomcat server 8.5 is what I have on my system. So I'm just going to show you where to download this from. This is where you download Tomcat server, and I already have the server downloaded. Again, this doesn't need any installation. I just unzip it here, and it kind of has a bin and configuration. I've made some subtle changes in the configuration. First and foremost, Tomcat server also by default runs on port 8080. Since we already have our Jenkins server running on port 8080, we cannot let Tomcat run on the same port. There will be a port clash. So what I've done, I have configured Tomcat to use a different port. So if I go to this configuration file here, there is a server.xml. Let me open this up here. All right. Okay. So this is the port. By default, it will be 8080. I've just modified it to 8081. So I've changed the port on which my Tomcat server would run. All right. So that's one change. Second change, when Jenkins kind of tries to get into my Tomcat and deploy something for someone, he would need some authentications so that he'll be allowed deployment by Tomcat. So for that, I need to create a user on Tomcat and provide this user credentials to my Jenkins instance. So I would go to Tomcat users.xml file here. I've already created a username called deployer and the password is deployer, and I've added a role called manager-script. Manager-script will allow programmatic access to the Tomcat server. So this is the role that is there. So using this credentials, I will enable or I'll empower Jenkins to get into my Tomcat server and deploy my application. All right, only these two things that is required. Let me just start my Tomcat server first. So I get into my bin folder, I open a command prompt here, and there's a startup.bat. It's pretty fast. It just takes a few seconds. Yes, there you go. Tomcat server is up and running. Now this is running on port 8081. So let me just check if that looks good. So localhost 8081. Okay, my Tomcat server is up and running. That sounds good. The user is already configured on this. That's also fine. So what I'll do as a part of my first job, Maven is also installed on my system. So I'm good to use Maven as a part of my Jenkins. So I will put up a simple job now. I will say job. MVN web app. I'll call this freestyle job. That's good. Okay, so this will be a Git repository. What is the URL of my Git repository? Is this guy, HTTPS URL. Okay, that's this URL. I will use the credentials. The old credential that I set up will work well because it's the same Git user that I'm kind of connecting into. All right, so now the change happens here where after I get this, since I said this is a simple Maven repository, I will have some Maven targets to run. So the simple target first is, let me run Maven package. This creates a war file. Okay, so MVN package is the target. Package is the target. So whenever I run this package, it kind of creates it, it builds it, it tests it, and then creates a package. So this is all that is required. Maybe let me try to save this and let me first run this and see if it connects well, if there's any problem with my war file or the war file gets created properly. Okay, wonderful. So it built a war file, and if you see, it all shows you what is the location where this war file was generated. So this will be the workspace. If you see this war file was successfully built. Now I need to grab this particular war file and then I would need to deploy it into Tomcat server. Again, I would need a small plugin to do this because I need to connect Tomcat with my Jenkins server. Let me go ahead and install the plugin for the container deployment. So I will go to manage plugins, available, type in container, container, deploy to container. Okay, so this would be the plugin that I would need. I would install it without a restart. Okay, seems to be very fast. Nope, sorry, it's still installing. Okay, it installed the plugin. So if at all you see this, if you go to my workspace, okay, in the target folder, I would see this web application war file that is already built. So I would need to configure this plugin to pull up this war file and deploy it onto the Tomcat server. For deploying onto the Tomcat server, I will use the credentials of the user that I've created. Okay, so let me go to configure this particular project again. And okay, all this is good. So the package is good. I'm going to just create a package. That's all fine. Now add a post build step. So after the war file is built as a part of this package directive, let me use this deployment to container. Now this will show up after you install the plugin. So deploy this one to the container. Now what is that you're supposed to specify? You're supposed to specify what is the location. Okay, so this is a global configuration that is there that will allow you to, from the root folder, it will pick up the war file that is there. So ****star.war, that's good for me. Okay, what is the context path? Context path is nothing but just the name of an application that, under which it will get deployed into the Tomcat server. I will just say MVN web app. That's the name of my thing. Now I need to specify what kind of a container that I'm talking about. All right, so the deployment would be for this Tomcat 8.5 is what I need. Okay, because the server that we have is a Tomcat 8.5 server that I have. So this would be the URL. So the credentials, yes, I need to add a credential for this particular server. So if you remember, I had created a credential for my web application. So let me just find that. My Tomcat server, yes, configuration of this. Okay, so deployer and deployer. Username is deployer, password is deployer. Okay, so let me use that credential. I would say add a new credential, Jenkins credential. The username is deployer and the password is deployer. So I would use this deploy credentials for that. And what is the URL of my Tomcat instance? So this is the URL of my Tomcat instance. So take the WAR file that is found in this particular folder, and then context path is mn web app. Use the deployment credentials and get into this localhost, which is there 8081. This is the Tomcat server that is running on my system, and then go ahead and deploy it. Okay, so that is all that is required. So I would say just save this and let me run it now. Okay, it successfully built the WAR file. It is trying to deploy it, and looks like the deployment went ahead perfectly well. So the context path was mvn web app. So if I type in this, or if at all I go ahead into my Tomcat server, there would be a web apps folder. You would see the the date timestamp. So this is the file that got recently copied, and this is the Explorer version of our application. So the application was built, the source code of this application was pulled from the GitHub server. It was built locally on the Jenkins instance, and then it was pushed into a Tomcat server which is running on a different port, which is 80881. Now for this demo, I'm running everything locally on my system, but assuming that this particular Tomcat instance was running on some other server with some other different IP address, all that you got to go and change is the URL of the server. So this would be the server in case you already have that, if you have a Tomcat server which is running on some other machine, that's all fine. With a different IP, that's all good enough. The whole bundle or the WAR file that was built as a part of this Jenkins job gets transferred onto the other server and gets deployed. That's the beauty of Jenkins and automatic deployments, or rather deployments using Jenkins and Maven. Distributed build or master slave configuration in Jenkins. As you would have seen, we just have one instance of Jenkins server up and running all the time. And also I told you that whenever any job that kind of, gets started on the Jenkins server, it is little heavy on in terms of disk space and the CPU utilization. So which kind of, if at all you're in an organization wherein you're heavily reliant on the Jenkins server, you don't want your Jenkins server to go down. So that's wherein you kind of start distributing the load that is there on the Jenkins server. So you primarily have a server, which is just a placeholder or like a master who will take in all the kind of jobs. And what he will do is based upon trigger that has happened to the job or whichever job needs to be built, if at all, he can delegate these jobs onto some other machines or some other slaves. That's a wonderful thing to have. Okay, use case 1. Use case 2, assuming that, if you have a Jenkins server that is running on a Windows box or on a Linux one, and if at all you have a need where you need to build based upon operating systems, you have multiple build configurations to support. Maybe you need to build a Windows, Windows based .NET kind of a projects where you would need a Windows machine to build this particular project. You also have a requirement where you want to build Linux based systems. You also have a Mac, you support some sort of an apps or something that is built on Mac OS. You would need to build, Mac based system as well. So how are you going to support all these needs? So that's wherein a beautiful concept of master slave or primary and delegations or agent and master comes into play. So typically you would have one Jenkins server who will just configure with all the proper authorizations, users, configurations, and everything is set up on this Jenkins server. His job is just delegations. He will listen to some sort of triggers, or based upon the job that is coming in, he will, if there is a nice way of delegating these jobs to somebody else and taking back the results, he can control a lot of other systems. And these systems may not have a complete, or there's no need to put in a complete Jenkins installation. All that you got to do is have a very, very simple runner or a slave that is a simple jar file that is run as a low priority thread or a process within these systems. So with that, you can have a wonderful distributed build server that can be set up. And in case one of the servers goes down, your master would know that what went down and kind of delegate the task to somebody else. So this is the kind of distributed build or the master slave configuration. So what I'll do in this exercise or in this demo is I will set up a simple slave. But since I don't have too many machines to kind of play around, what I'll do is I will set up a slave in one other folder within my hard drive. So I've got the C drive and D drive. My Jenkins is on my C drive. So what I would do is I would just use my E drive and set up a very simple slave out there. I'll just show you how to provision a slave and how to connect to a slave and how to delegate a job to that slave. Let me go back to my Jenkins master and configure him to talk to an agent. So there are various ways in which this client and server talk to each other. What I'm going to choose is something called as JNLP, Java Network Launch Protocol. So using this, I would ensure that the client and server talk to each other. So for that, I need to ensure that I kind of enable this JNLP port. So let me try to find out where is that. Let me try this. Okay, yes, agents, and by default, this JNLP agents thing would be disabled. So if you see here, there's a small help on this. So I'm going to use this JNLP, which is nothing but Java Network Launch Protocol. And I'll configure the master and server to talk to each other using JNLP. So for that, I need to enable this guy. So I enable this guy instead of making by default, the configuration was disabled. So I make him random. I make him, enabled, and I say save this configuration. All right. So now I configured, or I made a setting for the master so that the JNLP port is kind of opened up. So let me go ahead and create an agent. So I'll go to manage nodes. So if you see here, there's only one master here. So let me provision a new node here. So this is the way in which you bring up a new node. You have to configure it on the server. Jenkins would put in some sort of security around this particular agent and let you know how to launch this particular agent so that he can connect to your Jenkins master. So I would say new node. I would give a name for my node. I would say Windows node because both of these are Windows only. So that's fine. I just give an identifier saying that Windows node. I would say this is a permanent agent. I would say okay. So if you see the name, let me just copy this name here with the description. Number of executors, since it's a slave node and both of these are running on my system, I will keep the number of executors as 1. That's fine. Remote root directory. Now this is where, let me just clarify this, since I have both my master is running on my C drive program files 86, or hang on, not 86, C colon program files. It is indeed 86. All right, Jenkins. So this is where my master is running. So I don't want the C drive. What I'll do is I'll use something called as A drive. I have another drive in my system, but please visualize this like, you're running this on a separate system altogether. So I create a folder here called Jenkins node, and this is where I'm going to place I'm going to provision my slave, and I'm going to run him from here. So this is the directory in which I'm going to provision my slave node. So I'm going to copy this here, and that is the remote root directory of your particular agent or slave. So I just copy it here. The label, probably this is fine for me. And usage, how do you want to use this guy? So I don't want him to run all kinds of jobs. I will only build jobs with label expressions that match this particular node. And so this is the label of this node. So in order for somebody to kind of delegate any task to them, they will have to specify this particular label. So imagine this way, if I have a bunch of Windows mesh system, I name it as Windows star. Anything that starts from Windows, I can give a regular expression and say that anything that matches Windows, run this particular task there. If I have some Mac machines, I name all these Mac agents as Mac star or something like that. And I can delegate all tasks, saying that start with whatever starts with Mac in this node, run the Mac jobs there. So you identify a node using the label and then delegate the task there. All right. So launch method, we will use Java Web Start because we got to use JNLP protocol. Okay, that sounds good. Directory, I think nothing else is required. Availability, yes, we'll keep this agent, yep, online as much as possible. That sounds good. All right, let me save this. All right, I'm just provisioning this particular node now. So if I click on this node, I get a bunch of commands along with an agent.jar. So this is the agent.jar that has to be taken down to the other machine or the slave node. And from there, I need to run this along with a small security credential. So let me copy this whole text here in my notepad. Notepad plus is good for me. Okay. I copy this whole path there. I also want to download this agent.jar. I would say yes. And this agent.jar is the one that is configured by our server. So all the details that is required for launching this agent.jar is found in this. For launching this agent is found in this agent.jar. So typically I need to take this jar file onto the other system and then kind of run it from there. So I have this agent.jar. I copy this, or rather I cut this. I come back to my folder, my Jenkins node. I paste it here. Okay. So now with this provision agent.jar, and I need to use this whole command, Control A, Control C, and then launch this particular agent. So let me bring up a command prompt right here and then launch it. So I'm saying in the same folder where there is agent.jar, I'm going to launch this particular agent, java-jar, agent.jar, JNLP. This is the URL of my server. In case the server and client are on different locations or different IPs, you have to specify the IP address. All this anyway would show up. And then the secret and the root folder of your Jenkins or the slave node. Okay. So something ran and then it says it's connected very well. It seems to have connected very well. So let me come back to my Jenkins instance and see, if at all you see earlier, this was not connected. Now let me refresh this guy. Okay, now these two guys are connected. Provision a Jenkins node, and then I copied all the credentials of the slave.jar along with the launch code and then took it to the other system and kind of ran it from there. Since I don't have another system, I've just got a separate directory in another folder, another drive, and I'm launching the agent from here. As long as this particular agent is up and running or this command prompt is up and running, the agent would be connected. So once I close this, the connection goes down. All right, so successfully we've launched this particular agent. Now this would be the home directory of this Jenkins node or the Jenkins slave. So any task that I'm going to delegate to this particular slave would all be run here. It will create a workspace right here. All right, so good. So let me just come back and let me kind of put up a new task here. I will say that, delegate job is good. I say freestyle project. I'm going to create a very, very simple job here. I don't want it to connect to Git or anything like that. Let me just create a very, very simple echo delegated to the slave, delegated to, I don't like the word slave, delegated to agent. Put this way. All right. So delegated to agent sounds good. Now, how am I going to ensure that this particular job runs on the agent or on the slave that I've configured? Right? Do you see this? If at all you remember how we provisioned our particular slave, we gave a label, right? So now I'm going to put in a job that will only match this particular label. So I'm going to say that whatever matches this, Windows label, run this job on that particular node. So we have only one node that's matching this, Windows node. So this job will be delegated out there. So I save this and let me build this. This is again a very, very simple job. There's nothing in this. I just want to demonstrate how to kind of delegate it to an agent. So if you see this, it ran successfully. And where is the workspace? The workspace is right inside our Jenkins node. It created a new workspace, delegated job, it put in here. So my old or my primary master job is in SQL program files under Jenkins. And this is the slave job that was successfully run. Very, very simple, but very, very powerful concept of master slave configuration or distributed build in Jenkins. Okay, approaching the final section where we've done all this hard work in bringing up our Jenkins server, configuring it, putting up some jobs on it, creating users and all this stuff. Now, we don't want this configuration to kind of go away. We want a very nice way of ensuring that we back up all this configuration. And in case there is any failure, hardware crash or a machine crash, we will want to kind of restore from the existing configuration that we kind of backed up. So one quick way to do that would be, or one dirty way to do that would be just, take a complete backup of our program files Jenkins directory, because that's where our whole Jenkins configuration is present. But we don't want to do that. Let's use some plugins for taking up a backup. So let me go to Manage Jenkins and click on Available, and let me search for some back. There are a bunch of backup plugins, so I would recommend one of these plugins that I specifically use. So this is the backup plugin. So let me go ahead and install this plugin. All right, so we went ahead and installed this plugin. So let me come back to my manage plugins. So this plugin is there. So hang on, backup manager. So you will see this option once you install this plugin. So first time I can do a setup. I would say backup this particular. I'll give a folder. This folder is pertaining to the folder where I want Jenkins to backup some data, and I would say the format should be zip format is good enough. Let me give a name or a template or a file name for my backup. This is good. I want it in verbose mode. I don't want to shut on my Jenkins, or should I shut it down? No. Okay. One thing that you got to remember is that whenever a backup happens, if there are too many jobs that is running on the server, it can kind of slow down your Jenkins instance, because it's in the process of copying few of those things, and if the files are being changed at that moment, it's a little bit problematic for Jenkins. So typically you back up your servers only when there is very less load, or typically try to bring it to a shutdown kind of a state and then take a backup. All right, so I'm going to back up all these things. I don't want to exclude anything else. I want the history. I want the Maven artifacts. Possibly I don't want this guy. I would just say save, and then I would say back him up. So this would run a bunch of steps, and all the files that is required as a part of this is pretty fast. But then if at all you have too many things up on your server, for now we didn't have too many things up on our server, but in case you had too many things to kind of backup, this may take a while. So let me just pause this recording and get back to you once the backup is complete. So there you go. The backup was successful. Created a backup of all our workspace, the configurations, the users, and all that. So all this is kind of hidden down in this particular zip file. So at any instance, if at all I kind of crash my system for some instance, or say hard disk failure, and I bring up a new instance of Jenkins, I can kind of use the backup plugin for restoring this particular configurations. So how do I do that? I just come back to my manage Jenkins, come back to backup manager, and I will say restore Hudson or Jenkins configuration.
Now, the first one is that what exactly is in DevOps here? Now, DevOps is basically a combination of two practices, like that is the development and operations. So development is having their own task of doing the development and preparing the source code, and operation is responsible for deploying the source code to a specific environment, whether it's a production or any other environment. So they take care of all those tasks, creating the virtual machines, managing, performing the patching, and number of tasks is there from the operations perspective. Now, development is something which keeps on working on the source code there on the development, and they are responsible for keeping a particular product up and running. So they do the performance, they do the coding, they do the particular interaction with the testing to validate their source code. A huge number of activities is actually done by the development team, and they eventually uses a number of tools like scripting tools, coding tools, development tools. A lot of tools they basically use to support their development, because they are performing different kind of programming. It could be a possibility that more than one programming language is being used for your project. So that's kind of wider scope is present as such over here when we talk about the DevOps here. Now, from the operations perspective, it's basically a team which is responsible for managing the workforce, right? And it's something which we can use to see that all the daily activities and operations should be managed effectively and efficient. So that's the main important point over here, that whenever we are working with the operations, whenever we are working on that, we should be able to get a kind of a decent amount of work and decent amount of activities managed with the help of operations teams here. So operation teams is pretty much responsible for keeping the environment up and running, and whatever the activities and maintenance work we want to do, we will be able to do on that. Now, DevOps really helps us to achieve a lot of milestones over here. Now let's talk about that one by one. So very first one of that is that it helps us to get a frequent release of deliveries here. Now we were doing the releases prior to DevOps also, but that was not that much frequent. Probably people were doing like every quarter, every 3 months, 4 months. That kind of time duration was being used by the team to deliver the source code or deliver into a specific environment. But the moment the specific DevOps comes into the picture, the frequency of this release really increased a lot. So some organization, in fact, trying to do like every month release, twice a month. So that's the kind of frequency which we are getting when we move on to the DevOps. So that really helped and got efficient with the introduction of DevOps here. Now, second one is the team collaboration. Now that is also improved drastically, because earlier the operations and the development teams were not working in that collaboration. They were like working involved in their own task, but with the help of DevOps, they really come along and had a very good team collaborations, which really helps them to increase the overall productivity and the performance of the product. So these are the prime milestones which we achieve with the implementation of DevOps as such into our project. Another one is that it helps to get a kind of a better management here. So effective and efficient management is what we get with the help of DevOps, because ultimately you have redefined your processes, you have implemented certain development tools, certain automations, and that really helps you to increase the overall management of all your unplanned work. So the planning is something which got really improved with the help of DevOps. And faster resolution of issues, because the way you are delivering your source code to the production environment, you are pretty much doing it into a less duration of time. And when that is happening, definitely there is a kind of a increase in the number of bugs which is getting resolved. And there is another benefit that ultimately the number of bugs which you're getting in production, that drastically reduced in case of DevOps. So since we are getting less number of issues and bugs, it's very easy for us to do the resolutions quite quickly and implement into a specific production environment. Right? So DevOps today is being implemented by most of the major organizations, whether it's a financial organization, whether it's a kind of a service organization. Every organization is somehow looking forward for the implementation and the adaptation of DevOps, because it totally redefines and automate the whole development process altogether, and whatever the manual efforts we were putting earlier, that is simply or gets automated with the help of these tools here. So this is something which get really implemented because of some of the important feature like a CI/CD pipeline, because CI/CD pipeline is responsible for delivering your source code into the production environment in less duration of time. So CI/CD pipeline is ultimately the goal, which really helps us to deliver more into the production environment when we talk about from this perspective. Now let's talk about that. What exactly is a CI/CD pipeline? Now, when we go into that part, when we go into that understanding, so CI/CD pipeline is basically continuous integration and continuous delivery concept, which is used or which is considered as a backbone of the overall DevOps approach. Now, it's one of the prime approach which we implement when we are going for a DevOps implementation for our project. So if I have to go for a DevOps implementation, the very first and the minimum implementation and the automation which I'm looking forward is actually from the particular CI/CD pipelines here. So CI/CD pipelines is really a wonderful option when we talk about the DevOps here. So what exactly is the pipeline term all about? So pipeline is a series of events that are connected together with each other. It's kind of a sequence of the various steps, like typically when we talk about any kind of deployment, so we have like build process, like we compile the source code, we generate the artifacts, we do the testing, and then we deploy to a specific environment. All these various steps which we used to do it like manually, that is something which we can do it into a pipeline. So pipeline is nothing but a sequence of all these steps interconnected with each other, executed one by one into a particular sequence. Now, the pipelines is responsible for performing a variety of tasks like building up the source code, running the test cases. Probably the deployment can also be added up when we go for the continuous integration and continuous delivery there. So all these steps are being done into a sequence, definitely, because sequence is very important when we talk about the pipeline. So you need to talk about the sequence the same way in which you're working on the development and in a typical world, the same thing you will be putting up into a specific pipeline. So that's a very important aspect to be considered. Now let's talk about what is the continuous integration here. Now continuous integration is also known as the CI. Pretty much you can see that a lot of tools are actually named as CI, but they are referring to the continuous integration only. So continuous integration is a practice that integrates the source code into a shared repository, and it used to automate the verification of the source code. So it involves the build automations, test cases automation. So it also helps us to detect the issues and the bugs quite easily and quite faster. That's a very early mechanism which we can do as such if we want to resolve all these problems. Now continuous integrations does not eliminate the bugs, but yes, it definitely helps them easily to find out, because we are talking about the automated process, we are talking about the automated test cases. So definitely that is something which can help us to find out the bugs, and then the development can help on that, and they can proceed with those bugs, and they can try to resolve those things one by one. So it's not a kind of automated process which will eventually remove the bugs. Bugs is something which you have to recode and you have to fix it by following the development practice, but yes, it can really help us to find those bugs quite easy and help them to remove. Now, what is the continuous delivery here? So continuous delivery, also known as CD, is in kind of a phase in which the changes are made into the code before the deployment. Now, in this case, what happens that it's something which we are discussing, or we are validating that what exactly we want to deliver it to the customer. So what exactly we are going ahead, or we are moving to the customer. So that's what we typically do in case of continuous delivery. And the ultimate goal of the pipeline is to make the deployments. That's the end result, because coding is not the only thing. You code the programs, you do the development. After that, it's all about the deployments, like how you're going to perform the deployment. So that is a very important aspect. You want to go ahead with the deployments, that's it, you can go there. And that's a real beauty about this, because it's in kind of a way in which we can identify that how the deployments can be done or can be executed as such here. Right. So the ultimate goal for the pipeline is nothing but to do the deployments and to proceed further on that. Right. So when both these practices are placed in together in an order, so all the steps could be referred as a complete automated process, and this process is known as CI/CD. So when we are talking about, like, when we are working on this automation, so in that case, what happens that we are looking forward that how the automation needs to be done, and since it's in kind of a CI/CD automation which we are talking about, so it's nothing but the end result would be like build and deployment automation. So you will be taking care of both the build and the test case executions and the deployments as such when we talk about as such the CI/CD here. The implementation of CI/CD also enables the team to do the build and deploys quite quickly and efficiently, because these are things which is happening automatically, so there is no manual efforts involved, and there is no scope of human error also. So we have frequently seen that while doing the deployments we may miss some binaries or some miss can be there. So that is something which is completely removed as such when we talk about this. The process makes the teams more agile, productive, and the confident here, because the automations definitely gives a kind of a boost to the confidence that yes, things are going to work perfectly fine and there is no issues as such present. Now, why exactly Jenkins? Like, Jenkins is what we typically understand, or we here and there, that it's a CI tool, it's a CD tool. So what exactly is Jenkins all about? So Jenkins is also known as a kind of orchestration tool. It's an automated tool which is there, and the best part is that it's completely open source. Yes, there are some particular paid or the enterprise tools are there, like Cloud Vs and all, but there is no as such offering difference between the Cloud Vs and the Jenkins here. So Jenkins is a kind of open source tool which a lot of organizations pretty much implement as it is itself. So even if they don't want to go, we have seen in a lot of big organizations where they are not going for the enterprise tool like Cloud Vs and all, and they are going for the pretty much core Jenkins software as such here. So this tool makes it easy for the developers to integrate the changes to the project. That is something which is very important, because it can really help the teams to say that how the things can be done and how it can be performed over there. So the tools is very easy for the developers to integrate, and that's the biggest benefit which we are getting when we talk about these tools as such. So Jenkins is a very important tool to be considered when we talk about all these automations. Now, Jenkins achieves continuous integration with the help of plugins. That is also a kind of another feature or benefit which we get, because there are so many plugins which is available there as such, which is being used. And for example, you want to have an integration with Kubernetes, Docker and all. Maybe by default those plugins are not installed, but yes, you have the provisioning that you can go for the installation of those plugins, and yes, those features will start embedded up and integrated within your Jenkins. So this is the reason, this is the main benefit which we get when we talk about the Jenkins implementation. So Jenkins is one of the best fit which is there for building a CI/CD pipeline because of its flexibility, open source nature, plugin capabilities, the support for plugins, and it's quite easy to use, and it's very simple, straightforward GUI which is there, which can definitely helps us. You can easily understand and go through the Jenkins, and you can grab the understanding, and as an end result you will be able to have a very robust tool which using which pretty much any kind of source code or any kind of programming language you can implement CI/CD. Whether it's an Android, it's a .NET, it's a Java, it's a Node.js, all the languages are having the support for the Jenkins. So let's talk about the CI/CD pipeline with the Jenkins here. Now, to automate the entire development process, a CI/CD pipeline is the ultimate solution which we are looking forward. To build such a pipeline, Jenkins is our best solution and best fit which is available here. So there are pretty much 6 steps which is involved when we look forward for any kind of pipeline. It's a generic pipeline which we are looking forward. Now it may have like another steps which is available there, probably some additional steps you're doing, like some other plugins you are installing, but these are the basic steps which is there, like a minimum pipeline if you want to design. These are the steps which is available there. Now let's see. The first one is that we have to require a Java JDK, like a JDK to be available on the system. Now most of the operating systems are already available with a GRE, like a Java GRE. But the problem with the GRE is that it's only for the build process. It will not be doing the compilation. You can run the artifacts, you can run the jar files, you can run the application, run the code base, but the compilation requires the Java C or the Java JDK kit to be installed onto the system. And that's the reason why for this one we also require the JDK. And certain Linux commands execution understanding we need to have, because we are going to run some kind of steps, some installation steps and process. So that's pretty much required. Now let's talk about how to CI/CD pipeline with Jenkins. Now first of all, you have to download the JDK, and that is something which is installed. So after that you can go for the Jenkins download. Now jenkins.io/download is the official websites of Jenkins. Now the best part is that there you have the support for different operating systems and platforms. From there you can easily say that if you want to go for a Java package like a WAR file, Docker, Ubuntu, Debian, CentOS, Fedora, Red Hat, Windows, OpenSUSE, FreeBSD, Ganto, Mac operating system. In fact, whatever the different kind of artifacts or different environment or different application you want to download, you will be able to do that. So that's the very first thing to start upon. You download the generic Java package like a WAR file. Then you have to execute it. You have to download that into a specific folder structure. Let's say that you have created a folder called Jenkins. Now you have to go into that Jenkins folder with the help of cd command, and there you have to run the command called java-jar and the jenkins.var there. So these are the executables artifacts. So WAR files can be easily executable. Jar files, WAR files can be easily deployed. So just because with the Java command you can run them, you don't require any kind of web container or application container as such. So here also you can see that we are running the Java command and it runs the applications as such. And once that is done, so you can open the web browser, and you can open like localhost colon 8080. So Jenkins uses the 8080 port just like a Tomcat Apache. So if once the deployment is done, installation is done, so you can just open the localhost colon 8080. Now if you want to get the Jenkins up and running in the browser, probably you can go through the public IP address also there. So you can put the public IP address colon 8080, and that can also help you to start accessing the Jenkins application. Now in there you will be having an option called create new jobs, so you need to click on that. Now once the particular new job, new item, new job, that's a different naming conventions which is available there. Now all you are going to do is that you're going to do like you are proceeding with creating the pipeline job. So you will be having an option called pipeline job over there. Just select that and provide your custom name what pipeline name or job name you want to refer or you want to process there. Now once that is available, so what happens that it will be an easy task for us to see that how exactly we can go ahead and we can perform on that part. So this can really help us to see that how a pipeline job can be created and performed on these modifications as such. Now when the pipeline is selected, and we can give a particular name, that is, this is the name which is available, and then we can say okay as such over there. Now you can scroll down and find the pipeline section. So there what happens that when you go over there and say that okay, this is the way that how the pipelines are managed and those kind of things, so you will scroll down and find the pipeline section and go with that pipeline script. Now when you select that option, there are different options which is available, like how you want to manage these pipelines. Now you are have the direct access also, like if you want to directly create a pipeline script, you can do that. If you feel that you want to manage, like you want to retrieve the Jenkins files, also code management tool also can be used there, so you can work on that also. So like this, there are so many a variety of things which is available, like which you can use to work around that how exactly the pipeline job can be created. So either you can fetch it from the source code management tool, like Git version or something like that, or you can directly put the pipeline code as such over there, right? Now, so next thing is that we can configure and execute a pipeline job with the direct script. So we can, once the pipeline is selected, so you can put the particular script like Jenkins file into your particular GitHub link. So you may be having like already a GitHub link, so that where the Jenkins file is there, so you can make use of that. Now once you process the GitHub link, so what we can do is that we can proceed with that, and once the processing is done, so you can do the save, and you can keep the changes, and it will be picking up the pipelines. The pipeline script is added up into the GitHub, and you have already specified that let's just go ahead with this Jenkins file pipeline script from the GitHub repository and proceed further. Now once that is done, so what next you can do is that you can go with the build now process. You click on the build now, and once that is done, so what will happen that you will be able to see that how the build process will be done and how the build will be performed over there. So these are pretty much a kind of a way. So you can click on the console output, you will get all the logs that is happening inside that. Whatever the pipeline steps are getting executed, all of them you will be able to get, or you will be able to get on that part there. So these are the different steps which is involved as such. And the sixth one is that yes, whatever the particular when you run the build now, you will be able to see that source code will be will be checked out and will be downloaded before the build, and you can proceed with that part. Now later on, if you want to change the URL of this GitHub, you can configure the job again, the existing job, and you can change that URL, GitHub link URL, whenever you require. You can also clone this job whenever you go ahead and you work on that, and that's also kind of the best part which is available as such, right? And then you can have the advanced settings over there. So in there you can put like your GitHub repository. You can say like okay, the GitHub repository is there, so I'm just going to put this URL, and with that what will happen that the settings will be available there, and the Jenkins file will be downloaded as such. And when you run the build now, you will be able to have a lot of steps, like a lot of configurations going on. So then the checkout SCM, so we can have a declaration like checkout SCM which is there. So when the checkout SCM is there, so it will check out a specific source code. After that, you go to the log and you will be able to see that each and every stage which is being built up and executed as such. Okay, so now we are going to talk about a demo here. So on the pipeline here, so this is a Jenkins portal. Now you can see here that there is an option called create a job. You can either click on the new item, or you can click on the new job, create a job here. Now here I'm going to say like a pipeline, and then you can select the pipeline job type here. Now you have the freestyle pipeline, GitHub organization, multi-branch pipeline. These are the different options which is available there, but I'm going to continue with the pipeline here as such. So when I selected the pipeline and say okay, so what will happen that I will be able to see a configuration page which is related to the pipeline. Now here the very important part is that you have all the general build trigger options which is similar to the freestyle, but the build step and the post build step is completely removed because of the pipeline introduction. Now here You either have the option to put the pipeline script all together. You can also have some particular example. For example, let's talk about some GitHub Maven particular tool here. So you can see that we have got some steps as such over here, and it's pretty much running over there. Now you run it, it will work smoothly, it will check out some source code. But how we are going to integrate like the Jenkins file into the version control system, because that's the ideal approach we should be following when we create a pipeline of a CI/CD. Now I'm going to select a particular pipeline from SCM here, then go with the Git here. Now in there, the Jenkins file is the name of the file of the pipeline script, and I'm going to put my repository over here in this one. Now this repository is of my Git, which is like having a Maven build pipeline which is available there. It's having some steps related to CI for the build and deployments, and that's what we can follow as such over here. Now in this one, the if it is a private repository, definitely you can add on your credentials, but this is a public repository, a personal repository, so I don't have to put any kind of credentials. But you can always add the credentials with the help of add here, and that can help you to set up whatever the credentials, the private repositories you want to configure. Now once you save the configuration here, now what it's going to do is that it's going to give you a particular page related to build now, if you want to run, if you want to delete the pipeline, if you want to reconfigure the pipeline, all these different options are available there. So we are going to click on the build now here, and when I do that, immediately the pipeline will be downloaded and will be processed. Now you may not be able to get the complete stage view as of now because it's still running. So yeah, you can see that the checkout code is done, then it's going on to the build. Okay, that's one of the steps which is there. Now once the build will be done, so it will continue with the next steps, with the next further steps there. So you can also go to the console output log here, like you can click on this, or you can click on the console output to check the complete log which is happening there. Or in fact, you can also see the stage wise logs also, because that is also very important. When you go for the complete logs, it may have a lot of steps involved, and a lot of logs will be available there. But if you want to see a specific log of a specific stage, that's where this comes into the picture. And as you can see that all the different steps like test cases executions, the sonar cube analysis, the archive artifacts, deployment, and in fact the notification, so all this is a part of a complete pipeline. This whole pipeline is done here, and you get a kind of a stage view, its success over here, and the artifacts is also available to download. So you can download this WAR file is a web applications as such over here. So this is what a typical pipeline looks like, that how the automation, the complete automations really looks like as such over here. Now this is a very important aspect because it really helps us to understand that how the pipelines can be configured, can be done, and pretty much with the same steps you will be able to automate any kind of pipelines as such. So that was the demo to build a simple pipeline as such with the Jenkins, and pretty much in this one we understood that how exactly the CI/CD pipelines can be configured, and we can use them, and we can get hold on that part. Now in this one we are going to talk about that how exactly we can integrate both the Maven and the Jenkins here, just to implement the CI processes over here. Now what is the purpose of Jenkins here? Now Jenkins is normally a kind of a CI tool which we use for performing the build automations and the test cases automation there. It's one of the open source tool which is available there, and one of the most popular CI tool also available into the market. Now this tool makes it easier for the developers to integrate the changes to the project here. So we can easily integrate the changes, and whatever the modifications we want to manage, we will be able to do that with the help of Jenkins. Now Jenkins also achieves the continuous integration with the help of couple of plugins. Each and every tool which you want to integrate have its own plugins which is available there. For example, you want to integrate Maven, we have a Maven plugin in Jenkins which you can install, you can configure. In that case you will be able to use the Maven there. Now you can deploy the Maven to build tool onto the Jenkins server, and then you can prepare or you can configure any number of Maven jobs in case of Jenkins. So what exactly the Maven or the Jenkins really do is the Maven when integrates with Jenkins through the particular plugin, so you can able to automate the builds, because for automation the build you require some integration with the Maven, and that integration is what we are getting from the Maven plugin. So in Jenkins you have to install the Maven plugin, and once the plugin is installed, so what you can do is that you can proceed with the configurations, you can proceed with the setup, and this particular plugin can help you to build out some of the Java based projects which is available there in the Git repositories, and once that is done you will be able to go ahead and you will be able to process a complete integration of Maven within Jenkins. Right, so let's see that how we can go for the integration. Now I have already installed the Maven onto the Linux virtual machine which we are using. So using the app utility or using the yum utility, you can actually download the Jenkins package and the Maven package onto the server, onto the virtual machine. And now I'm going to proceed further with the plugin installation and the configuration of a Maven project. So I have a GitHub repository which is having a Maven project, Maven source code and the Mavenized test cases over there. So let's log into the Jenkins and see that how it works. So this is the Jenkins interface which we have over here. Now in this one, what we can do is that we can create some Maven jobs over here, and once those jobs are created, we will be able to do a custom build onto this Jenkins. So first of all, we have to install the particular plugin here. For that, we have to go to the Manage Jenkins. In Manage Jenkins, you have the Manage Plugins option there. So you have to click on that. Now here you will be having different tabs like updates, available, installed, advanced. All these different tabs are available there. So what you can do is that you can click on the available one. When you go to the available tab, so what will happen that here you can actually put up that what exactly plugin you want to fetch here. So I can put up plugin called Maven. Now you can see that the very first one, the Maven integration tool, is available. So I'm going to select that particular plugin and click on download now and install after restart. Now once that is done, so what will happen that the plugin will be downloaded, but in order to reflect the changes we have to do a couple of restart. Now for that you don't have to go to the virtual machine. You have the option here itself that will allow you to do the restart over here when you click on this button. So you check this option and say that restart Jenkins when the installation is done. So what will happen that the installation will be automatically attempted whenever the particular plugin installation is completed here. So you just have to refresh the page again, and you will be able to see that the particular Jenkins is being processed as such here. Right, so you can see that the screen is coming up that Jenkins is restarting. So it will take a couple of 5 to 6 seconds to do the restart and the login screen to come up again over there. You can do the refresh also if you feel. Automatically it will be reloaded once the Jenkins is ready, but sometimes we have to refresh it so that we can get the screen over there. So once the login is done, so my Maven integration is done. So next thing which I will be doing is that I will be creating a Maven related project. So I'm going to put the admin user and the password. So whatever the user and password you have created, you are going to put that so that you will be able to log into the Jenkins portal. Now this is the Jenkins which is available here. So all you have to do is that you have to click on create a new job or new item. So both the option is pretty much same only. So here you will be able to see a Maven project here. So I'm going to select like Maven build. That's the name which I'm going to give here, and the Maven project I'm going to select here and then press OK. Now here you will be providing the first of all the repository from which you will be checking out the source code. Now I can have a discard old builds over here. So if I feel that I want to have like a log rotation, so all the previous builds should be deleted. So I'm just saying that dates to keep build should be 10 over here, and the number of builds which I need to keep over here is 20. You can adjust these settings according to your requirement, but over here we are doing a kind of configurations which we are trying to do a lot of configurations and settings here. So these are the particular settings which we are looking forward as such over here. So now we are going to have the log rotation here. So we can have it like how many days we want to keep and how many number of builds we want to keep here. So both the values we are providing over here. And then now I'm going to put the Git integration here, like the repo URL. So I have this repository here in which I have the Java source code and some particular unit test cases, and I also have the particular source code, and it's kind of a Maven project. So that's what I'm trying to clone over here with the help of this plugin. So this plugin will download this repository, it will clone it onto the Jenkins server, and then depending on our integration with Maven, the Maven build will be triggered here. So now I'm going to process with the Maven here. So you can see here that it's saying that Jenkins needs to know that where the Maven is installed, because that Maven version it needs to configure, it needs to process on that part. So I'll just do the save over here, and or I can click on this tool configuration. So I'll just save or do the apply, click on this tool configuration here. Now here you have the options like where you can have the JDK installation, but what happens that since Jenkins is running there, so JDK is automatically installed. So in the tools configuration you don't have to put the JDK configuration, but at least for the Maven configurations you have to provide that where exactly the Maven is available there. So I'm just saying that Maven 3 I want to process, and the latest Maven Apache web server I want to configure here. So I just want to have I just want to save this setting so that it will be automatically download the latest version Apache 3.6.3 version there, and that same should be utilized over here in this case. Now I'm just going to the Maven build configuration here and click on the configure part. So these Git repository is available here, and in the build step it automatically builds up that what Maven environment you want to select. So you see that previously, since I did not configure my Maven environment, so it was throwing an error. But once I have configured that I have to download it during the build process or before the build, that utility should be downloaded. So instead of doing the physical installation of Maven on the server, what I have chosen over here is that I have selected the particular version, like I have selected that particular 3.6.3 version should be installed for the Maven purposes over here. Now once that is done, I'm going to put the particular steps over here. You can have it like clean install, you can have clean compile test, clean test, or test alone you can give. It's just a part of the setup or the goals which you want to configure here. It by default says that pom.xml file is the current one in the current directory you need to refer, you need to pick on that one. What it's up to you only that how you want to configure and how you want to process as such these information. So according to your requirement, you can say that okay, I just want to go for these particular goals, and you can say like save over here. The particular configuration will be saved. Now you can just click on the build now, and you will be able to see that the first of all the git clone will happen, and then the desired Maven executable will be the build tool will be configured, and according to that it will be processed here. So you can see here that the Maven is getting downloaded, it's getting configured here, and once it's configured, because I have explained over there that 3.6.3 version I have to select, so that specific version will be configured and will be picked up over here. Now even if you don't have the Maven installed on the physical machine on which the Jenkins is running, still you will be able to do the processing using this particular component here. So you can see here that we have some particular test cases executed, and in the end we are able to get a particular artifacts also there. Since I did not call upon the package or install goal, that's the reason why the particular artifacts was not generated, war file or jar file, whatever the packaging mode is available at POM level. But still what happens that my test cases do gets executed, and that's what I have got over here in this case. So this is a kind of a mechanism where we feel that how we can configure a Git repository. Once the Git repository is configured, you are going to integrate the Maven plugin. In the Maven plugin, you are going to configure in the tools configuration that this and so version I want to configure to run my build. And once that is done, after that you just have to trigger the build and click on the build now option, and once that is done, you will be able to get a particular full-fledged build or compilation happened onto the Jenkins, and this log will give you the complete details that what are the different steps which has happened on this one.
So what exactly is Jenkins? Jenkins is nothing but a powerful automation server that is written in Java, and it is a web application which can also be run on any web server. But what makes Jenkins an ideal choice for a continuous integration server? Jenkins has got wonderful plugins that allows it to connect to all kinds of tools, software development, deployment, coding, build, source code kind of tools. That is what makes Jenkins very, very powerful. From a continuous integration perspective, Jenkins can connect to various source code servers, and it has also got plugins that allows it to build, deploy, test all kinds of software artifacts. So this is what makes Jenkins an ideal choice for a continuous integration server. But mind you, for me, Jenkins is nothing but a very, very powerful automated server. At the heart of it, there's a lot of automation in it, but the powerfulness of Jenkins is more so because of the tools that it integrates with and the kind of plugins that it has got. What is continuous integration? From a software development lifecycle, assuming that the software delivery is happening in very small sprints, maybe 3 to 4 weeks is your delivery lifecycle, and there are a bunch of developers who are located in different locations who are working on the same code base, on the same branch. If the code check-ins do not happen quickly, as in every day, if at all developers stagger their code check-ins into the repository, finding problems at a later stage would be very costly for the whole project. Early detection of any such issues would be, quick to resolve and would not affect your delivery schedules. So, as a part of continuous integration, what is requested or what is demanded is that every developer checks in code pretty much, every day. As long as it doesn't break the code, he checks in code pretty much regularly. And at the end of a day, you have an automated server which kind of wakes up, pulls the latest code. So this code has got the integrations of all the code bases that has been checked in by various developers. So it pulls out the code. It builds on a completely different server. That is the CI server, which pulls this code. It builds it. It's got all the tools that is required to compile it, build it, and test it. And assuming that you got some good percentage of test case automation, you're also having most of your regression test suites automated. If at all there is a way by which in a couple of hours time, when the team is out or rather the team is sleeping, you have verification that happens at a very crucial level, and then any breakages even before the team arrives for the next day, if these are notified to the whole team members, saying an email going out saying that something got broken, most of the code would be pretty okay from the perspective of compilation errors or build errors. It is the functionality and the regressions that the team is worried about. So if these can be automated, tested very, very quickly and very, very fast, and then any breakages are detected early during the day. Right? By the time the next day people come in, they know what is broken and possibly they know what code check-in broke that particular thing. And they can have a quick stand-up meeting and then they discuss what broke the code and able to fix it. So this way, any problem that could possibly arise at a later point of time, if at all they kind of move to the initial phase of the project, any detection that is early doesn't really hurt the team. So this is all continuous integration that is about, and Jenkins plays an important role in being the continuous integration server because it's got connections to anything and everything, all kinds of tools, and then it has also got various ways on which triggering the job, which is a part of its automation strategy. Now that we know what is continuous integration and where does Jenkins come into picture, let's look at the rest of the tasks of our software development lifecycle. So if at all I were to visualize the kind of steps that is involved in delivering my software, possibly the continuous integration phase would be somewhere here where multiple developers are developing on that. And then we have a little bit of a stable code that is there that can be kind of moved across because I want to go ahead with the particular build that I have, and then I want to migrate that, I want to propagate that across various environments. So if you consider the standard software delivery approach, in the first cycle, you just do some minimal testing. And then you kind of move that to one of the environments. And from there, you kick off more and more tests. They could be integration test. They could be acceptance test. They could be functionality check. They could be a stress test. They could be a load test. It could be a system integration test. All kinds of tests that you can think about. And all the way maybe propagating the build across various environments. If all this can be considered as various steps, the workflow is such that as and when the build moves across various phases, if there's any failure, of course, the build propagation kind of stops. Everyone gets notified. But if at all everything goes well, so your workflow is progressing well, and at the end of the workflow, you eventually have a code which is pretty much good to release. Now, mind you, I make an assumption here that most of your test cases are automated and you have a good percentage of coverage of your test cases. But if that is not the scenario, then possibly there are some automated tests or checks that may be required in between. But if the workflow can kind of accommodate all that as well, you can visualize this as the steps that is required for your software development or a software delivery lifecycle. Now in Jenkins, the way this kind of translates is that each of these tasks can be put out as a job. So now let me quickly let you know, or let me quickly demo what existed in pre-Jenkins 2.0, where I could put up a couple of jobs and I can connect them using the upstream downstream linking mechanism. So if this job 1, if at all it is a build and unit test cases, if at all that passes successfully, job 2 gets triggered. If the job 2 is more about running some more automated tests or possibly deploying it to environment and then kicking off some more test cases, that would be job 2. But if the deployment fails or if some of the other test cases fail, it would not propagate to the third job. All right, so let me quickly bring up my Jenkins instance and put up some sample jobs and tell you how to connect that, or rather how would one connect that using Jenkins 2.0 or pre-Jenkins 2.0 release. I have now brought up my Jenkins instance, and in case some of you don't know how to install Jenkins or you don't know how to bring up your Jenkins instance, I would strongly recommend that you watch our previous videos on Simplilearn YouTube channel, where I've detailed out the steps that is required for you to install Jenkins and bring it up. So alright, so I've brought up my Jenkins instance. Let me put up few of those jobs now. Mind you, I'm going to cover the pre-Jenkins 2.0 feature here. Alright, so let me put up my first job. Alright, I hope I don't have that job. I say it's a freestyle project. I don't want to change anything. I'm going to put up a very simple job here. It's in batch command. I say echo first job triggered at. Alright, that's my first job. Now let me put up my second job. It's a freestyle project. All right, that's my second job. All right, that's my third job. I've got a very simple echo statements in this. So it just prints out the system date and the time in it. All right, so I could run these jobs individually if I want. So let me just check running my third job. So this is what I get in the console output. Third job triggered at date and time. Oops. Let me fix that. All right, that should fix it. Let me check my second job. All right, that's my second job. All right, so I've got three jobs. Now, if I were to link them together, or if at all I want a scenario where after the first job is successfully run, I would like to trigger my second job. So I would do a small configuration change in here. I would say after this first job is run, I want to trigger the second job. So I have something called as a post build action. So I can say that trigger some other jobs from here. So if you see this, publish, record, deploy, all right, trigger. Let me check the other one. Build other projects. This is what I would want to do. So after the first job is done, I want to trigger my second job. All right, I would say save this. Now let me go back to my second job and then trigger the third job after the second job is done. All right, I will add this post build other projects, third job. Again, I'm not really sure if you guys noticed this. There is various configurations as to when exactly do you want to trigger the other job. And the default one is trigger only if the build is stable. So typically this is the configuration that would need. We definitely don't want the third job to be triggered in case the second job fails. All right, so this is the combination that I want, or this is the choice that I want. And let's save this. Now I have three of my jobs. If you see this, the second job, the upstream job is the first job. So let me check this kind of a pipeline. What I've set here is a very simple pipeline. So after my first job gets triggered, if I build this guy, right, the second job gets triggered after the first job is built. So if I click on the second job, all right, So the first job was trigger the second job, and after the second job, it is triggering the third job. So this is how first job, second job, and third job were kind of linked. But it's pretty hard to visualize this as to, if I need to see one holistic picture where after the first job, after the second job, after the third job, what was the flow? It's not possible for me to visualize that. That's wherein I install a plugin. So let me go to manage plugins right here. I think I already have it installed. For those of you who don't have it installed, you can go to the available button, available tab, and click on that. The plugin is called Delivery Pipeline plugin. I already have it installed. In case you don't have it installed, you just go to the available, you click on this and say install without restart. This is the plugin that I want you to install. All right, so now we have that plugin installed. So what I want to do is after the plugin is installed, you see something like this. So this is where I would create a new visualization for the pipeline that I've created. So I would say my first pipeline, or I give a name for my visualization. I would say, yes, this upstream, downstream dependencies, this is exactly what I want. And there are a bunch of settings here. I'll not look at any of that now. What I want is, I just want to tell this view that, I can give a name for this. I would give it as Simplilearn pipeline. And what's important is that I specify what is the first job that should be picked up as a part of this pipeline. And the final job is optional because it knows that if the first job is triggering this other jobs, it knows where to end this whole life cycle. So I define a pipeline, I give a name for my component, and I initialize that as I give it the first job. So I say, okay, and there you go. This is much better. This gives you a beautiful visualization of as to what happened after the first job, second job was run, second job. If I click on any of these, that will in fact take me to that job. All right, there is also one other option, which is pretty good option in my opinion, which is about edit view. Yes, this is where it is. Enable start of a new pipeline build. Let me apply and let me click OK on this. What it gives me is a way in which I can trigger my whole pipeline from here. So if I click on this, there you see the first job getting triggered, the second job is still running. The green means it's all run properly and nicely. The second one is triggered now. The third one, it's still running. All right, so this is the pipeline that existed prior to Jenkins 2.0. This is pretty decent enough, and if you see, there's a one-to-one mapping. But if at all you remember, we could go and add multiple dependencies for the projects that I set in. Just to give an example, let's say if I go to my first job, I can do a configuration here, and nothing stops me from triggering multiple jobs after this by giving me a comma. I can trigger multiple jobs here in case if I have to run few things parallelly. This also gives me that option to do that. But having said that, this was the most primitive way in which the jobs were kind of visualized and run prior to Jenkins 2.0. Now, this feature became such an important feature. The users wanted more and more complicated because the pipelines was not a lot complicated. It was not just one job after the other. There were multiple jobs that has to be run. And there was also an introduction of the Jenkins agents where multiple tasks could be parallelly run on different agents. So they wanted to club all of that, and the pipeline could have all the such complicated stuff. That's where in post Jenkins 2.0 or in Jenkins 2.0, Jenkins released a version which has got the feature of pipeline which can be written in Groovy scripts. Now, Groovy is wonderful scripting language. It's very, very powerful. Anybody can visualize your pipeline or write your pipeline using programming language. And the point of everything as code, where this whole Groovy script gets into your source code repository. So instead of putting jobs here, and in case my Jenkins kind of fails, there's a crash on my Jenkins, I don't get back these jobs. How do I bring back all these jobs back? So everything as code, that's the DevOps principle. So the pipelines will be written as scripts. That is what I'm going to do in my next exercise. In my previous example, I showed you the crude way, in my opinion, of putting up a Jenkins pipeline. But this is what existed prior to Jenkins 2.0. And now I have post Jenkins 2.0 in terms of my version. Jenkins version is 2.107. So this supports something called as a scripted pipeline, wherein you can write your pipeline in terms of Groovy scripts. No need to put up any jobs here and remember how exactly you put up these individual jobs. You can write a pipeline script in terms of Groovy language. Let me quickly show you a very, very simple and elementary pipeline that I have. This is what a Groovy script would look like. Pipeline, any agent can run this. Stages, there are individual stages that is defined as a subset of these stages. So the first stage is the compile stage, and stage has got some steps in it. You can have multiple steps in it, and once only after all these steps successfully complete, that's wherein the stage gets through perfectly with the pass. So there's a compile a stage, there's a JUnit stage, there's a quality gate stage, there's a deploy stage, and I'm really not doing anything much within this other than echoing, some text within each of these stages. And what's interesting is at the end, there's something called as a post, which is similar to, or you can kind of equate that to what would be there in a try catch kind of a block. So post always, meaning this would run all the time. Success, only if at all the steps that were above in terms of the stages, they were completed successfully without any failures. So typically you would have your email that is going out here saying that the build is successful and stuff like that. Failure, if something went bad, if any of the step resulted in a failure, this particular block will get executed. Unstable, whenever any build is marked unstable. If at all, only few things that failed within your test run and you would want to mark the build as unstable are changed. This is an interesting option. So this compares the present run with the previous run, and if there's any change, meaning if the previous run was a failure and the present run is a success or vice versa, this would get triggered. So this is what a simple pipeline script would look like. So let me copy this pipeline and let me put up a simple job for running this pipeline. So let me open up my Jenkins, say a new, I would say scripted pipeline. Yeah, this is what I want. I don't want to choose a freestyle project. This is going to be a pipeline project. So I would say pipeline and say okay. All right, this has got far less options than the other jobs that we put up. So general, I don't want anything here. I don't want any build trigger. Right. So this is where I can paste in whatever I had copied. There's also something called as a pipeline syntax or a syntax generator. This is like a lookup where you can choose what you want to do and choose the option that is specific to those steps, and you will get a pipeline generated or a script generated for you. Jenkins knows that you're not very good at understanding these pipelines, so this gives you this sandbox kind of an environment where you can check out whatever you want to do as a part of your pipeline and then get the equivalent groovy script from here. Let me look at this in a bit later. So for now, I have my pipeline syntax already copied. So what I'm going to do is I'm going to paste what I copied. All right, so this looks good. Okay, I'm not connecting to any GitHub repository or any of that. I'm just running a very, very simple pipeline which has got some steps in it, and it just compiles, or rather it just puts out some messages saying that this stage completed successfully and stuff like that. So let me save this and let me try to run this scripted pipeline. All right, if you see this, you would see each of those steps going through, and if at all I look at the console output, compile successfully, unit passed, all the stages passed, there was a pass, the failures doesn't show up. You would see the messages from our post or the try catch block that I was mentioning earlier. So this is how one would put up a pipeline, and you also get to see the visualized view of your pipeline that says which stage run after which phase, how much time did it take, and you can click on any of these and get into looking at the logs from that particular pipeline run. That was pretty easy, wasn't it? Now let me give you another scenario for a pipeline wherein the source code of my pipeline would be in a GitHub repository, and I will write scripts to grab this particular code and run some part of the code which is there as a part of the repository. So let me look at the repository that I have. I have a repository out here on the Simplilearn GitHub account, which is called the pipeline script. And if you see in there, there are a bunch of batch files that are there. So the first batch file would be a build.batch. So there's nothing in it except that it is just trying to build a particular project. You can visualize this as individual batch files, which actually contain the scripts for building, running, deploying, and checking the quality gate of your particular project. So I have a couple of batch files that is here, and this is on the GitHub repository. So I would need to write Jenkins job, which will log into my GitHub account and then check out this particular repository from my account and then run these batch files as a part of those individual steps within the scripted pipeline. So let me check as to how I could do that. Let me put up a new project for this. Let me call this scripted pipeline from GitHub. All right, so let this be a pipeline project. That's good enough for me. Let me see my scripts. All right, now this is where I need to put in the scripts for pulling out the code repository from my GitHub server and running those batch files that are there as a part of the repository. So what I want to do is I already have the skeleton of my pipeline that is written, which is very similar to whatever was the pipeline syntax that I showed you in the previous step. So I just copy this out here and then paste it here. So what I have here is I've written on the high level skeleton without really putting in the actual steps required for checking out rather running those build scripts. So I've got 4 steps. One is the git checkout step, the build step, unit test, quality gate, and possibly the deploy. Alright, so I need to put in the actual scripts that is required for first checking out the repository from my GitHub server. So this is where I will make use of this pipeline syntax. So as I mentioned earlier, you have a bunch of help that is available for you to figure out the actual scripts that is required for you to write within your pipeline. So what I wanted to do is check out something from Git. So it's Git related. So search on Git and you'll find this option. So I got to specify my Git repository URL and my credentials. So let me look at the repository URL. This would be my repository URL. So let me copy this. I'm going to copy the HTTPS URL of my repository, and branch is good. And one thing that you got to notice is for now, the repository is anyway a public repository on GitHub. So even though if I don't specify any credentials, that would work for me still. But in case you have a repository which needs strictly a username and password to be specified, you can kind of add it out here using add Jenkins, and you can give your username and password out here. But for now, I don't need any of these things. So I'm going to just say git checkout, or rather the URL of my repository, and what we want is the master branch. For now, I have only one branch on my GitHub server, so this is good for me. So this is what exactly I want to do as a part of the script. So if I click this, this is the script that I need to put in my build script. So I come over here and this is what will check out the code from my repository. Alright, so now once I get my code onto my repository, from my repository rather, it will grab those code, all these batch files, and get it onto my Jenkins workspace. Now I'll have to run these batch files as a part of each of my step. So let me look at what would be the syntax. So the first one that I want to run would be my build.bat. Alright, so I want to run a batch file. Alright, and what is the name of the batch file that I want to run? I want to run this build.bat. So generate pipeline script. This is all that I got to specify as a part of my build step. And then unit test, I've got to just change this to unit. I think that's what I have in my repository. Okay, that is unit. And then deploy and quality. Q capital quality, and this one would be deploy. Alright, so this piece of code will actually get into my repository and check out my source code and grab it and take it to the Jenkins workspace. So from this workspace, since all the files are there in the root directory of this workspace, it will run these batch files one after the other. Alright, let me save this and let me try to run my pipeline. Alright, so it runs a lot of things in the background trying to get the source code from my repository. Whoa, that was fast. Alright, so it pulled out all the source code from my repository. The last commit message from where the source code was pulled out was this create deploy.bat. That looks good. I'm saying building checked out project, building the checked out project. This is what I had in my build.bat if I'm not mistaken. Okay, building the project, that's what is there with the timestamp, running unit test cases, unit.bat, it is running the unit.bat, and then giving me the date and timestamp. Okay, so all these kind of passed, and if I go back to the project, I will also see this beautiful view of how exactly, what is the time that was taken for checking out the repository, running the build.bat, running the unit test cases, quality gates, and all this. Isn't that pretty simple? Now let me modify my previous job, or rather let me put up a new job for making use of an agent wherein I could delegate a job to an agent. Typically, agents can be brought up on any other remote machines other than where your primary Jenkins server is running. In case you don't know or you don't know how to start up these agents, I would strongly recommend that you refer to our previous Jenkins video on the Simplilearn YouTube channel. Alright, so let me just check the status of my agent for now. Yes, he's offline. So let me start this agent because agent is not running. So I have the agent set up in my Simplilearn agents. So let me copy the script file that is required for starting my agent. Let me go to the agents folder, open up a command prompt, and let me try to bring up my agent. All right. So the agent is up and running. For now, I don't have the luxury of starting my agent on a different machine. So my agent is running on the same machine, but the agent's workspace is SQL agent, while my primary Jenkins server is running, has the workspace out here, SQL program files 86, and this is the workspace of my Jenkins. All right, I hope you can kind of differentiate those two. All right, so now what I want is I will look at the same job that I put in earlier, or rather modify that. Let the steps be the same, but I don't want to run that on my master server. Let me try to delegate that using the script. So let me put up an agent scripted job. All right, it will be a pipeline rep job. I would say okay. And let me copy. This was a step that I had put in for my previous job. So agent any. So what I'm going to do now is I don't want this to be running on any other agent. I want this to be running on the agent whose label is, let me check what is the label of my agent that is running. Okay. So this is the name of my agent. Okay. Windows node. So let me just copy that there. All right. So with a very subtle change, instead of saying agent any, I'm going to run, or rather I'm going to specify the agent who will be running this job is the one who has got the label as Windows node. So this agent that I brought on my system has got the name as Windows node, and it is configured to pick up any job that matches the label to which any job is kind of delegated. So let me come back to my jobs. Where is my scripted agent job? I've got too many jobs running. All right. So this is my agent scripted job that I left halfway through. So here in the pipeline, what I'm going to do is this is all I'm going to need. So the job remains the same. Git checkout is going to check out from the same repository, run the batch files accordingly. But this change is just to ensure that this job is kind of delegated on the agent. All right. So this would be my agent job. Let me save this. Let me get back to the dashboard and let me run it from here. If you see this, the master and agent are both idle as of now. Let me try to run this agent scripted job. All right, so the agent kind of kicked in and there was a job that was delegated to the agent. If I look at what is there in the console output, he's pretty much doing whatever was there as a part of the job. But the interesting thing to note is that this is the new workspace, or rather this is delegated to the agent, and the agent's workspace is this particular folder. So this is where it's going to get all this stuff, run the whole thing, and the flow is pretty much the same. The only thing is this whole thing ran on the agent. If I need to check my agent, I would see the workspace out here, agent scripted job. If you look at this, all the batch files are here, and this is where the job was kind of delegated to run. So with a very subtle change in the scripting, I can ensure that the jobs are kind of delegated onto the agent, the pipeline job specifically. As I mentioned earlier, Jenkins provides you two different ways of writing pipelines, called the scripted and the declarative. The first one that was launched was the scripted pipeline. This is heavily based on Groovy scripting. Since Jenkins ships along with the Groovy engine, so this was the first script or the first support for pipeline that was provided by Jenkins in 2.0. This needs a little bit of a learning curve since Groovy is a wonderful script. Understanding that may be a little cumbersome. But then once you kind of master it, you can write really powerful scripts based on Groovy. At a very high level, this is what a typical scripted pipeline would look like. There's something called as a node. Node represents the agent or the actual box on which your job would be running. And then a bunch of stages are put out, which each of the stage along with the steps that needs to be covered as the part of those stages listed one below the other. So all these stages, if they run peacefully, then the whole task is kind of marked as run successfully. Since understanding Groovy or learning Groovy was a little tough for many of the people, so this is a new one from Jenkins wherein it provides you a much simple and friendly syntax for writing pipelines without really needing to understand or without really needing to learn some Groovy scripting. Again, there's a very subtle change between these, and there are a lot of lookups for figuring out what is a better pipeline for you to kind of write. But if you can figure out the difference, or if you can try to find that particular piece of code which kind of helps you out with your pipeline, either of the scripts, there's not really any difference in writing or kind of delivering your pipeline using either of these two methods. All right, so declarative pipeline is something like this, where you have an agent. You can specify the agent label, or if you can say agent any, it will pick up whatever is an available agent and run the job. And then you have something called as stages. Stages is nothing but a collection of stage, and stage could have multiple steps defined within this. So if any of the steps in any of the stage fails, then that particular complete stage and the build is marked as failure. So very subtle difference between both these two syntax, but using either of these, you can write powerful scripts for your pipeline. Now let me come up with an example where I'm going to at least demo one of the feature where you could run a master and a slave job in parallel. So let me come up with a demo for that particular scenario. Let me put up a new job for my parallel agent pipeline. Let me call this, and this would be a pipeline project. I don't want anything here. Let me look at the pipeline script that I have. Pipeline agent none stages, and there's a first stage where this would be a kind of non-parallel stage where there's a need for you to possibly pull out the source code from one of the repositories and possibly unit test it. If all the unit test cases pass, then possibly you want to deploy it to one of the test environments. That would be what would be there as a part of the non-parallel stage. And then you may have a bunch of tests that could be run, and assuming that you have a Windows node, you have a Linux node, you have some other kind of an operating system based node, you could run these stages in parallel. So for demonstration, I've just put in two parallel stages. In parallel is the keyword that you're going to use for running tests parallelly. So I would say parallel stage test on Windows, and I'm going to run this in my Windows node. Well, I could run a bunch of steps that I want out here, and then in the other stage or other step, what I want is I will run something else on my master. As long as this parallel keyword is encountered, Jenkins will ensure that these two stages are run parallelly. For now, I have both these things running on my same machine, but assuming that these were running on different boxes, you could kind of visualize it as these two steps are going to be started parallelly, without really any dependency on each other. And then you could wait for the test results, and then based upon whether both of these steps passed or failed, if one of them failed, then we could kind of mark the build accordingly. So let me copy this pretty simple script. Let me put this out here, and let me save this out, and let me try to build this. All right, there you go. This stage will be executed first. This is a non-parallel stage that's going to happen. Then the task 1 on agent, task 1 on master, followed by, as I said, since I have only one node, or rather one system on which both these things are running simultaneously, you would not really see a benefit of this. But assuming that you have a couple of boxes on which you have multiple agents running, you will possibly want to run your Selenium tests on the Windows box, because Selenium brings up some of those UI which needs a browser. You could possibly need some regression tests that could run on Linux boxes or Linux agents. And then you can kind of break down your tasks into multiple things that is running on multiple systems at the same time, and then collate all the results. Okay, one final thing. All right, now I have all my particular job, or rather the steps required for my pipeline put down in terms of the scripts, and this is saved in this particular job. That's not a good or a recommended approach. So what I'll do is I'll copy all of these steps out here, and then what needs to be done is actually, let me go back to this repository. The most preferred approach is where you create something called as a Jenkins file, and you paste all the scripts that is required for your pipeline. Now this is in a true sense the DevOps approach, where I'm going to save this out. So if at all you have a pipeline defined for your project, the best place to kind of put out your configurations for the pipeline is within your repository. So this may be a different project that I was referring to, but assuming that you have your project where you have to define your pipeline, instead of putting that as a particular job on Jenkins and fearing that if Jenkins fails or the jobs, there's a crash and then you lose out your job configuration, the best approach is to use a Jenkins file. Put all the steps that is required, the tried tested steps that is required as a part of your Jenkins file, and then you can put out a job that can pull the source code from here as well as use the steps that is defined in the Jenkins file. So let me end up by putting up another job which is a true DevOps kind of a job. So I would say DevOps pipeline, and this is a pipeline script. And then I'm not going to say any of these things. I would say the pipeline script is from the source code management. So my pipeline script is already defined. It is present in SCM. So what is my SVN? What is my source code repository? This is my source code repository where I already have this. So let me copy this URL. This is my URL. I don't need any credentials because the repository is anyway in public repository. That is all that is required, I would say. And the scripted file, it automatically picks up Jenkins file. All right, so let me save this. Let me build this. So that's the beauty of DevOps, wherein I have a pipeline that is defined, and instead of putting the pipeline as a job, because pipeline is nothing but a configuration, the configuration is also checked into the source code repository, and any changes to this pipeline, instead of putting that modifications in the job, these are all captured as a part of my repository. So the changes are nicely configured so that we know who's done what change.
DevOps has emerged as a transformative approach fusing development and operations to streamline workflows, enhance collaboration, and boost efficiency. This dynamic fusion has given rise to a multitude of groundbreaking projects that are reshaping the industry. So in this explanation of the top 10 DevOps projects, we'll delve into the innovative solutions and tools that are catalyzing progress from automation and containerization to continuous integration and deployment. These projects not only facilitate agility but also drive excellence in software delivery, ensuring that DevOps remains at the forefront of modern technology. So join us as we embark on a journey through the most influential DevOps initiatives of our time. With that said, if these are the types of videos you'd like to watch, then hit that subscribe button and the bell icon to get notified. So let's start with why are DevOps skills crucial? Understanding DevOps is vital for optimizing the software development lifecycle. DevOps engineers need to master several key skills. Linux proficiency. Many firms prefer Linux for hosting apps and managing configuration systems. It's essential for DevOps engineers to be well-versed in Linux as it's the foundation of tools like Chef, Ansible, and Puppet. Continuous integration and continuous delivery. CI ensures teams collaborate using a single version control system, while CD automates design, testing, and release, improving efficiency and reducing errors. Number 3. Infrastructure as code. Automation scripts provide swift access to necessary infrastructure, a critical aspect with containerization and cloud technologies. IAC manages configuration, executes commands, and swiftly deploys application infrastructure. Configuration management. Tracking software and operating system configurations ensures consistency across servers. Tools like Ansible, Chef, and Puppet simplify this process, making it efficient. At number 5, we have automation. DevOps aims for minimal human intervention, maximizing efficiency. Familiarity with automation tools like Gradle, Git, Jenkins, and Docker is essential for DevOps engineers. So these tools streamline development processes and enhance productivity. Moving on to the first project of the day, we have unlocking efficiency of Java application with Gradle. Meet Gradle, the versatile build automation tool transcending platforms and languages. This project helps you start on a journey of Java application creation, breaking it into modular subprojects and more. The main aim of this project is to help you master project initiation as a Java application, adeptly build it, and generate meticulous test reports. You will be well versed in running Java applications, crafting archives, and elevating your Java development pros. So dive in to transform your coding skills with Gradle. The source code for this project is linked in the description box below. Moving on to project number 2, unlock robust applications with Docker for web servers. Docker, the go-to container technology, revolutionizes services and app hosting by virtualizing operating systems and crafting nimble containers. This project focuses on creating a universal base image and helping you collaborate with fellow developers in diverse production landscapes. You will be dealing with taking web apps foundations in Python, Ruby, and Meteor. So master this project and you will yield Dockerfile efficiency like a pro, slashing build times and simplifying setups. So say goodbye to lengthy Dockerfile creation and resource-heavy downloads. The source code for this project is also mentioned in the description box below, so don't forget to check out. Moving on to project number 3, we have master CI/CD pipelines using Azure. In this Azure project, we harness Azure DevOps to create efficient CI/CD pipelines. This project mainly focuses on leveraging Azure DevOps project. We deploy applications seamlessly across Azure services like App Service, virtual machines, and Azure Kubernetes Service or AKS. Utilizing Azure's DevOps starter, we set up ASP.NET sample code, explore pre-configured CI/CD pipelines, commit code changes, and initiate CI/CD workflows. Additionally, we fine-tune monitoring with Azure Application Insight for enhanced performance insights. The source code for this project is also mentioned in the description box below. Moving on to the next project, Elevating Jenkins Communication, the Remoting project. The Jenkins Remoting project is all about enhancing Jenkins communication capabilities. It's an endeavor to bolster the Jenkins Remoting library, creating a robust communication layer. This project incorporates a spectrum of features from TCP protocols to efficient data streaming and procedure calls. As a part of this project, you will start on the exciting journey of making Jenkins Remoting compatible with bus technologies like ActiveMQ and RabbitMQ. To succeed in this project, a strong grasp of networking fundamentals, Java, and message queues is your arsenal. Dive in and join us in elevating the way Jenkins communicates with the world. Check out the link mentioned in the description box below for the source code. Moving on to project number 5, Automated Web Application Deployment with AWS, your CD pipeline project. In this project, you will create a seamless continuous delivery pipeline for a compact web application. Your journey begins with the source code management through a version control system. Next, discover the art of configuring a CD pipeline enabling automatic web application deployment whenever your source code undergoes changes. Embracing the power of GitHub, AWS Elastic Beanstalk, AWS Code Build, and AWS Code Pipeline. This project is your gateway to streamlined, efficient software delivery. The source code for this project is linked in the description box below. Moving on to the next project, Containerized Web App Deployment on GKE, Scaling with Docker. This project will help you discover the power of containerization with this project. You will learn how to package a web application as a Docker container image and deploy it on a Google Kubernetes Engine or GKE cluster. You can watch your app scale effortlessly to meet user demands. These hands-on projects cover packaging your web app into a Docker image, uploading it to Artifact Registry, creating a GKE cluster, managing auto-scaling, exposing your app to the world, and seamlessly deploying newer versions. You get to unlock the world of efficient, scalable web app deployment on GKE. The source code for this project is linked in the description box below. Moving on to project number 7, Mastering Version Control with Git. In a world of software development, mastering a version control system is paramount. Version controlling enables you for code tracking, version comparison, seamless switching between versions, and collaborating among developers. Your journey in this project will begin with the fundamental art of saving code in a VCS, taking the scenic route to set up a repository. You can then start on a quest through code history, unraveling the mysteries of version navigation. Navigating through branching, a deceptively intricate task, is next on your path. By the end of this project, you will be fully equipped to conquer Git, one of the most powerful version control system tools in the developer's arsenal. The source code for this project is mentioned in the description box below. Moving on to the next project, Effortless Deployment, Running Applications with Kubernetes. The major focus of this project is to help you harness a straightforward web service that handles user messages, akin to a voicemail system for leaving messages. Your mission, you ask. You get to deploy this application seamlessly with Kubernetes, then Dockerize it. By mastering this fundamental step, you will unlock the power to run your application in Docker containers, simplifying the deployment process. The source code for this project is mentioned in the description box below, so don't forget to check it out. Moving on to the project number 9, Mastering Terraform Project Structure. This project will help you maintain and extend the efficiency of Terraform projects in everyday operations. A well-structured approach is essential. This project unveils the art of organizing Terraform projects based on their purpose and complexity. So harness the power of key Terraform features, including variables, data sources, provisioners, and locals, to craft a streamlined project structure. By the end, your project will effortlessly deploy an Ubuntu 20.04 server on DigitalOcean. Configure an Apache web server and seamlessly point your domain to it. Level up your Terraform game with proper project structuring and practical application. Check out the link mentioned in the description box below for the source code. Moving on to the last project of the day, we have Efficient Selenium Project Development and Execution. In the world of test automation, Selenium projects play a pivotal role. They enable seamless test execution, report analysis, and bug reporting. This proficiency not only accelerates product delivery but also elevates client satisfaction. By the end of this project, you will master the art of building Selenium projects, whether through a Java project or a Maven project, showcasing your ability to deliver high-quality results efficiently. Check out the link mentioned in the description box below for the source code to this project.
DevOps has become an essential skill set for today's technology professionals, with many organizations seeking out talented individuals who can help them build and maintain their infrastructure. If you are looking to become a DevOps engineer, this video is for you. In this video, we'll be covering some of the most common interview questions for a DevOps engineer, as well as some tips on how to answer them successfully. We will cover infrastructure as code and CI/CD pipelines, along with many other important topics. You'll often be asked about your experience with ISA tools like Terraform and Ansible, as well as your knowledge of cloud providers like AWS Google Cloud or Microsoft Azure. We will also discuss tools like Jenkins, Travis CI, or Circle CI, as well as concepts of containerization and Kubernetes. There's a lot to learn and a lot to discuss in our DevOps Engineer Interview Questions video. So without further ado, let's get started. But before moving ahead, let's first understand what is DevOps. Now, DevOps is a set of activities and approaches aimed at enhancing the effectiveness and excellence of software development, delivery, and deployment. It brings together the realms of software development, depth, and information technology operations ops. The main goal of DevOps is to encourage seamless collaboration between development and operations teams through the entire software development lifecycle. It achieves this through the utilization of automation, continuous integration, delivery, and deployment, thereby accelerating the process and minimizing errors in software development. Now, let's explore who is a DevOps engineer. Now, a DevOps engineer is an expert in developing, deploying, and maintaining software systems using DevOps practices. They work closely with IT operations, developers, and stakeholders to ensure efficient software delivery. The responsibilities include implementing automation, continuous integration, and continuous delivery or deployment practices, as well as resolving issues throughout the development process. DevOps engineers are proficient in various tools and technologies, such as source code management systems, build and deployment tools, virtualization, and container technologies. But how exactly to become a DevOps engineer? Now, depending on the business and the individual function, different criteria for becoming a DevOps engineer may exist. However, some specific fundamental skills and certifications are frequently needed or recommended. First is an excellent technical background. Now, DevOps engineers should be well versed in IT operations, system administration, and software development. Second is experience with DevOps tools and methodologies. Now, DevOps engineers should have experience with various DevOps technologies and processes, including version control systems, build and deployment automation, containerization, cloud computing, and monitoring, and logging tools. Third is scripting and automation skills. Now, DevOps engineers should have strong scripting skills and be proficient in using tools such as Buzz, Python, or PowerShell to automate tasks and processes for this cloud computing experience. Now, DevOps engineers should have experience working with cloud platforms such as Amazon Web Services, Microsoft Azure, or Google Cloud Platform, and in the end, certification. Some organizations may require DevOps engineers to hold relevant certifications such as Certified DevOps Engineer, CDE, or Certified Kubernetes Administrator, CKA, or AWS Certified DevOps Engineer Professional. Well, now, let us begin with some really important DevOps interview questions and answers, as we have already covered the roadmap of how to become a DevOps engineer. So the first question that we are coming up with is, how is DevOps different from Agile methodology? Well, DevOps is a culture that allows the development and operation team to work together. This results in continuous development, testing, integration, deployment, and monitoring of software throughout the life cycle. Whereas Agile is a software development methodology that focuses on iterative, incremental, small, and rapid release of software, along with customer feedback. Basically, IT addresses gaps and conflicts between the customer and developers. DevOps addresses gaps and conflicts between the developers and IT operations. Now, the second question is, which are some of the most popular DevOps tools? Well, some of the most popular DevOps tools include Selenium, Puppet, Chef, Git, Jenkins, Ansible, and Docker, which are considered really important in today's world if you want to become a successful DevOps engineer. The third question is, what is the difference between continuous delivery and continuous deployment? Now, we will address this one by one. So, continuous delivery ensures that you can safely deploy onto production. But continuous deployment ensures that every change that passes through automation testing is deployed to production automatically instead of manually. Continuous delivery ensures business applications are delivered as they were expected. Now, continuous deployment makes sure that software development and other processes like release are smooth and faster. Continuously, we also make changes to a production life environment through rigorous automated testing. But when it comes to continuous deployment, there is no explicit approval for a developer to require a developed culture. Question 4 is, what is the role of configuration management in DevOps? Now, configuration management enables management of and changes to multiple systems. Also, it standardizes resource configuration, which in turn manages infrastructure. Also, it helps with the administration and management of multiple servers and maintains the integrity of the entire infrastructure. Next is, what is the role of AWS in DevOps? Well, AWS has the following role in DevOps. First is flexible services. This provides ready-to-use flexible services without the need to install or set up the software. Second is build for scale. You can manage a single instance or scale to thousands using AWS services. Third is automation. AWS lets you automate tasks and processes, giving you more time to innovate. Then comes secure. Using AWS Identity and Access Management, you can set user permissions and policies in your organization. And then comes large partner ecosystem. AWS supports a large ecosystem of partners that integrate with an extended AWS services. Now, if we talk about the sixth question, that is, name 3 important DevOps KPIs. Now, the 3 very important KPIs are as follows. Mean time to failure recovery. This is the average time taken to recover from a failure. Deployment frequency, the frequency in which the deployment occurs. Percentage of failed deployments, the number of times the deployment fails. Now, the 7th question is, what are the benefits of using version control? Here are some of the benefits of using version control. Well, all team members are free to work on any file at any time. With the version control system later on, VCS will allow the team to integrate all of the modifications into a single version. The VCS asks to provide a summary of what was changed. Every time we save a new version of the project, we also get to examine exactly what was modified in the content of the file. As a result, we will be able to see who made what changes to the projects. Now, inside the VCS, all the previous variants and versions are properly stored. We will be able to request any version at any moment, and we will be able to retrieve a snapshot of the entire project at our fingertips. A VCS that is distributed, such as Git, lets all the team members retrieve a complete history of the project. This allows developers or other stakeholders to use the local Git repositories of any of the teammates, even if the main server goes down at any point in time. So the next question is, what is the blue-green deployment pattern? Now, this is a method of continuous deployment that is commonly used to reduce downtime. This is where traffic is transformed from one instance to another. In order to include a fresh version of the code, we must replace the code with the new code version. The new version exists in a green environment, and the old version exists in a blue environment. Now, after making changes to the previous version, we need a new instance from the old one to execute a newer version of the instance. So this was the right answer. Next is, what is continuous testing? Continuous testing constitutes prohibits running of automated tests as part of the software delivery pipeline to provide instant feedback on the business risk present in the most recent release in order to prevent problems in step, switching in software delivery lifecycle, and to allow development teams to receive immediate feedback. Every build is continually tested in this manner. Now, this results in a significant increase in speed in a developer's productivity, as it eliminates the requirement of rerunning all the tests after each update and project rebuilding. Now, let's move to the next question. That is, what is automation testing? Now, test automation or manual test automation is the process of automating a manual procedure in order to test an application or system. Automation testing entails the use of independent testing tools that allow you to develop test scripts that can be run repeatedly without the need for human interaction. The next question is how to automate testing in DevOps lifecycle. Now, developers are obliged to commit all the source code changes to a shared DevOps repository. Every time a change is made in the code, Jenkins, like continuous integration tools, will grab it from this common repository and deploy it for continuous testing, which is done by tools like Selenium. So why is continuous testing important for DevOps? Any modification to the code may be tested immediately with continuous testing. This prevents concerns like quality issues and release delays that might occur whenever big bang testing is delayed until the end of the cycle. In this way, continuous testing allows for high quality and more frequent releases. So the next question is, how do you push a file from your local system to the GitHub repository using Git? Now, first connect the local repository to your remote repository. Now, git remote, add origin, and then you can see the code. And the second step that you need to do is push your file to the remote repository. Next question is, what is the process for reverting a commit that has already been pushed and made public? Now, there are two ways that you can revert a commit. Remove or fix the bad file in a new commit and push it to the remote repository. Then commit it to the remote repository using this command. And second is create a new commit that undoes all the changes that were made in the bad commit. You can use this command for it. Next is explain the difference between git fetch and git pull. Now, git fetch only downloads new data from a report repository, whereas git pull updates current head branch with the latest changes from the remote server. The second difference is git fetch does not integrate any new data into working files, whereas git pull downloads new data and integrates it with the current working files. Git fetch users can run a git fetch at any time to update the remote tracking branches, whereas git pull tries to merge remote changes with your local ones. Now, coming to the next question. Explain the concept of branching in Git. Suppose you are working on an application and you want to add a new feature to the app. You can create a new branch and build a new feature on that branch. By default, you always work on the master branch, and the circles on the branch represent various comments made on the branch. So after you're done with all the changes, you can merge it with the master branch. Next question is, explain the master-slave architecture of Jenkins. Now, Jenkins master pulls the code from the remote GitHub repository every time there is a code commit. It distributes the workload to all the Jenkins layers, and when requested from the Jenkins master, the slaves carry out build, test, and produce test reports. The next question is, which file is used to define dependency in Maven? build.xml, pom.xml, dependency.xml, or version.xml. The correct answer is perm.xml. Next question that we are going to cover is explain the two types of pipelines in Jenkins, along with their syntax. Now, Jenkins provides two ways of developing a pipeline code, scripted and declarative. Now, scripted pipeline is based on GroovyScript as their domain-specific language. One or more node blocks do the core work throughout the entire pipeline. Now, the syntax is execute the pipeline or any of its stages on any available agent, define the build stage, perform steps related to building stage, define the test stage, perform steps related to this test stage, define the deploy stage, and perform steps related to the deploy stage. Now, declarative pipeline provides a simple and friendly syntax to define a pipeline. Here, the pipeline block defines the work done throughout the pipeline. So the syntax that follows is: first, execute the pipeline or any of its stage on any available agent, define the build stage, perform steps related to building stage, then define the test stage, perform steps related to the test stage, define the deploy stage, and perform steps related to the deploy stage. Again, this was the code for declarative pipeline. And the last question for this video is: explain how you can set up a Jenkins job. To create a Jenkins job, we go to the top page of Jenkins, choose the New Job option, and then select Build a Freestyle Software Project. Now, the elements of this freestyle job are optional triggers for controlling when Jenkins builds, optional steps for gathering data from the build, like collecting Javadoc testing results and or archiving artifacts, a build script that actually does the work, or the optional source code management system like Subversion or CBS. Well, there you go. These are some of the most common DevOps interview questions that you might come across while attending an interview. As a DevOps engineer, in-depth knowledge of processes, tools, and relevant technologies is essential, and these DevOps interview questions and answers will help you get some knowledge about some of these aspects. In addition, you must also have a holistic understanding of the products, services, and systems in place. Here's an inspiring success story from one of our satisfied learners who has propelled their career with DevOps. This can help you boost your confidence and make a firm decision in this field. Do watch the video.
Moving on to the top 10 cloud computing projects, we have divided this video into 3 parts. The first part is for beginners. Moving on to the first project for beginners, we have a cloud-based file storage. In this project, you will create a simple cloud-based file storage system similar to a Dropbox or a Google Drive. Users can upload, download, and manage files stored in the cloud. The part to create this project will start by choosing a cloud storage service. Select a cloud storage service provider like AWS S3, Google Cloud Storage, or Azure Blob Storage. The next step is creating an account. Sign up for an account with the chosen cloud provider if you don't already have one. The next step is to set up a bucket or a container. Create a storage bucket or container to store your files. The next step is to develop a web interface. Create a web-based interface for users to interact with your storage system. You can use HTML, CSS, and JavaScript for this. The next step is to implement file upload and download. Add functionality for users to upload and download files to or from their storage bucket using the cloud provider's SDK or API. The next step is user authentication. Implement user authentication to secure access to files. You can use services like Firebase authentication or build one of your own. The next step is testing and deployment. Test your file storage system locally, and once satisfied, deploy it to the cloud. Make it publicly accessible if needed. The key learning points of this project is: you will learn the basics of cloud storage services, file uploading and downloading, and user authentication. Moving on to project number 2, we have a website hosting service. This project involves setting up an essential website on a cloud platform like AWS, Azure, or Google Cloud. You will deploy a static or dynamic website and make it accessible to users worldwide. Let's move on to the path to create this project. The first step is to select a cloud hosting service. Choose a cloud hosting platform like Amazon Web Services, Azure, or Google Cloud. The next step is to design your website. Create the content and design for your website. You can use HTML, CSS, and JavaScript for static websites or web frameworks for dynamic ones. Then register a domain name. Purchase a domain name from a domain registrar, for example GoDaddy, Namecheap, etc. The next step is to configure DNS. Configure the DNS setting to point to your cloud hosting server's IP address. The next step is to set up a virtual server. Create a virtual server instance on your chosen cloud platform, for example AWS EC2, Azure VM, and Google Compute Engine. The next step is to install web server software. Install and configure web server software like Apache on your virtual server. And the last step is to upload website files. Upload your website files to the server. and then you are done with the project. The key learning points of this project: you will learn how to configure a web server, you will deploy web applications and manage domain names, and finally you will ensure high availability. The next project we have for beginners is a cloud-based calculator. Create a simple web-based calculator application and deploy it on a cloud platform like Heroku. Users can perform basic calculations using this calculator. Let's talk about the path to create this project. You will start by selecting a cloud platform. Choose a cloud platform like Heroku, AWS or Azure for deployment. Then develop the calculator. Create a simple web-based calculator. You can use HTML, CSS and JavaScript for this. Then set up a development environment. Install necessary development tools and libraries on your local machine. Then move ahead with version control. Use version control systems like Git to manage your project. Then create a cloud account. Sign up for an account with your chosen cloud platform. Then comes the deployment part. Deploy your calculator application to the cloud platform of your choice. For Heroku, this might involve pushing your code to a Git repository. And then comes the testing part. Ensure that the calculator functions correctly on the cloud server. Let's talk about the key learning points of this project. You will gain experience in setting up cloud server environments, deploying web applications, and understanding server-client interactions. Moving on to intermediate level projects. These projects are for people with decent knowledge of cloud computing basics. The first project we have in this category is an IoT data analytics project. Build a system that collects data from IoT devices, sensors, smart devices, etc. and stores it in cloud databases, for example AWS DynamoDB or Azure Cosmos database. Implement analytics to gain insights from the collected data. Let's talk about the path to create this project. The first step is IoT device setup. Set up IoT devices or sensors to collect data. Then choose a cloud database. Select a cloud database service, for example AWS Dynamo database, Azure Cosmos database for data storage. Then comes the data ingestion part. Write code to send data from IoT devices to the cloud database. Then comes data analytics. Implement data analytics tools or scripts to analyze the collected data. Then comes data visualization. Create visualizations to present insights from the data using tools like AWS QuickSight or data visualizations libraries. And then the last part is monitoring and scaling. Implement monitoring and scaling mechanisms to handle increased data volumes. So let's talk about the key learning points of this project. You will explore IoT data ingestion, cloud database management, data analytics, and of course data visualization. Moving on to the next project, we have a video streaming service. So you will create a video streaming service where users can upload and stream videos from the cloud. Implement features like video encoding, content delivery, and user authentication. Let's talk about the path to create this project. You will start by selecting cloud services. Choose cloud services for video storage, for example AWS S3. For encoding, you can choose AWS Elastic Transcoder, and for content delivery, you can choose AWS CloudFront. The next step is to design the application. Plan the architecture of your video streaming platform, including user interfaces for uploading and streaming. The next step is user authentication. Implement user authentication using services like AWS Cognito. Then comes the video uploading part. Allow users to upload videos to the cloud storage. And then comes the video encoding. Implement video encoding to create different quality versions of uploaded videos. Then comes the content delivery. Use a content delivery network or CDN to distribute videos efficiently to the users. And the last step is testing and scalability. Test video streaming and ensure it scales to handle concurrent users and varying network conditions. Let's talk about the key learning points for this project. You will learn about video processing, content delivery networks, and secure user access control. Moving on to the next project, we have cloud-based e-commerce website. Build an e-commerce platform hosted on cloud. Develop features like product listing, shopping carts, and secure payment processing. Let's talk about the path to create this project. You will start by selecting cloud platform. Choose a cloud platform, for example AWS or Azure, to host your e-commerce application. Then comes the e-commerce framework. Choose an e-commerce framework, for example WooCommerce or Shopify, or build a custom solution. Then comes the product listings part. Add product listings and descriptions with images. Then comes the shopping cart. Implement a shopping cart functionality for users to add products. Then comes the secure payment processing. Set up secure payment processing using payment gateways like Stripe or PayPal. Then comes the user authentication part. Implement user authentication for customer accounts. And finally, the testing and security. Thoroughly test your e-commerce website, ensuring it's secure and capable of handling transactions. What are the key points of this project? You will gain experience in building scalable web applications, handling online transactions securely, and managing customer data. Talking about advanced level cloud computing projects. For advanced level cloud computing projects, you should master cloud infrastructure and cloud services. The first advanced level project we have for today is machine learning with cloud. Develop a machine learning model and deploy it on a cloud server for scalable processing. This project involves working with large data sets and real-time data analysis. The first step is machine learning model. Develop a machine learning model using libraries like TensorFlow or scikit-learn. Then comes the data preparation part. Prepare and clean the data for training and testing. Then choose a cloud machine learning service. Select a cloud machine learning service, for example, AWS SageMaker, Google AI Platform, and etc. Then comes the model deployment part. Deploy your machine learning model on the cloud platform. And finally, the scalability. Ensure the model can handle real-time predictions and scale as needed. Let's talk about the key learning points of this project. You will delve into machine learning, cloud-based data processing, and model deployment. The next project we have in this list is the cloud-based virtual desktop. Create a system that allows users to access virtualized desktop environments hosted on the cloud. This project focuses on remote desktop solutions. Talking about the path to create this project, you should start by selecting cloud service. Choose a cloud service for virtual desktop. For example, Amazon Workspace, Windows Virtual Desktop, or Azure. Then comes the configuration part. Configure virtual desktop instances with desired specifications. User management. Create and manage user accounts for accessing virtual desktops. Security. Implement security measures for data protection during remote desktop access. Then comes the access control part. Set up access control policies to restrict user permissions. And lastly, testing. Test the remote desktop access from different devices and locations. Talking about the key learning points of this project, you'll learn about virtualization, remote desktop technologies, and user management in a cloud-based context. Moving on to the third advanced level cloud project, we have a cloud gaming service. Build a cloud-based gaming service similar to Google Stadia. This project involves GPU virtualization, low latency streaming, and multiplayer game server management. Talking about the path to create this project, you should start by selecting cloud infrastructure. Choose a cloud infrastructure. You can either choose AWS or Azure for hosting game servers. Then comes the game server setup. Set up game servers for hosting games. Then comes the low latency streaming. Implement low latency streaming technologies for gameplay. Then comes the multiplayer support. Add multiplayer support for users to play together. Then comes the user management. Create user accounts and manage players' profiles. And finally comes load balancing. Implement load balancing to handle increased player loads. Talking about the key learning points of this project, you will explore cloud-based gaming infrastructure, server management, and real-time multiplayer networking. Moving on to the last cloud computing project, we have a healthcare data management system. Develop a cloud-based system for storing and managing healthcare-related data such as patient records. Ensure compliance with healthcare industry standards, for example, HIPAA. Talking about the path to create this project, you should start by ensuring compliance with healthcare industry standards. HIPAA compliance. Understand and adhere to HIPAA compliance regulations. Cloud platform selection. Choose a HIPAA compliant cloud platform, for example, AWS Healthcare APIs and Azure for healthcare. Then comes the data storage part. Create a secure cloud-based data storage system for healthcare records. Then comes the access control. Implement strict access controls and encryption for data security. Then comes the audit trials. Maintain audit trials for data access and modifications. And then at last comes the user training. Ensure staff are trained on HIPAA compliance and data handling protocols. Talking about the key learning points of this project, you will gain expertise in cloud security, data privacy, and compliance while addressing real-world healthcare data challenges. These projects provide a progressive learning path allowing individuals to start with basic cloud concepts and gradually advance to more complex and impactful cloud computing applications. Each project offers valuable experience and skills that can be applied to real-life scenarios and career development in the cloud computing field.
Welcome to our video on Cloud Engineer interview questions. Cloud computing has revolutionized the way businesses operate, and as a result, the demand for skilled cloud engineers is on the rise. If you're aspiring to become a cloud engineer, so you have come to the right place. In this video, we'll be discussing some of the most commonly asked interview questions for cloud engineers, providing you with valuable insights and tips on how to answer them effectively. So let's dive right in. One of the key areas you will be quizzed on is your knowledge of cloud providers. Cloud giants like Amazon Web Services, Google Cloud Platform, and Microsoft Azure dominate the industry along with the knowledge of various services provided by these cloud platforms is crucial. Employers will want to know about your experience with these platforms, such as deploying and managing resources, configuring security, and optimizing performances. Cloud engineers often collaborate closely with DevOps teams, so basic knowledge of DevOps and its related concepts is essential. Now, let's add some solid data to support the significance of cloud engineering. According to a recent survey by RightScale, 94% of enterprises are using cloud infrastructure in some form. And according to recent data from Glassdoor, the average base pay for cloud engineers is around $115,000 per year in the USA. So, in our Cloud Engineer interview questions video, we'll cover these important topics and more. So, without any further delay, let's embark on this knowledge-packed journey and get started. Now, let's get started with the video. But before dealing with the questions, let's first understand what is cloud computing. Cloud computing is the delivery of computing services over the internet. It provides on-demand access to shared resources like servers and storage. Users can scale resources as needed and only pay for what they use. It offers benefits like cost efficiency, scalability, and accessibility. There are different service models like infrastructure as a service, platform as a service, and software as a service. However, it also comes with considerations like security and internet connectivity. Now, let's understand the role of a cloud engineer. Well, a cloud engineer is a professional responsible for designing, implementing, and managing cloud-based infrastructure and services. They specialize in deploying and maintaining cloud computing solutions to meet the specific needs of organizations. Well, the role of a cloud engineer involves cloud architecture design. That means accessing business requirements and designing cloud-based solutions that align with organizational goals. This includes determining the appropriate cloud service models and selecting the right cloud provider. Second is cloud infrastructure deployment. This involves implementing and configuring the necessary cloud infrastructure components such as virtual machines, storage, networks, and security measures. This involves setting up and optimizing cloud resources for performance, scalability, and reliability. Then comes automation and orchestration. Developing automation scripts and tools to streamline cloud deployment, management, and monitoring processes comes under this. This includes using infrastructure as code technique to automate infrastructure provisioning and configuration. Then comes cloud security and compliance. This ensures the security and compliance of cloud environments by implementing appropriate security measures, access controls, and encryption protocols. This may involve managing identity and access management policies, implementing data encryption, and monitoring for potential vulnerabilities. Then comes performance monitoring and optimization. Monitoring cloud infrastructure performance, identifying bottlenecks or issues, and optimizing resource allocation for efficient operation comes under this. This includes analyzing cloud usage patterns and making recommendations for cost optimization. And after this comes collaboration and support. Collaborating with cross-functional teams such as developers, system administrators, and network engineers to provide support and resolve any cloud-related issues. Cloud engineer may also assist in training and guiding teams on cloud best practices. Well, cloud engineers typically possess a combination of technical skills, including knowledge of cloud platforms such as Amazon Web Services, Microsoft Azure, or Google Cloud Platform, proficiency in scripting or programming languages, understanding of networking concepts, and experience with infrastructure and application deployment. But remember, becoming a cloud engineer is a journey that requires dedication, hands on experience, and a commitment to continuous learning. Now that we have an overview of how to become a cloud engineer, let's focus on how to prepare for it. Here are some top cloud engineer interview questions and answers that will help you prepare better for your interview. Let's start with the basic level first. So, now that we have an overview of how to become a cloud engineer, let's focus on how to prepare for it. Here are some top cloud engineer interview questions and answers that will help you prepare better for your interview. So, let's start with the basic level first. Question 1 is, what is cloud? List some different versions of cloud. So the answer is, cloud computing refers to the integration of networks, hardware, services, storage, and interfaces for delivering computing as a service. It involves three primary users: end users, cloud service providers, and business management users. Different types of cloud deployment exist, including multi-cloud, public cloud, private cloud, and hybrid cloud. Coming to the question number 2 is, what is meant by function as a service? So the correct answer is, function as a service offers users a platform where they can develop, manage, and run their applications without worrying about the infrastructure's maintenance. Coming to the question number 3 is, define the various cloud storage levels. Well, the correct answer is, level of data storage that cloud storage device mechanisms offer are files, that batches of data grouped into files located in folders, blocks. The smallest unit of data that can be accessed individually is known as a block, the lowest level of storage and closest to the hardware. Data sets. These are data sets that have been divided and organized into a tabular, delimited, or recorded format. Objects refers to the data and the related metadata organized as web-based resources. Now coming to the question number 4 is, what are some of the key features of cloud computing? Well, the answer is agility. Helps in quick and inexpensive reprovisioning of resources. Location independence. This means that the resources can be accessed from anywhere. Multi-tenancy. The resources are shared amongst a large group of users. Reliability. Resources and computation can be dependable for accessibility. And scalability. Dynamic provisioning of data helps in scaling. Question number 5 is, what do you mean by cloud delivery models? Well, cloud delivery models are models that represent the computing environments. These are as follows. Infrastructure as a service is the delivery of services including an operating system, storage, networking, and various utility software elements on a request basis. Platform as a service. Platform as a service is a mechanism for combining infrastructure as a service with an abstracted set of middleware services, software development, and deployment tools. These allow the organizations to have a consistent way to create and deploy applications on a cloud or on-premises environment. Software as a service is a business application created and hosted by a provider in a multi-tenant model. And function as a service gives a platform for customers to build, manage, and run app functionalities without the difficulty of maintaining infrastructure. One can thus achieve a serverless architecture. Coming to the question number 6 is, what are the main constituents that are part of the cloud ecosystem? Well, the parts of the cloud ecosystem that determine how you view the cloud architecture are cloud consumers, direct customers, and cloud service providers. Now, coming to the question number 7, that is, who are the cloud service providers in a cloud ecosystem? Well, the answer is, cloud service providers are the commercial vendors or companies that create their own capabilities. The commercial vendors sell their services to cloud consumers. In contrast to this, a company might decide to become an internal cloud service provider to its own partners, employees, and customers, either as an internal service or as a profit center. Cloud service providers also create applications or services for such environments. Question 8 is, describe the cloud computing architecture. The answer is, the architecture of cloud computing encompasses the interconnected components that form a cloud model. This illustrates the relationships between different cloud services catering to the requirement of businesses. On the left side, the cloud service consumer represents the various ways in which cloud services are utilized. Regardless of specific user demands, it is crucial to assemble the appropriate service capable of supporting both internal and external users. Consumer management should enable the swift availability of services to meet evolving business needs. This category includes applications, middleware, infrastructure, and services built on premises computing models. Additionally, the model highlights the role of a cloud auditor, either internal or external, responsible for overseeing the consumer group to ensure compliance with obligations. Question 9 is, who are the cloud consumers in a cloud ecosystem? Well, the correct answer is the individuals and groups within your business unit that use different types of cloud services to get a task accomplished. A cloud consumer could be a developer using compute services from a public cloud. Question 10 is, who are the direct customer in a cloud ecosystem? Well, the answer is users who often take advantage of services that your business has created within a cloud environment. The end users of your service have no idea that you're using a public or private cloud. As long as the users are concerned, they're interacting directly with the services and value. Now, let's move to the intermediate level of cloud engineer interview questions. The question 1 in this category is, what are cloud enabling technologies? There are several areas of technology that contribute to modern day cloud based platforms. These are known as cloud enabling technologies. Some of the cloud enabling technologies are broadband network and internet architecture, data center technology, virtualization technology, web technology, multi tenant technology, and service technology. Question 2 is, what are serverless components in cloud computing? Well, the answer is serverless components in cloud computing allows the building of applications to take place without the complexity of managing the infrastructure. One can write code without having provision to a server. Serverless machines take care of virtual machines and container management. Multi-threading, hardware allocating are also taken care of by the serverless components. Question 3 is, what is an API gateway? Well, an API gateway allows multiple APIs to act together as a single gateway to provide a uniform experience to the user. In this, each API call is processed reliably. The API gateway manages the APIs centrally and provides enterprise-grade security. Common tasks of the API services can be handled by the API gateway. These tasks include services like statistics, rate limiting, and user authentication. Question 4 is, what do you mean by encapsulation in cloud computing? Well, a container is packaged software code along with all of its dependencies so that it can run consistently across clouds and on premises. This packaging up of code is often called encapsulation. Encapsulating code is important for developers as they don't have to develop code based on each individual environment. Question 5 is, what are the different data centers deployed for cloud computing? So cloud computing is made up of various data centers put together in a grid form. It consists of the data centers like containerized data center and low density data center. Question 6 is, what are containerized data centers? So the containerized data centers are the traditional data centers that allow a high level of customizations with servers, mainframes, and other resources. These require planning, cooling, networking, and power to access and work. Question 7 is, what are low density data centers? Now, the low density data centers are optimized to give high performance. The space constraint is being removed and there is an increased density in these data centers. One drawback it has is that with high density, the heat issue also creeps in. These data centers are quite suitable to develop the cloud infrastructure. Question 8 is, what are cloud native applications? Well, cloud native is a software framework designed with containers, microservices, dynamic orchestration, and also continuous delivery of software. Every part of the cloud native application has within it its own container and is dynamically orchestrated with other containers to optimize the way the resources are utilized. Now the question number 9 is, what do you mean by rate limiting? Well, rate limiting is a way to limit the network traffic. Rate limiting runs within the app rather than the server. It typically tracks the IP addresses and the time between each request. It can eliminate certain suspicious and malicious activities. Bots that impact a website can also be stopped by rate limiting. This protects against API overuse, which is important to prevent. So now that we have covered basics and intermediate level, let's move on to the advanced level. Question 1 is, what is Cloud Usage Monitor? The Cloud Usage Monitor is an autonomous lightweight software application that is responsible for gathering and processing the IT resource utilization data. Cloud usage monitors may exist in various formats depending on the kind of usage metrics. These are designed to gather and how the usage data needs to be collected. The three typical agent-based implementation formats are monitoring agent, resource agent, and polling agent. Question 2 is, how does the monitoring agent monitor cloud usage? Well, a monitoring agent is a service agent that exists as an intermediate and an event-driven application that resides alongside the current communication channels. It examines and transparently monitors data flows. The monitoring agent is frequently used to gauge message metrics as well as network traffic. Question 3 is, how does the resource agent monitor the cloud usage? Well, a processing module that is used to collect usage data by having event-driven interactions with the specialized resource software is a resource agent. This agent is applied to check the usage metrics based on predefined observable events at the resource software level like initiating, suspending, resuming, and vertical scaling. Question 4 is, how does the polling agent monitor cloud usage? Now, a polling agent is a processing component that collects information about how cloud services are used by polling IT resources. The polling agent has also been used to promptly track the uptime and downtime of IT resources. Question 5 is, what are microservices? Well, microservices is a process of developing applications that consist of code that is independent of each other and of the underlying developing platform. Each microservice runs a unique process and communicates through well-defined and standardized APIs once created. These services are defined in the form of a catalog so that developers can easily locate the right service and also understand the governance rules of usage. Question 6 is, why are microservices important for a true cloud environment? The reasons why microservices are so important for a true cloud environment is because of these four key benefits. Each microservice is built to serve a specific and limited purpose, and hence application development is simplified. Small development teams can then focus on writing code for some of the narrowly defined and easily understood functions. Second, code changes will be smaller and less complex than with a complex integrated application, making it easier and faster to make changes, whether to fix a problem or to upgrade service with new requirements. Third is scalability. Now, scalability makes it easier to deploy an additional instance of a service or change that service as needs evolve. Fourth, microservices are fully tested and validated. When new applications leverage existing microservices, developers can assume the integrity of the new application without the need of continual testing. Question 7 is, what is meant by edge computing? So edge and cloud are complementary. These are both parts of a broader concept called the distributed cloud. A majority of those pursuing edge computing strategies are now viewing edge as part of their overall cloud strategy. Edge computing, unlike cloud computing, is all about the physical location and issues related to latency. Cloud and edge combines the strengths of a centralized system along with the advantages of distributed operations at the physical location where things and people can connect. In IoT scenarios, the edge is very common. Cloud is different from the edge in that it has never been about location. As opposed, it has always been about the independence of location. The popular scenarios are where you have cloud and edge together, and the cloud provides control to run and defines the architecture for what is out at the edge. Question 8 is, how does resource replication take place in cloud computing? Well, resource replication is the creation of multiple instances of the same IT resource. It is typically performed when an IT resource's availability and performance are needed to be enhanced. The virtualization technology is adopted to implement the resource replication mechanism in order to replicate the cloud-based IT resources. Question 9 is, what are the advantages of serverless computing? Well, serverless computing has the following advantages. It is cost effective and the operations on serverless computing are simplified. Serverless computing helps boost productivity and offers scaling options, which involves zero server management. Question 10 is, what are the disadvantages of serverless computing? Well, serverless code can cause response latency. It is not ideal for high computing operations because of resource limitations. Also, for serverless computing, the responsibility of security comes under the service company and not the consumer, which might be more vulnerable. And debugging serverless code is a bit more challenging. So, there you go. These are some of the most common cloud engineer interview questions that you might come across while giving an interview. Also, here's an inspiring success story from a satisfied learners who have propelled their careers with cloud computing. This can help you boost your confidence and help you make a firm decision in this field.
Now that's a wrap on our cloud computing full course. We hope you gained valuable insights and are ready to take next steps in your cloud journey. Don't forget to like, share and subscribe for more helpful content. See you in the next video. Hi there, if you like this video, subscribe to Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, you can check the description box below.